And then a warning.
Hey, how about that earthquake warning?
Earthquake. Don't get too many of those.
Mexico City yesterday, and 10 minutes later they had an earthquake.
Really?
Yeah, it was all over Twitter.
How'd they do that?
I posted on Twitter. I was like, it's probably a scheme by the cartels and the government, you know, to clear traffic out. Yep. Earthquake warning, Mexico City.
They're warning for that, and you know. Where'd that come from?
Hey, we're live.
Well, these folders are there. I think we're good on orange. Maybe we're going to be cutting short. No.
The orange is the last one that goes to.
Are you supposed to just sit down and wait?
Yeah, I think so.
Oh, okay.
We're live right now.
What's up?
We got it.
Work. Awesome. What kind of quality is it? I mean,
That's it right there. That's I'm streaming from there, and then that's quality.
you're the man.
I just got to work out once we get audio going. I'll adjust that down a little bit. Might be a little bit too much.
Yeah, in this room it may echo a lot. I don't know. They got pretty good.
So yeah, you can that link that I sent you. Go ahead, throw it up again.
Okay.
Everybody's going to be here. Is going to be here.
Right.
Oh, very good. Yeah. Yeah. Good time. Fill up so fast.
I mean, even lighting right here is not there.
Yeah. What's going on?
Just to clarify. That's why I put it on church. Because we put the back row.
So what's that?
We're keeping you busy.
Oh my gosh, I got 4 things going at once. I need a tripod out of it. Drove a Hyundai Santa Fe white. Got mud on the tires right outside. It's a rental car because my wife's car's in the shop. And I'm gonna go run and get that tripod. It's right there in the back. I might have to put that camera on the tripod.
What is it again?
It's just a tripod.
I'm in the car.
It's that white Honda or Hyundai Santa Fe.
Sit back here with us.
Sit in the back.
Here, you can sit right here. I'll sit next to Hayden.
Chris, go sit here.
I doubt Chris is. I'm glad he's able to cover everything.
Oh my God. I swear he just went totally black and I got this load so the hard drive crashed. I think what had happened, I bought a 2 terabyte hard drive. Went to the store. I didn't want to. So erased everything and then reboot it. Yeah.
It's hot. It's hot.
Yeah, I've been snoring here. Sure. I apologize for Green Street. Sorry. Exactly 132. I went home.
Eat like you mean it. Is that yours? Eat
I
like you
haven't
mean
had
it.
time to do anything. Waited a half hour for that biscuit. It's about an hour and a half old. Yeah.
How are we looking? Awesome. Okay.
We're gonna be all right. Just adjust the audio a little bit. We'll be
Yeah.
good.
Okay. We need to get a copy of this.
Yeah, that's what I said. I've got one for clear on the phone, so will that work?
I just want
They got some.
get started at 5.
Yeah.
Trying to tell everybody what we have some bathrooms are.
Yeah.
Figure that
So I need to make sure that is good.
I've got my high-low video, but I gotta give it to that guy up there so he can make one.
Yeah, sometime as soon as you have a chance that you. As soon as you have a chance that,
No, I
just
forgot
get up
to
there.
sit my bad.
Mark Darwin, you know Mark, right? He's kind of running some of the AV stuff, but I don't know. We'll put the guy from here, Jason, is the guy that's been coming in and helping us out. So might find him. What I'll do is I'll try and find him, send him to you. It's yours. Oh,
You can screen this. We're live right now.
cool.
That should be okay. Tim went to go grab his tripod and I'm gonna sit that camera up there.
Oh, that's weird. You're getting the mirror image on there.
Uh-huh.
I thought, wait a minute.
That's how it works.
Yeah. Hey, Bob. Is this Frank next to you? No, this is John. Oh,
Hey, Kenny.
hey.
It's a good guest, John. How are you?
Busy bee. Just gotta get somebody to do me sound check.
We're not moving anything real fast, but we're making a few things happen.
That's good. Well, I'm trying to make everything happen today, and then I'm going to drink.
Where are you going tonight?
Unfortunately, I got to drive back to Louisville before. I wish I'd stayed over tonight, and then I would just like, no, tonight.
You come to Franklin?
Well, actually, that's not a bad idea.
We're gonna go to the Legion.
Yeah.
What have you been up to, man? Yeah, The road.
Yeah, you're ready for it. I know. Guys are all Jones.
Nah, I was worried. I got to go to Green Bay next week. And in 2 weeks, I'll be at Challenge, South Carolina for a week. And then we'll talk about making me work down in Mobile for a month. I'm not sure. I wish I had some tape.
Yeah. How tall is this guy?
I mean, that'll be good.
Just get up over there. What about taking
There you
this?
go.
There you go.
Yeah, but I got to keep everybody from hitting it.
What if you took this down about halfway and set it on the table over there and just used it?
There you go.
See, I'm good for something. I'm a guy I'm with the government. I'm here to get you.
That'd probably be high enough.
Yeah. I'll get to a place here. See what that does for you.
There we go. What do you think?
Good morning.
Hi.
How's everybody? Oh, come on. Good morning. Ah, that's better. I know some of you are not awake yet. That's all right. And I apologize for the long line waiting to get in and get registered, but we got everybody in and some folks are still coming in, but we want to try to stay on time today and get you through the day. It's a long day, and I know some of you are probably wanting to watch basketball. You know, there's this little team called Kentucky that's going to play today. We thought about throwing it up on the big screen, you know, like just stop the seminar in the middle of it. But that's not going to happen. I'm sorry. But anyway, thank you so much for coming. My name is Chris Allen. I'm the weather director at WBKO here in Bowling Green, but I'm also the chapter president of the Ohio Valley National Weather Association. And that's the local chapter of the National Weather Association. And it's a local chapter that takes in all of Kentucky and parts of southern Indiana, specifically the Louisville National Weather Service area, including parts of Paducah, Jackson, Nashville. How many of you are from Kentucky that are here? All right, Tennessee? A few from Tennessee, good, thank you. How about southern Indiana? All right, thank you so much, great. How about Ohio? Anybody from Ohio? What about any other states? Where are you from? Southern Illinois, wow, we've got pretty good coverage here. Thank you so much for coming. So, did everybody get a yellow folder when you came in? Anybody not get a yellow folder? This lady right here does not have a yellow folder, and a couple of folks over here. So we'll make sure you get one. Inside your yellow folder is the agenda for the day. If you have not seen that online, we have a copy for you, and it's been updated just a little bit from probably what you saw online when you registered. And there's also a forum info and satisfaction survey. Now, if you would, throughout the day, preferably at the end of the day, if you would take the time to fill that out, just ask you a few questions about the seminar, the presentations. If there's something that you feel like should be a part of this presentation that you did not see today, but you would like to see in future presentations, then be sure and make that known, okay? Because your feedback is important. We want this to be a great seminar. We want this to be informative, but we don't want you to get, you know, so bored out of your gourd that you never want to come back. We're going to try to make this as entertaining, as informative as possible. But we also want to design this in a way to where it's not just a bunch of weather geek talk. You know, sometimes when we do these seminars, it's shop talk. It's weather people talking to other weather people about the weather. And we wanted to open this up this time to make it where it's about the general public and about making them better informed about weather and weather preparedness. So that's what this is designed to do. So amongst the audience today is not just weather service people, television or media weather people, or those in emergency management. There's, you know, Joe Q public that's here, that's trying to learn, and even some younger people will be showing up. There's some Western students that are here. There's different people that are wanting to learn more about the weather, and that's why we invited them to this forum. So it's what you're going to hear today is not going to be highbrow, deep, synoptic or operational meteorology. Some of it will be that, but then most of it's going to be pretty understandable stuff, or at least that's the way it's designed to be. So at the end, we're going to have, of course, these tables will be filled with some of us that will be taking your questions. So think about the questions you want to ask, and at the end of the day, we'll be glad to answer those questions. The National Corvette Museum, a great setting for this. A reminder that your badge, hopefully you've got a badge with your name on it. That badge will get you in and out. It will not get you through to tour the museum unless you first go to the ticket office that you saw as you came in, and you'll get a discount on the price of admission to go through the museum. So be sure and keep that badge on you at all times, and then you can go to the ticket counter at any time you want to. And this is going to be real informal. So anytime you want to get up, you need to go to the restrooms. The restrooms are out of the exits, and you go back in front of the ticket counter. There are restrooms right around that corner to right about here as you first come in the door. And then there are restrooms that you'll see out in the main lobby area, the atrium, where they have all the, they'll usually have the Corvettes parked out there. There are men's and women's restrooms out there. So you have your options as to where you need to go. All right. So I think that covers all of anything I needed to say to start that I can think of. Be sure and hold on to your surveys and fill those out at the end. All of our sponsors are on there, including the National Corvette Museum, the Ohio Valley chapter of the National Weather Association, LG&E, which is sponsoring our lunch today. We get lunch. And by the way, on those back tables, there will be coffee and water and anything at any time you just, in any session, if you need to get up, go to the restroom, or get up and get a refreshment, feel fine. Don't feel like this is so, you know, such a formal affair that you can't get up and get up and go if you need to. So help yourself with that. So we thank LG&E for sponsoring the lunch today. Midland Weather Radio is here. I saw Bruce Thomas come in. He's going to be here in a few minutes. Mean Motion Media. Chris Conley has got live streaming set up for this today because I actually received a few emails from some people that could not make it here, but have special needs. And they would love to be here, but because of their special needs situation, they're not able to be here, of course, but they're watching us via live stream. So I thank Chris Conley and Mean Motion Media for getting that set up. NOAA Weather Ready Nation, of course, this is all about being a weather ready nation. An initiative from NOAA and the National Weather Service is to do more of these types of forums and open them to the public so that they are better informed as to severe weather and preparedness. The National Weather Service offices, Louisville, Nashville, Paducah, Jackson, Memphis, all involved in this event today. Kentucky Emergency Management and the Kentucky Weather Preparedness Committee. So let's give them all a hand for their participation today. Now we will be giving away, for those of you that can stay until the very end, but you do have to be present, we brought some weather radios to give away. So we'll take care of that through the registration, and we'll get you going, and we'll give away some weather radios at the end of the day after we do our table session, our discussion. All right, first up, the man who I want to give right here public credit for helping really do the heavy lifting for this event, making sure all the presenters are here, making sure all their presentations are ready to go. And he really spent a lot of hours organizing this event and making sure that it comes off today and that you are here. He also cooked all the food for lunch. He stayed up all night for that. I thought that would get a laugh. I mean, oh, there you go. Thank you very much. Just appease me. It's a lot better. It'll go a lot faster that way. But anyway, ladies and gentlemen, the warning coordinating meteorologist at the National Weather Service office in Louisville, Kentucky. Please make welcome Mr. Joe Sullivan.
Thanks, Chris. And now you know who to blame if this doesn't go off well today. Go ahead and bring up the, where'd it go? See, it already started. Mark, do you have my presentation? That is not my presentation. Go back into PowerPoint. There, just click on the PowerPoint down there. I can get it. I've got the mouse here. Okay. There we go. That's why I always, see, I pretty much work solo. I don't have an AV guy when I go out and do my talk. So this is a real short presentation. I did want to just let you know what Weather Ready Nation is all about. It's what I've been doing for the last 28 years of my career, which is essentially trying to help people help themselves. And it all comes down to just one thing, our mission, protection of lives and property. You can go into meteorology for a lot of different reasons. You can go in because you want to be on television like Chris, or Shane is here. And I mean, there's how many of you are on television right now, or aspire to be on television? Because we have a lot of Met students here. Okay, so I did TV for a year, and I got out because I had such a wonderful TV face, and I actually enjoy what I do behind the scenes. I'm much more of a behind the scenes type of person. And trying to find the sweet spot where I don't, I guess I'm going to get behind the speakers back here. So anyway, you can read the slides as well as I can. I don't like reading slides to folks, but what it really boils down to is getting partnerships, and that's the ambassador program. And that's what we're really trying to promote today, is getting more people to spread the message. And then it also has to do with situation awareness, because when you get to severe weather, it all boils down to just a couple of really simple things. You need to prepare in advance. Then you need to monitor when weather is starting to get nasty, whether it's summer, winter, etc. And then you have to react and respond appropriately, whatever conditions you have. And then, if you really want to be a weather-ready nation, you don't just do it once, you do it every time. Whether it's 24 inches of snow on the interstate or 8 inches of rain on the Ohio River. You have to be ready for whatever happens. And that really comes down to something we call situation awareness. And if you've never Googled situation awareness on the internet, you get all sorts of really funny memes. You get things like this. It's just people not paying attention and getting into bad situations. There's things with the hunting or doing your pretty stuff on the Serengeti and all these kinds of photographs. But what most of them say, if you look at them, they call it situational awareness. And there is a difference between situation and situational awareness. And the best example I've seen of that is from this report I did.
And the first thing I'm doing is I'm catching the sidelines and looking for an exit.
I see the exit sign too. I'm not worried. I mean, you were shot. People do all kinds of weird and amazing stuff when they're scared.
I can tell you the license plate numbers of all 6 cars outside. I can tell you there are waitresses left-handed, and the guy sitting up at the counter weighs 215 pounds and knows how to handle himself. I know the best place to look for a gun is the cab of the gray truck outside. And at this altitude, I can run flat out for a half mile before my hands start shaking. And why would I know that?
Okay, so why would he know all these things? Well, if you've seen the movie, you know why. Because he's a spy. And he's had the training, and he's just doing it without even thinking. And really, that's what it gets down to when we're talking about severe weather. If you wait until the sirens sound and then start looking for your tornado shelter, you waited way too long. She waited until she was inside the restaurant to look for the exits. Well, that's fine if there's a fire, she knows where to go, but if there's a myriad of other things that can happen, he's the one that's really ready. Those of you that are following me afterward, you might end up having to stand up here just to keep the feedback from occurring. So everything that's on this little logo chart here is the type of severe weather that can affect you somewhere in Kentucky or Tennessee today, tomorrow, next week. Whether it's tornadoes or just regular thunderstorms, around a drought, heat. You know, people are dying every year because of usually small children being left in their cars. And I don't think I have to even talk about winter weather right now. We had 23 fatalities at last count in the state of Kentucky from winter weather that we had in the last month. So it's not just about tornadoes. It's not just about floods. It's not just about severe convective weather. We have heat, cold, winter, and we don't have too many rip currents on the Ohio River, but we actually did have a flood fatality up in Louisville when somebody tried to jump over just a little egress into the Ohio and was washed away. So this is what it's all about. It's all about saving lives. And as the population of this country gets larger and larger, and we talk about global warming and climate change, I'm not going to say that those things are happening or not happening, but the population of the planet is getting larger. So every time there's an extreme weather event, there's a greater risk that somebody's going to get hurt from it. And that's what the whole Weather Ready Nation Ambassador Program is about. I hope at least some of you will check it out before the day ends. The handouts you have the URLs on there. You can look at them. And with that, I'm going to pass the baton, or the microphone, the back-feeding microphone, on to Jane Marie Wicks. Jane Marie is a forecaster in Jackson. She started with the National Weather Service as a volunteer up in our office in Louisville. What year was that, Jane? 2009. We were having dinner last night. I couldn't believe she's so many years have flown by since she started doing that. So she went up to northern Michigan, to Marquette, Michigan, for 3 years, which yeah, cold. Lots of snow. The snow is taller than she is. She's only 5 feet tall. So now she's very glad to be back down in Bluegrass State. So without further ado, Jane Marie Wicks.
Now, because I am short, I will be standing up here. Do we have the lightning safety talk? Good there. And I do want to mention, I am the timekeeper today, so if anybody is presenting, sorry, I will give you a 5 for a 5-minute warning, and then whenever it's time, I'm just going to cut you off. If you keep talking, I may charge the stage, so just watch out.
I want to see that.
The one on the, yes. And there's also a link, I think, that was brought up. If not, we can always click on it later. Okay, so I'm going to be talking about lightning safety today. Lightning is one of those things I think we underrate a lot. We don't warn based on lightning, but any thunderstorm is a potential killer because it does harbor lightning death potential. To go through this talk, we're actually just going to go through an overview of lightning. We're going to talk about safety aspects of lightning if you're outdoors or you're indoors. And then we're going to go through what we call Lightning Safety Toolkit. That's a volunteer recognition program for local counties and communities. It creates awareness of the dangers of lightning at the outdoor recreational facilities, and it provides the community with safety measures to take in the threat of lightning. So I know a lot of the EMs probably know a lot about this, but especially for some of the larger venues as we go into the summertime, if we have the threat of lightning, these are good things to keep in mind and make sure the community is aware of as we go into some of these larger venues with the threat of lightning. So I'm actually going to give you a little bit overview of lightning. I know most people here know how lightning forms, but just in case. As a thunderstorm develops or as a rain shower develops, you have ice crystals in those clouds, and some of them are positively charged, some of them are negatively charged. So as the storm develops, these negatively charged particles, I'm going to try to keep my hand here, negatively charged particles will go along the bottom of the storm, the positively charged particles will go to the top of the storm. So as the storm intensifies, those particles are going to get stronger and stronger, and the difference between them is going to get stronger and stronger. And as the storm moves, it's also dragging along positively charged particles along the ground. So as that storm moves and it gets stronger, the difference in the positively charged particles and the negatively charged particles between the ground and that bottom layer of clouds gets stronger and stronger to the point that some of these particles are starting to climb up things on the ground. That could be a tree, that could be a house, that could be a building, skyscraper, and it could be you. So anytime that there is a thunderstorm and it's moving, if you are outside, you have the potential for those positively charged particles to run up you, and you're going to become part of that lightning strike. If your hair stands on end, that means that you have positively charged particles actually running through you, and you are at a very high chance of getting struck by lightning at that point. Once those two particles decide to attract to each other, it's within a split second, and that's what we see as lightning. It can happen within milliseconds. It's only about the size of your thumb a lot of times, but it can pack a lot of energy. And as we all know, that rapid expansion of heat, once that hits, is what we then know as thunder. So some interesting facts about lightning. In the United States, there's about 25 million cloud-to-ground lightning strikes a year. Each of these flashes is a potential killer. The only thing that's keeping a lightning strike from being a killer versus a non-killer is if somebody's in the way of that lightning strike. More than 400 people are struck by lightning every year. And although it's decreased in the last 30 years, lightning continues to be one of the top weather killers in the United States. Now, I read a couple different statistics on this. I found the one that says 55 to 60 people per year are killed by lightning. I also read another one that said 51. But regardless, between about 50 and 60 people per year can be struck by lightning and killed because of it. What you don't think about is that's about the same number as tornadoes. Tornadoes always get a lot more media attention, obviously, than lightning, but I mean, lightning's pretty deadly. It's also more than hurricanes. And even if you aren't killed by lightning, so 90% of those people are going to have some kind of scarring, medical issues. It's a very neurological, damaging phenomena. So even if you aren't killed by the lightning, you're probably going to have some lifelong problems afterwards. Also, I have a couple more little statistics here. The spark of electricity, which is lightning, can reach over 5 miles in length. So if you're on the far edge of a thunderstorm, it could be sunny overhead. That lightning strike can come from a neighboring storm over 5 miles away. It can raise the air temperature by as much as 50,000 degrees, which is roughly 5 times hotter than the sun. And it contains 100 million electrical volts. So one of the leading number of deaths due to lightning is just because of a cardiac arrest because of that much voltage going through your body. It's estimated that on Earth as a whole is struck by an average of 100 lightning bolts per every second. So the odds of becoming a lightning victim in the U.S. per year is 1 in 700,000. That sounds like a lot. But in your lifetime is only 1 in 3,000. So that's actually not a very good statistic. You have a pretty good probability. The only way you can avoid it is to take action. If you hear thunder, even a distant rumble, you are already too close to that thunderstorm. You need to take action to make sure that you are not a lightning victim. And we need to understand the dangers of this lightning because then you know that, okay, if I know what's going to happen to me if I potentially get struck, then you know that you need to seek a safe place. This is just kind of a cool map. Tennessee, I know we have quite a few Tennessee people here, is actually in the top 10 for lightning deaths in between, 1959 and 2013. So Kentucky, Tennessee area is actually a pretty well area for lightning. So it's not something to take lightly here. We do get quite a lot of thunderstorms. Obviously, Florida is probably the highest. You have a lot of recreational activities outdoors there, and they're also the highest state for thunderstorms. So lightning safety, we actually do have a really good website. You can barely see it up here. But it's lightningsafety.noaa.gov, and there we have statistics on lightning. If you're a teacher, we have educational materials, posters. We're actually going to go here just so I can open it because we're going to be talking about what we call our lightning safety toolkits a little bit later. So I'll go ahead and get it open there. But anyway, make that a little bit smaller. Anyways, we can go down. There's a whole bunch of links on the side and at the bottom. I'm going to go ahead and click on this. But you can see for media, myths and facts about lightning, a whole bunch of stuff. So we're going to go ahead and click on this, and we'll get to that a little bit later. Okay. Oh, not my presentation. Sorry about that. Okay, so if you hear thunder, take shelter. Too many people, like we were talking about before, they wait too long. Once they hear that thunder, the thunderstorm's on them, and then they decide to take shelter. It's already too late. You're already in danger's way. So we've come up with some helpful guidelines on the website I just showed you to kind of keep you safe. We'll go through some of those if you're inside or you're outside, and then we're also going to go through these safety toolkits, or sorry, lightning safety toolkits I talked about for the outdoor organizations. Okay, if you're outside, there is really no safe place if you're outside. The safest place you can go is inside to a building that is completely enclosed and has some kind of electrical or plumbing going to that building. If you're outside and you cannot get to a safe location, if you're camping, if you're out golfing, if you're out on the water, these are some precautions you can take. Obviously, you want to make yourself the smallest target possible. So if you're on a hill, you want to get down into a valley. If you're by trees, you want to stay near the smallest trees. Stay away from water, because even though that will not attract the lightning, it is a good conductor of electricity. So if you're near water, that can just basically travel through the water and then strike you. If you're camping, a tent, even though it is enclosed, is not a safe location for lightning. You have to remember, you usually have metal stakes that are going into the ground. If that lightning's traveling through the ground, those metal stakes are then going to probably fry you. So probably not a safe place. So if at all possible, if you're outside, seek a safe shelter. Worst case scenario, if you find yourself caught outside and there's a thunderstorm and you cannot get to a safe shelter, try to minimize, like I said, as much as you can of your surface area with the ground, or get away from those tall objects. If you feel your head, or if you feel your hair starting to stand on your head, you're probably one of those positively charged things that are probably going to be connecting to the sky pretty soon, and you do not want to be in that path. So we actually have a what we call the tuck position. You only have a few seconds to act if you feel that you are starting to get your hair standing on your head. So we suggest that if you can, take all the metal objects off of you. And then you want to get into a crouch position. So basically you put your hands on your knees, you crouch down, you tuck your head down so that you're the smallest object possible. And if you can possibly stand on the balls of your feet, that will minimize the contact your foot has in contact with the ground. Minimizing that contact will minimize your injury. Now, once you're inside, that doesn't mean that you have free range. You can do whatever you want. I'm inside, I'm safe. Sometimes whenever that lightning hits, it's going to conduct all that energy through your electrical systems in your house and through your plumbing. So if you're using either one of those, you're at pretty high risk of also getting struck as well. And it will also go into your system, like this computer here. My mother actually had an incident when she was babysitting once when she was a kid, and they were watching TV during a thunderstorm, and that actually blew up the TV. So probably a good idea if you know a thunderstorm's coming or if it's near, you want to go ahead and unplug a lot of those electrical devices so that, for one thing, they're safe, and another thing, you're safe. Please do not take a shower, do your laundry, anything like that during a thunderstorm, because that water, like we said, will conduct electricity. So here are some other options or other things to go through. Another thing, concrete floors. If you're in your garage, try to get off the concrete floors, because that will also conduct electricity. Don't lay on your garage floor and just waller there while there's a storm going on. You're probably not very safe. Okay, now we're going to go through our lightning safety toolkits. Like I said, if you're outside during the summertime, we have a lot of activities going on. Around this area, we have Beachman Water Park. We have lots of ball games going on. Western has a lot of stuff going on outside. So we have actually implemented these toolkits as a way to keep the community safe. So the leaders of these activities, or the managers of these facilities, are able to get hold of information that will keep their staff safe and trained, and make sure that they keep the people that are visiting the parks or visiting the recreational areas safe. It encourages the public to take action when they hear thunder, rather than waiting until the lightning actually occurs. It does focus on the community level, and we have some that are geared just for specific things like golf courses and lifeguards, but really a lot of these can be kind of geared towards anything going on in the community. So with that, let's see here. We mostly, yeah, kind of talked about that. So we're going to actually go to one of these toolkits. Maybe. Let's go. Let's go back to the website. Sorry about that. So here you can see we have some already set up for golf courses, for lifeguards, stadiums, large venues. We'll just do the counties and communities one because that's probably the most basic. So you can see here, there's several things that an organization would have to go through in order to fill out these toolkits. But really, it's all about keeping the public safe. For the person that actually fills this out and decides to take part in this, they're actually becoming a lifesaver, because it's up to them to make sure that they're monitoring the lightning situation and that they will inform the public that are visiting and the staff when that lightning threat is occurring, and also how to take safe shelters. So there are several things they have to do. See if I can get my mouse here to work. That's me. First, they have to submit a written plan. Now, we're going to go through a lot of these elements. The elements are already spelled out, and then they'll actually submit that in writing. And then they'll go through some training. They'll have educational material that we'll give them that they can hand out to the public and to the staff. First of all, they need to make sure that they are weather situational aware. They need to obtain timely thunderstorm information, designate a weather watcher, and assign an official in charge who will stop the event when required. If we have a soccer game going on or a Little League baseball game, dugouts are not a safe shelter. We need to make sure there's a plan in place if there is thunder approaching, if there is lightning approaching, to get those kids to a safe place and get the attendees to a safe place. How are you going to communicate that to the people? They need to have a communication plan in place. They also need to identify what safe structures are around. If there's only like a little concession stand, that's probably not going to fit everybody in it. So you need to probably evacuate, have everybody get in their cars. Cars are actually a safe place, as long as you're not touching any of the metal on the car. So you need to know what to do in the case of an emergency like that, and you also need to be prepared in order to enact that plan. So you basically are signing an agreement. Like I said, you're basically signing an agreement to save other people's lives. So it's a pretty big deal. But you will designate a weather watcher official. That person will sign, and also the official in charge of stopping the event. They need to make sure they're looking at several different ways of notifying them about approaching lightning or thunder. That could be via website, via the weather service, that could be via TV networks, and also their weather radios. So they need to list those additional contacts, and then how they're going to notify the public. So if the game's going on, is the referee or somebody going to radio down the referee, help them stop the game? If it's at the water park or the lifeguard's going to be the ones in charge. So they need to have that kind of already implemented in their written plan so that they know. And then where are these people going to go after that? Once we've decided, okay, there's a lightning threat, we need to evacuate, we need to get to a safe shelter, where are you going to go? Are you going to evacuate completely? Or are you going to send them into a specific shelter until we ride it out? Do remember it takes 30 minutes after the last rumble of thunder before you are safe to go back outside. So if you think it's going to be a duration thunderstorm that could potentially end the event, especially if you have to wait another 30 minutes, you may just want to go ahead and evacuate to make sure people are safe. And then also, we need to make sure that the staff is aware of the dangers, that they are aware of how to take action, and that's through a lot of training. Like we talked about, you can't just put something in place and just prepare it or just expect to do it. We need to practice and practice until we know that if something happens, we know exactly what to do. We don't have to think about it. So these are just some other little statistics there. Also, one thing I do want to note, victims do not carry an electrical charge. So if you are struck by lightning, give that person immediate care. More than likely, they're having some kind of cardiac arrest. They're probably sustaining a lot of damage to their body. The quicker you can get to them to give them care, the better. They do not have any charge left in their body once that lightning strike goes through them. So just keep that in mind. But once a community or a specific event fills us out, like I said, we can give them more training. We can provide their staff with training. We can give them supplemental material to give to the people that are visiting. And it just makes you know that whenever you go to these places that you are protected in the sense that they know, they know the risks, they know the procedures, and then you can make sure that you are safe whenever you're visiting these places. So if you're an EM, I would highly recommend advertising this to some of your community leaders. If you are visiting a park or an amusement park, an event, I would recommend talking to some of the leaders of that event and see if they can get in contact with us, because it's a really nice thing to be able to have, to know that you are safe. And these are some of the signs that we can post when Thunder Roars go indoors. We have 2 lifeguards up there on the top left that have taken the training. So those signs, we can put those signs up, but the training is what really is important. So does anybody have any questions?
Any questions? We'll come by with a microphone. Anybody has any questions? Anybody? Come on. Comments? All right.
Quick video real fast here. I talked about how quickly that lightning can happen and why you do not want to be outside. Oh, let's see what. Do we have the lightning video? Yeah, I got it. Okay. This is, I want to kind of get a setup of this. This is actually somebody that has this guy here has a camera that was, I think, used back like in World War II. It takes 1 million shots per second. So you're basically seeing a second worth of lightning. And you can see how many little streamers jut out. It's basically that one streamer is looking for the path of least resistance. And unfortunately, that path of least resistance is going to be the tree down here at the bottom. It could have easily been the same guy, but it takes, all of this is occurring within like less than a second. So if you're in the path of that lightning bolt, you're probably looking at a death wish right there. So just, even though it's fascinating, even though it's pretty, take caution. So with that.
Chris.
Thank you, Jane. I appreciate that very much. Give her a hand.
I just want everyone to notice, we took this.
I was going to say the same thing. Yeah, oh no, it's Tim Samaras. Who knows who Tim Samaras is? Isn't it incredible? You know, unfortunately, he lost his life doing what he loves, and that's chasing. And but look at the stuff that he's left us. I mean, he has a whole library and an archive full of these type of things, and the things that he went out in the field and learned about, not just tornadoes, but about lightning and severe weather, and you know, those things we will use forever. You know, while we're here today and we're doing what we're doing, let's all remember how dangerous it is. As we can see, even someone as experienced as Tim Samaras, you know, when nature is unpredictable, and so we have to be at our best. We have to take every safety measure that we can, and that's very important. And let's just, you know, let's all remember Tim and what he did and what he left for the rest of us, that legacy. All right. Yes. Jane, do you have a question here? We're everybody here.
I was just wondering about the sign, the fence sign.
Yeah, we can provide you with those when you get the training. Joe, correct me if I'm wrong here. I think if you go through that training, you definitely will be getting those signs. You may be able to post the signs without the training, at least the full training, but I'm not exactly positive on that. I know that if you do go through the training, you will get those signs. Yes.
Thank you. So are those signs being produced by the Weather Service? That
Talk to me afterwards. I don't know. I'll find out.
So those of you, I know some of you, you know, that are EM directors, you're probably interested in that sort of thing. They will find out through Joe's office and hopefully get an answer for you, you know, at some point. Maybe not today, but at some point. All right, we're going to try to keep things on time here. And next up is Dr. Josh Durkee from Western Kentucky University. He's going to talk about weather situation awareness apps and websites.
Hello, all right, good morning. Today I'd like to talk about a little bit about credible online and mobile technology. There's a lot of stuff out there and there's a lot to sift through, so I just want to kind of point out some of the more, I guess, like I said, credible sources and resources of information. So it's a little bit focused on the technology side. Let me figure out there we go. Okay, so I'm an associate professor of meteorology at Western Kentucky University, and I'm the director of one of our new forecast labs, which is called the Chaos Lab, and it stands for the College Heights Atmospheric Observatory for Students. It's a student-centered forecast center that focuses on extreme event forecasting for all events, winter weather, severe weather, and the like. So we kind of have our NASCAR branding here for all our entities. So on the left there is the logo for the meteorology program, and we've got the Chaos logo there. And then of course I'm also the director of the WKU Storm Chase program as well, which is an intensive forecast workshop that I run every spring, where we take students out to the plains and we basically practice forecasting and documenting the most severe storms in the country during that time period. And of course, below are the folks that we are closely affiliated with during these times. So today, I just want to talk a little bit of redundancy, but just a little bit about the Weather Service, the role of the spotter. What is a spotter? And then again, focus then the end on this idea of credible information, or what I like to call incredible information, if you know where to get the right stuff. Okay, we'll not focus on computer software, mainly just websites and mobile technology, and then sort of conclude with how to report this information. Okay, so the Weather Service. A lot of folks, don't even realize who the Weather Service really is. It's a component of the National Oceanic Atmospheric Administration, or NOAA, and their mission, as Joe was mentioning earlier, just to be very specific, to provide weather, water, climate information, forecast and warnings, but the emphasis here is for the protection of life, property, and the enhancement of the national economy. It's an important thing to realize. When we talk about spotters, that idea comes up again. And of course, then the vision is why we're all here today, is to prepare for a better weather-ready nation. Here's a map showing all the Weather Service offices around the country, and sort of come into our area, the KenTenn area. And it's important to realize that the Weather Service is not a group of people that go out into the field all the time and spot the weather. They're an assembly of forecasters who sit in an office and rely on help from others to make this thing successful. So in summary, the Weather Service is sort of like I said, the primary conduit for weather information that's disseminated through that office, but also for the receipt of information coming from folks like you. So they issue the outlooks, general forecast discussions, the near-term forecast, that's like your 3 to 5 day type stuff. The warnings come from them, and of course the storm reports, which are critical. So again, it's a fixed location, but they rely on the volunteer efforts of others to help make this operation a success. Okay, so then how do the spotters come in? What is a spotter? Okay, the role here is to assist the Weather Service by providing some real-time information out in the field during these extreme events. The warnings that come from the Weather Service are often issued because of these spotter reports, and it helps society sort of understand where this information is coming from. So you'll often hear or read about a tornado report from a trained spotter, as opposed to just someone else who happened to see it, and that information tells a lot about the sort of the credibility of where it's coming from. So in essence, then the spotter role is to come back to the Weather Service mission here and help out with the protection of life and property and so forth. Spotters are not supposed to chase storms. They're not storm chasers. That gets mixed up all the time, and it's easy to want to go out and spot storms and then follow the storms or chase the storms, but that's not your job. Your job is certainly not to seek attention and compete with other spotters or other chasers or anything like that. And basically, long story short, your job is not to be the hero. Your job is to assist the National Weather Service, because in the end, no one really cares, to be blunt. So if you've seen the movie, you know where that kind of comes from. So anytime spotters take on the roles that they're not supposed to, it's generally bad news, and it's a disservice to everyone involved. So then the question is, who can be a spotter? The answer is pretty easy. Anybody. There's no requirement of formal training or anything like that. It's a real basic, fundamental understanding of what to look for, what to understand, what's going on. And there's a lot of websites in my talk, and we don't have the best website, sort of links of ease to remember. So if any of this stuff blows past, actually, for anyone on the organization side, are these presentations going to be available to the folks afterward? Yes, okay, so a lot of this stuff will be available afterwards, so I won't spend time, with the links. But anyway, you can visit a lot of stuff or just Google the names and find some of this stuff. Okay, so let's get to our credible sources, and this is a tough thing because modern meteorology is incredibly complex because there's a lot of information out there, too much information overload. Why? Well, technology has allowed this, and the fact is, everyone loves the weather. Weather's the #1 topic of conversation among strangers at the bus stop, the hair place, whatever. Hey, how's the weather today? It's the way it is, and so the internet has sort of created this path, unfortunately, for overnight meteorologists and what I like to call the quote experts, right? So how do you know what's good? Who do you trust? And how do you sift through that? Well, that's kind of the point of the talk today too, is I'm going to try and point you in some of those directions so you can kind of forget about a lot of the other nonsense that's floating around out there. Okay, first place to stop is steer clear from places that give you forecasts that go out beyond 3 to 5 days. The science is not there yet, and a lot of this stuff is just sort of for entertainment or other purposes. And just to demonstrate here, so here's 2 weeks from now in the red box in the upper right, and here's what the model is sort of trying to show you. And hopefully you're going, what does that mean? And the answer is, we don't know. All right. So they're basically, in this example, giving very precise weather forecast information based on that to the right. And it's just not possible. Well, if that's not possible, and this is some of our silly long-term forecasting that we like to look for real vague pattern information, nothing specific at all. So if that's sort of the silly part of our forecast, look down here. There's already forecast for early May. It's not credible. It doesn't work. I'm sorry. So any forecast going beyond 3 to 5 days, let's not focus too much on the chance of nighttime thunderstorms on April 29th. Sleep easy until then, worry about it when it gets closer. Okay, there's some other issues. All right, we get our other online folks. A lot of bloggers out there. Everyone's a weather blogger expert. Okay, so I've kind of poked fun here. Loves the weather, issues warnings of the worst scenarios ever. And there's a lot of people that follow these people, and you got to be very aware of the people you do follow online, because you just don't know who they are, how old they are, and what their backgrounds are, what their motives are. Just got to be careful. This is another classic situation here. Online weather experts, they're the ones who always pick on the National Weather Service. Weather Service does a fine job, so anyone who sort of picks on them is a red flag in my book. So just be careful. If it's on the internet, it's probably not true. Okay. Okay, so where do we start then? basically anything coming from NOAA is going to be your primary source of credibility. So if it's got a NOAA tag or identifier or anything on the website, that's a good place to go. So we're talking about the National Weather Service, of course, the Storm Prediction Center, the Weather Prediction Center. Other government entities such as NASA provide valuable weather information. That's definitely good. Your favorite local broadcast meteorologists, they know your area more than other folks who are good at doing weather prediction outside of your area. So pay attention to them. And this also involves a mixture of folks who've been doing it for a very long time and brand new meteorologists who are currently training in meteorology programs. So a lot of broadcast meteorologists that you see on TV today are coming right out of my classroom. So they're fresh off the wagon and doing a really fine job. Credentialed education that is advertised. Some folks come off to be the weather expert, and if you say, so what's your background? How long have you been doing it? If they kind of dodge those types of questions, it's probably not good. They should advertise their experience and their background. And lastly, nothing can be substituted for experience. There are plenty of degree meteorologists who do a terrible job, and there are plenty of non-degree meteorologists who do a fantastic job. So in the end, it's the folks who have a good history of producing solid output. That's who you want to follow. Okay, so this is just some of the websites of some of these places, what the Storm Prediction Center looks like. They provide the day-to-day and the near-term 3 to 5. And in this case, they do focus a little bit out to the 8-day period for the general severe thunderstorm pattern. You've got the National Weather Service who focuses on your area. And of course, the Weather Prediction Center is also a national forecast entity. These are the primary places to get the most credible forecast information. Okay, so go from sources to resources. Start off again, make sure you know your incredible sources, NOAA, NASA, those types of places. And then again, so remember how the internet has spawned all of this information that's very complex and confusing and a lot of redundancy, and you just don't know what to do with half of it. There's websites, now there's apps, and now there's a million blogs and social media, and it's like, what do I do with all this information? And the answer, in my opinion, is to just keep it simple. You don't need 50 weather apps to do what you're probably trying to do. You don't need to bookmark 100 websites of weather information. There's probably 1 or 2 that can get it done for you. Okay, so there's a lot of options. There's some winners, there are some losers, but most of it, to be honest, is garbage. Okay, it's clickbait, it's money making, and it's easy to do that. So there's no need to reinvent the wheel here. So my main point is try to use as little as you need to obtain what you're looking for, and that will help you out with your understanding and the success of whatever mission is at hand. The best resource we often forget about is the most obvious one. As technology comes up the ladder, we're looking at toward our feet when we should be looking away from our body. All right, the best resource is the sky. So coming back to the idea of situational awareness, get to know your local skies. The skies look different in this part of the country than they do in others. And you get to know sort of how storms and the skies evolve over time in this area or wherever you live. And you get very comfortable with that. There's plenty of people, again, who have zero meteorological training who can look up and just tell you, oh, it's going to be a hot day, it's going to be a bad day, it's going to be a severe weather type day. And they generally do a good job with that. So get to know your area and try to look up first, look out your window and get to know your local meteorological patterns. Then, never hurts to go back and refresh. I've been doing this a long time, and I do this all the time. Go back and just brush up on the basics. One of the best places is a freely available glossary of meteorology online that comes from the American Meteorological Society. And more than you would ever care to know about all these terms and definitions on stuff. But if you come across some terms and you don't understand them, it's going to be in there and you can figure it out pretty quick. And then you can go beyond that. YouTube is a fantastic resource. Sometimes we even forget the obvious. If you just YouTube, do a search on just some fundamental things, there's probably a video somewhere demonstrating it. Just beware, is it coming from a credible source or not? But it's a lot easier to identify that in a video than on just written word from a blog. And the item on the left here is a fantastic resource. It is academic, so it gets a little challenging in areas, but they do rate it from 1 to 5 or 1 star to 5 stars to provide the level of difficulty, I suppose. But they provide some quizzes and some other things in there, and they've got plenty of spotter things, severe storm dynamics, and all sorts of stuff that you probably don't need to worry about. But if you're interested, it's a fantastic resource. Online forecasts, this just comes back to the slide I had previously. This is pretty much the 3 main places that I visit on a daily basis just to get general forecast information. And there are other emerging models of forecast dissemination, okay? So just because it's a blog doesn't mean it's bad. This is something that is sort of, again, coming out of the fabric of weather information dissemination. And a fantastic example of that is our own Landon Hampton, who provides an online weather service called Weather or Not, and it's right here out of Bowling Green. And he also focuses on the Louisville area as well. And the quote that he uses is, "It's doing weather differently," and that's true because his job is to provide all day long, in some cases all night long, full-time weather information for a specified area. It's very unique. Most people have to focus on regions or areas, and in this case, he's focusing on specific points and goes out and reports on that. Very, very handy for outdoor sporting events and whatnot. Some sporting events, for instance, get canceled because of a light rain. We have an outdoor hockey league here, and a light rain can ruin the whole day. It doesn't need to be severe weather. And most of the time, we're not going to break into TV or stuff like that to tell us about an impending light rain that's coming in the next 5 minutes. But he does, and that information is very useful. So he provides an official forecast for the daily news, our local newspaper, also local radio, and again, various sporting events. So there are credible blog sources, if you will. You just got to do a little research and make sure you're getting the right information. And this is just sort of how this decision tree comes together a little bit, at least for our area. So we communicate with Weather or Not through Western and the National Weather Service, and we really try to provide spotter information, forecast information, and more importantly, the reports coming out of the area. Oh, there we go. And of course, we don't carry our laptops everywhere. A lot of these sites I've showed you are available in a mobile format. So there's the Weather Service version. Here's the Storm Prediction Center. So it's just formatted for your mobile device. And of course, we get to the apps. All right. Well, I think you all feel this overwhelming perspective of all the apps available. Just do a search for weather apps alone, and it's just like, gosh, there's 100 that just show the forecast. There's 100 that show the same radar. And the reason for that partly is that one of the cool things about our country is most of the weather information is freely available. And so anyone can go grab radar data or jet stream data or anything like that and code it into an app and sell it and enterprise off of that. The bad news is most of these people are just sort of regurgitating the reinventing the wheel, and it's nothing you just can't go online and get for free. Or they're not sort of weather-minded, and these apps just kind of come out kind of crummy. Hey, and you all know that the apps often don't have a big test market. You gotta purchase it, deal with it. If you don't like it, throw it away. It's a disposable $1 or $2, but it adds up if you're wanting to get a handful of apps. Okay, so the apps. One thing I want to stress is that they are to be used with your visual observations, not to replace what's going on with your eyes. The maps may provide or enhance your situation awareness. because a lot of stuff is GPS enabled, gives you a precise location of where you're at relative to a storm. And that's good, but that could be a very dangerous thing because it can give you a false sense of safety. So never rely on the apps or technology to save your life or to save others, because it's technology. There are a lot of issues with this stuff. These apps need updated. You might get the best app that's doing the thing for you for that month or whatever, but as the information gets old and the developer doesn't update the app, then it falls apart pretty quick. Batteries die, leave you blind. I'll talk about that in just a second. There's glitches. The phone needs a reboot. So if you're letting the storm get as close to you as possible because it shows you if you're safe because your GPS location, and then it turns off in the middle of the storm, then all of a sudden there's that panic of what do I do with that? And that's not good. So the apps and the technology really, in my opinion, are the last resort, and they're just sort of a supplement to the overall process. In this example here, we can see the GPS location on the right, and we have a tornadic storm bearing down on the left. This arrow pointing to the empty space is where technology failed me in a situation, because it said go this way, and the road was a 2-lane paved road, and it ended up being a dirt road that stopped suddenly because a farmer plowed over it. And when I went down that road, then I also lost cell phone service and I lost all information. And the only thing I had to work on was the sky. And if I wasn't prepared for that situation, that would have been a really risky situation. So then the second arrow was pointing to where I finally got phone service again. I could see where I was relative to the storm again, because there were a lot of trees and other stuff. So it is dangerous. Okay, so here's just my opinion. Here's, you may know something better or whatever. Happy to hear it. But these are the ones that I kind of know are credible and do a good job and tend to be the most popular. Some are more expensive than others, some are free, some are available in both common sort of iOS and Android formats, and some are not. So anyway, I would argue that the most popular radar app is Radar Scope. It does a very fine job and has GPS-enabled positioning and provides all of the more than the wealth of radar products that you would ever need for it. Followed next by this oddly spelled pickle radar. In this case, this one's only available for Android, but it's cool because it also allows GPS enabling, but also you can add your own road maps and other stuff to it as well. So both radar programs are not going to let you down for sure. This third one is kind of a fun one, but it uses your GPS location to give you a relative position to the storm track, and it actually tries to provide minute-by-minute forecasts and tells you where the precipitation is moving in relative to your position. It'll say you've got like 5 minutes or so until it starts raining on your spot if you don't move. I wouldn't trust that too much. I wouldn't say, okay, I got 5 minutes until the tornado gets here. I'll wait it out for 4. But you understand the situation. Fantastic app here. This Weather Radio app provides, well, like I said, the most accurate alerts, and the most timely alerts because of some algorithm that they use. Arguably, it's argued that this is better than a traditional weather radio. The downfall is on your phone. So if your phone isn't charged or turned up, it's not going to work. Another one, Weather Geek, appropriate name, provides all the weather models you could ever ask for. But, for basic day-to-day spotter type use, who cares about the models? Just trying to focus on the general forecast from the other entities. HailSpot's another one that's good that provides real-time hail information, which is good. This MPing app, which I'll show again in just a second, is used for precipitation type reporting, because especially in a place like the KenTenn region where we don't know if it's sleet, snow, rain, or what, or all at the same time, we can use this to report what we're getting at our specific location, and then it feeds that into a map where you can see the distribution of stuff. And then finally, this other one for satellite data. A lot of folks, where do you get your satellite data? Again, it's really available. Just got to kind of know where to find it. And the WeatherSat, the WX is our abbreviation for weather, by the way. It's kind of a funny one. But the WeatherSat app coming out of Wisconsin is a great app that shows you fundamental satellite data. It's cool to look at. All right, and then to wrap up, we'll get into the reporting. There's a lot of places to report. Find your weather service office area and bookmark the reporting page. There's this thing called the Spotter Network where you can sort of do this really basic training module, and then they'll take a test, and if you pass, it's pretty easy. You become part of this Spotter Network, and you can report through that through phone or online, and it's fantastic. And when you're reporting, make sure, if you can, to try to take a picture, because a lot of times we don't know what it is. And so we can at least take a picture of what we're seeing and say, I think I see this, send in a report, and it helps the folks on the other end help make that final decision for you. So lots of options there. Make sure you just program the weather service number in your phone now. Don't wait until you're needing a Google search or anything like that. Go ahead and program it in your phone book. And like I said, provide evidence when you can. Here's the MPing page. Like I said, so when you send your data in, it provides a map of all the different precinct types that are floating around. Primarily, winter weather, but not always. And then we also have just precipitation reporting. We can participate in this other volunteer reporting system called COCROS. And you just put a rain gauge essentially at your location, and you submit your reports on what you're getting at your house. And it helps supplement all the other stations at airports and other places around the area. All right, so in summary, your weather service office, because we all have different weather service offices that represent our area, is the primary source of weather information, but they need your help. Okay? The spotters are critical to the success of the weather service sort of mission. There's lots of weather information online, most of it's bad. So be careful, take note of your incredible sources, and don't stray from them. There's no need to. That's their full-time job, is to provide the most accurate information. Your situation awareness is key. You got to be careful with your position and whatnot, and try to be a valued spotter with that. Don't be a competitive hero with it, because it doesn't benefit anybody. And then submit your accurate reports. So as I conclude, I'd like to thank Joe Sullivan for having me out, and also providing some of the slides to help me get this presentation together. And with that, I'll take any questions.
Any questions for Josh? One thing that Josh referred to was the National Weather Service toll-free number that you can call in a report. If in your yellow folder, there should be an orange card that has pretty much the things that you talked about, the things that should be reported, and the Weather Service 800 number should be on the back there. So if you did not get one, I think they're still out on the table, but that card has that 800 number on it and ways to get a hold of the National Weather Service. But it's great to have those things like MPing. That is like real-time reporting. You can do that from your phone. You can tell what type of precipitation. If it's rain, sleet, snow, ice, it doesn't matter. It's automatic, and then it shows up on that map that Josh showed you. It really gives them kind of the ground truth as to what's going on at those particular locations, and then know exactly where that report is coming from. So that's very key. Any questions for Josh? All right. Josh, thank you very much. Let's give Josh a hand. We're going to stay on time here, and it's 10:05. We're going to give you a bit of a break here till about 10:15 or so. So you've got 10 minutes to help yourself to the restroom, get some coffee. Just make sure you keep your badges on you so you can get back in here. And we'll be back in a few minutes.
Not bad. Hanging in there. I'm going to put up the chocolate.
But they were up 3
Yeah. I don't know if he was or not. I think he was planning. I think he was. He was talking about a good business in that last spot. I'm sure if he had to be willing to pay what he's just trying to get out. What's that?
Well, I mean, look at BG, we had, I think, official percentages
Yeah. Yeah, I mentioned go. Go chat.
Yeah. I don't think
Challenge South Carolina, I gotta go to Green Bay next week.
Right. Nice presentation. Thanks. Yeah. Say to me today. And I'm like, I said, now you know why I say this. Because he was saying, I couldn't tell if it was that or it's such a matter. So we don't have seminars. That was okay. It was okay. You have some areas where you can get some. Yeah, it was really good. It was really good.
Now, he was saying yesterday how he was talking about him
How many people do you have?
What's the set now?
I'm in, so.
Yeah.
I think that's really helpful. I like that one. It looked like it was going good.
We'll put them all.
I did have a question.
We all know him. Charging. Yeah. How'd your wife do after that accident? She's finally settled down.
Oh, really?
She was pretty tore up.
Oh,
Yeah.
Well, probably what it is. It must be, yeah, you need to talk to Chris.
Lots of men. Usually I would say I'm used to it. Yeah. This is everything maintaining.
That's insane.
We'll jump in there.
That's what I thought.
We'll jump in there.
Oh, video bites, yeah.
Oh, I'm on TV. So you're good.
Yeah.
That's actually what I work for. Yeah.
Oh, yeah.
We got some information.
Yeah, we're working on this. That's something really you see that.
Yeah. That's years. You go through your yeah. If you at 10 o'clock in the morning, they're going to put me on the road.
Well, that's a problem. When they're doing hardware, securities, and sometimes
You're still on that
shuttle. We don't know we all. And they go on some time. Probably back on the good beach island. Work on rewind. Learn how to run.
Facial tissue.
And then I'm just going to work 7 days. Get promotion. And might get the new hand. Yeah. So we'll go forward to great. We'll have all that information. Yeah. Cool. We made great things. So, I'll stay staff and they're gonna work it out so
We did. Oh, no. These are the guys, when you're watching the show and they show the interview, but you don't actually see the guy interviewing.
Hey Chris, good to meet you.
Oh,
I'm Alex Sizemore.
Oh, yeah,
Probably
yeah,
seen
yeah.
you.
Oh, yeah.
Hey, ever come down here, man? I'll give you a shout.
All right.
I don't say come here, man.
Yeah, I've done the last guy.
Really?
Oh. Yeah.
right, we're going to try to keep things rolling on time. It's a little bit after 10:15, but you guys are free to roll around, get you some refreshments. I think they're going to bring in some water. I think the water that was back there is gone, so they're going to bring in some more. We'll give it just a couple more minutes for people to come back in. Yeah, folks are coming back in.
You're fine.
By the way, some of the speakers that are presenters that are here today, you'll find a separate sheet in your folder. Some of them provided bios, so you get a little background information on some of the speakers today, some of the presenters, so you can find out a little bit more about them. You've got one, if you keep hearing a popping like I do over here, there's one speaker, this one right here, that keeps popping in and out. And that's just a speaker, so I'll apologize for that. You may hear on for a few minutes and then off for the next few minutes. So we'll get moving here. And up next is a presentation on mitigation and preparation. And a couple of people that are doing this particular presentation is Emory Kidd, who is the Metcalfe County Emergency Management Coordinator and Director, and then Bruce Thomas, who's here from Midland Weather Radio. But Emory's up first. Emory.
Yeah, great. Yeah, great.
I don't do well with microphones, so you don't have to overlook that. We'll talk a little bit about mitigation and preparation. And for those of you that are wondering, I actually made this picture down at the bottom. That's in Livingston County, Kentucky, Smithland Dam Road, somewhere in there, about 5 miles from the Ohio River. What you're seeing is the Ohio River back in 2011. But I'll get into the over there. Mitigation. Talk about mitigating something, we're preventing something. Whether it's death, loss of life, loss of property. And in order to mitigate, we've got to understand all the risks. Got to make some hard choices. Invest in long-term community well-being. That's what you're looking at. Without mitigation actions, we jeopardize our safety, financial security, and self-reliance. Disasters happen anytime and any place. Their consequences, whether it be human or financial, are hard to predict. If you have a tornado and it goes through an open field, there's no consequences. If it goes through downtown Bowling Green, major consequences, both financially and personally, loss of life. Number of disasters each year seems like it's increasing. If you'll think about it, we just had 2 back to back. The snowstorm in February and then again in March. You live a little bit to the north of here, you had a whole lot more snow in March than we did. FEMA's mitigation programs, and that's what we're going to talk about, is how we chose in Metcalfe County to mitigate some hazards. The projects I'm telling you about all come through FEMA's mitigation money from a previous disaster. The state of Kentucky gets a pot of money from a disaster that's presidentially declared. Counties apply for that money for mitigation projects. They help reduce the impact of events. And we reduce the impact of events, we reduce our dependency on taxpayers and the treasury for disaster relief. That's our money that we're trying to keep from spending. Preparation, the activity or process of making something ready or of becoming ready for something. Bruce had a good example a while ago of that. Can I use it? Sure, go ahead. He was talking about if you had an ulcer. Mitigation would be not eating anything that agitated that ulcer. Preparation is making sure you've got a bottle of Gums handy just in case you do.
I try to put everything in food terms because it makes sense to more people. And Emery and I have been discussing these two topics, preparation and mitigation, for the last several weeks, discussing how we wanted to talk about these because it's important to mitigate future disaster and then encourage people to prepare in their own homes and communities and have a plan of action. And I have to say that Emery has been one of the exemplary emergency managers on mitigation. And then we're going to walk through some slides and show you what he has done in Metcalfe County, Kentucky, that hopefully will be noticed by many of the others in the emergency management community, because having this layered approach that he's going to show you will save lives in areas that have severe weather.
I want to show you an example of mitigation. May 2nd, 2010. Anybody remember that date? Raise your hand if you do, because I know I do. That was the day that Nashville flooded. Not only did Nashville flood, Bowling Green had a lot of damage. Metcalfe County ended up with about 14 inches of rain in about the same number of hours. And one of our local community parks was destroyed, the top picture there. Suffolkwell Community Park, everybody's sure have heard of the Lighthouse Restaurant where you go get country ham. Right across the road from that. Well, we got to looking at rebuilding. They would come in and they wouldn't allow us to rebuild the community building where it was previously because it was in the floodplain. So we mitigated that hazard. If you look at the bottom picture here, by moving it up on the hill, we elevated it about 30 feet. That was a mitigation project. That eliminated the hazard. The community building is rebuilt. We mitigated it, and hopefully won't have any more problems with it. This is a poster I borrowed from the National Weather Service. It talks about April census 16, 19, and 98. I believe that was the day that Bowling Green had a massive hailstorm down here. Lots and lots of damage. Metcalfe County had a tornado that same day, had a loss of life. When we started looking back at previous damages, previous disasters, we've had several people lose their lives in Metcalfe County. And that's one of the reasons we have chosen to do the mitigation projects that we have, is try to prevent that from reoccurring. This shows all the tornadoes since 1965 that have gone through Metcalfe County. Some of them are EF0s. I think the largest one we've had was an F2. And I think it's represented of 3 or 4 deaths in the county. So what we done is we started looking at several different avenues. How do we protect our people? How do we get them word? How do we get information out to them? In 2004, basically, we had 5 weather sirens, 3 of those in the city, 2 in the county, 1 on the north side, 1 on the south side. Population of about 10,300 people. We explored the possibility of covering our county with outdoor warning sirens. 2 issues with that. One of them, to cover Metcalfe County in warning sirens, you're looking at excess of $4 million at about $25,000 a siren because of that terrain. The second issue with that is it is exactly what it says it is. It's an outdoor warning siren. It's not designed to be heard in your house. If you're outdoors, you've got, depending on the terrain, wind, possibility of a 2-mile diameter from where that siren is. So we started looking at asking questions. In 2006, Kingsford Manufacturing, they're located in Summersade, came to emergency management, and they have a lot of people that work on the outside, and they could not get notified of severe weather. So we worked out a deal. They actually installed 2 outdoor warning sirens in Kingsford, 1 for the general public and 1 for their people. So now we're up to 6 outdoor warning sirens. But still, the yellow circles represent the coverage. We still don't have the coverage for the number of residents we have in the county. So we continue to look. 2 miles. Metcalfe County's got about 495 square miles in it. Get over in the eastern part of the county, Hills and Holmes, and Simon's only going to be heard about a half a mile. So it's not feasible, in our opinion, to try to equip the county without the warning sirens. Next thing we done is we looked at our notification and the joint venture between Barron and Metcalfe County, and we purchased CodeSphere. CodeSphere sets up, it covers the whole county. So we're starting to get better on our coverage. The landlines are automatically loaded. If you've got a cell phone and want to receive messages, you have to go in and manually put that information in. The disadvantage to this is to notify every citizen in Metcalfe County, you're looking 5 to 6 minutes. The average tornado warning, I think, is about 7 minutes. It doesn't give them enough time. Yes, this is a great tool and it has a place. But in the county's opinion, it did not have, this was not the right application for this tool. Next, the money became available. We started talking about tornado safe rooms. We wrote a grant and was able to get 10 safe rooms. That's what the blue stars represent. That's 10% of our population. Each safe room will house about 105 people. This is the safe rooms. There are 4 concrete, rebar put on the centers. Once we got the safe rooms up, we got to talking about them. How do we get these unlocked for people? Are we going to have somebody drive from one side of the county to the other when we go under a warning and manually unlock the doors? Working with a local radio company, one that does most of our emergency services work, he come up with an idea, and one of the doors has got a mag lock on it. That's tied into an informer, which is operated from our dispatch center. When we set our sirens off, there's a strobe on the tornado safe room, it automatically goes off. But the right-hand door of every one of our rooms automatically unlocked. That way people can get in them. We don't have to worry about it. And as a backup, we've got people in the community, one person in each shelter close to it, that can manually unlock the doors. The other backup is there's 4 people in the county that pack 2-way radios that have been programmed to also unlock these doors. And as soon as we set our sirens off, these doors unlock. The strobe on the side of the building remains on the entire time we're under a warning. When the strobe shuts off, it's an all clear sign. These rooms are designed to handle 250-mile-an-hour winds, tube-of-force, various other debris hitting them. The way we chose our locations that are our vulnerable populations, they are in areas where people do not have places to go, trailer courts. And when we got to talking about it and it got out in the public, I actually had a gentleman that owned 3 trailer courts in the county. He came to me and said, I will give you a lot if you'll put a safe room in my trailer court. He got one the first go around, and before the end of the year, he'll have 2 more. Because he understands the value of his residents having somewhere safe to go. When you look at your population, you look at a 5-minute travel distance, half a mile basically. So now we've got 6 sirens covered in the county. We've got the reverse call system and 10 tornado safe rooms. We're getting to where we want to be. We're protecting our citizens one step at a time. But we still got the issue of how do we get them information in a timely manner? What is our best approach? We've got news media. That's great, provided they've got a radio on or television on. We've got a reverse 911. We know it's not going to be as effective as we would like to see it in severe weather. We've got our outdoor warning systems. Next step is, after some meetings with some people, we chose to do a weather radios. Wrote a grant to buy every occupied structure in the county, weather radios, bid those out. Midland won the bid on that. So basically, we're purchasing 6,500 Midland 120 weather radios. That'll put one in every occupied structure, and that also includes the structures that are only part-time occupied, such as our churches. This was the next step in our toolkit to getting those residents notified. Okay, had some concerns, some citizens read about it, and they come to us and express some concerns that they currently have weather radios. They would not work. Okay, so we started doing some research, lots of meetings with National Weather Service, calls with Midland Radio to find out what is their best receiving radio. National Weather Service came down and done a drive study for us. And none of us liked what we saw. What we saw is the black areas have no weather radio coverage. You'll notice the center of that slide is Edmonton, our county seat. A population of about 1,600. I've got a weather radio set in my office, second floor of the courthouse, and I cannot pick up warnings if I have it. Okay, we wrote this grant, we've got the money. But we're going to put a product out there that's not going to do what we want it to do. It's still not going to notify our citizens the way it needs to. And when you overlay this with the county map, we're a very rural county, but there's a whole lot of the county that this will not benefit. But yet we're going to give them a tool they're going to rely on. So we go back to the drawing board and back to research. What do we need to do next? Worked with the National Weather Service, several meetings, some local radio gurus, and it was suggested that if we could rewrite or change the scope of work for the grant, to look at a weather transmitter for McKay County. Got the pricing, went back to FEMA, wrote lots of letters explaining what we wanted to do, and in 11 days they signed off on the purchase of a 300-watt weather transmitter. Talked to the National Weather Service, and due to budgets, there's not a whole lot they can do to help us. Well, we're using grant money that was left over from the weather radios to purchase the transmitter, the antenna, coax, and everything we need to take care of the coverage. And I got ahead of my slides. Bottom corner here is an Armstrong 300-watt continuous duty transmitter that'll be put on an existing antenna in Metcalfe County at a height of about 170 feet, which is the second tallest point in the county, but it's over all ground elevation areas in the county, so we should have the coverage we want and need. It'll have an antenna put on it. It'll be tight. I'm not good with technical stuff. Y'all have to overlook me. It'll be tied in with another transmitter site from the National Weather Service. It'll have a designated frequency where the people in the county, when we issue these weather radios out, the station will be tuned into it. And that way we have got the coverage that we need. 300 watt, I've been assured by many people, it should give us about a 98% coverage of weather radios in Metcalfe County. Another issue we encountered is who's going to program 6,500 weather radios. I program them in my office occasionally, and it takes me about 10 minutes of radio. I talked to Midland, and one of the things we was able to work out is they're actually programming the weather radios for us before we take possession of those. They've got, as of Friday at noon, 4,000 of them are already programmed. We're projected to have them shipped by this coming Friday and take possession of them. And then once we hand those out, we'll hand them out after we get the transmitter installed so that they are preloaded with that frequency and they don't melt down the switchboard calling and saying their weather radios don't work.
That's a very important thing because we don't want this to have a negative impact. We want it to have a positive impact on the community. So one of the things that Emory has worked so hard on is getting all these components brought together so that once it's put into the community, it's going to work well and do what gets, like you said, 98% of the population of this county covered with no weather radio. There'll be some sporadic sirens. There'll also be the reverse 911 or call service also. But to get this to where it is now, how many years have you been working on this, Emory?
We started this project in 2010. But it's a stepping stone. And every year it seems like we make another stepping stone, and somebody just told me we've got 5 minutes. Purchase the Armstrong transmitter, 6,500 radios, install it. That's going to give us the coverage we need. Tying it all together. A alert comes out from the National Weather Service. Warning is transmitted through their system of transmitters. Metcalfe County citizens receive the warning by using the transmitter we've got in the county. The safe rooms are unlocked. Citizens are prepared or they have a safe place to go. With that, we're looking at about we project a 98% coverage. And the other thing is we wanted more safe rooms. More residents need to be protected. By the end of this year, we'll have an additional 4 safe rooms, enough for about 1,450 to 60 people. So from 2004 to December of 2015, we will have installed 14 tornado safe rooms, 6,500 weather radios for every occupied structure, a 300-watt broadcaster or transmitter, 1 outdoor warning siren in addition to what we already had. We project this will mitigate notification for the citizens of Metcalfe County at about a 98% rate. Bruce, you go ahead.
Well, I want to say, Emory's done all the legwork, even on this presentation. I'm here to support Emory today on this presentation, and I'll be on a panel discussion later this afternoon. But we would welcome some questions about how this implementation is going to happen. And I will tell you right now, the weather radios are being programmed to Metcalfe County and 2 additional counties that are to the west and to the south. And that way they'll have a little extra lead time as the storms are moving in, especially a tornadic storm generally coming from the southwest. But we're not going to set the frequency until the transmitter's in place. Because the number one thing you have to do on a NOAA weather radio is have it on the correct frequency for the county in which you're living in. Because if it's on, sometimes you can hear a signal from another transmitter, but that doesn't guarantee that the National Weather Service warns your county from that transmitter. So having the correct frequency set, and he'll have his own transmitter and frequency for the entire county. So that's one of the novel aspects of this that makes it so robust, is that he'll be able to have his own transmitter, and every structure in the county will have a NOAA weather radio in addition to the services he's layered in his county. There's a couple of them.
Hey, one more slide, did you say?
Just contact information.
We've got a couple of questions
Oh, yeah.
here. We got a couple of hands.
Yeah, I'll run back.
Oh, I got loud little boys, that'll be one.
Are you a loudmouth? What do you say?
What kind of liability is going to be associated with the shelters and the people going in and out?
We're not making them go. They go of their own free will. The county has insurance on them just like it does any other building.
Do you know of any other counties that included shelters and shelters?
The shelters, they've got some in Warren County, they've got some in Barron County, Metcalfe County, and those are the ones that I'm most familiar with because I work with those.
Other regions for their
I don't know what they have over there.
because, you know, because that
Yes, it is.
Chris. She can contact her local EM director and find out.
Sheltering in place is always a good idea unless you're in a mobile home or in a structure that will not sustain, winds of 150 miles an hour.
Each county is going to be different, so contact your local emergency management office, and they should be able to tell you. Yeah, I'm back here, sorry. Because we have a question back here.
How much is that bad boy transmitter and 6,500 weather radios cost? We're able to do every bit of that for less than $250,000. When it's all said and done, we're gonna have about 226,000 in it total.
We have another question.
What's your planned method of distribution once you get those radios to you, to the county?
We're gonna get a van and drive around and hand them out, but no, that's not how we do it.
We talked about several different things. We need an opportunity to test our reverse 911 system. We're going to notify everybody in the county of the date and time and have them to, if they're able to come to the county seat and pick them up probably on the courthouse lawn. And the ones that are not able, we'll be working with our fire departments and they'll be hand delivered from house to house if needed.
Okay, anybody else? Yes, sir.
With the more recent wireless emergency alert system that goes to everybody's cell phones, I think that's making a huge impact. Is that something you considered when you're trying to implement all this, as far as that this newer technology is hitting a lot of cell phones that people typically will have with them now, versus making this large investment? Now, the weather radio, I give it a lot of credit because it gives you a lot more information right there, but I'm just wondering if you took into account as far as people having access to that, at workplaces and that.
We did. The problem with that is when you start talking about small rural counties, small cell phone services, they can't handle the volume and there is a delay there. And to me, a 3-minute delay would be like that. That's the reason we went on with the reverse system we have. It does have that capability where we can tie it in. So it is there.
One of the things about phone service and phone systems, when there's a true emergency, the bandwidth usually goes to emergency responders. And in my understanding is that the local emergency management officials can actually take all the bandwidth from the sites to use for emergency response. That happened in Moore, Oklahoma, when the big tornado cut through there. There was a loss of cell coverage completely. You got people calling each other, sending video, streaming video, taking pictures, and then all the bandwidth is gone. So relying on a cell phone for everything, which many of us think we can, is really not a good idea. But having that as one of the warnings in your toolkit, the wheel alert is a great tool, and a lot of people are getting that alert. But you really have to layer for your personal protection. Start with the base of a weather radio, the phone call service, outdoor sirens, wheel alerts, wireless emergency alerts. That's the ones coming to your smartphones. And a lot of smartphones don't get them yet. You have to buy a 5, 6, or later, or with the newer droids to get the wheel alerts. So that's becoming more popular for mobile ones.
Yes, if you've heard me say it, those of you that have watched me, I've said it many times during severe weather, even before that, have more than 2 or 3 different ways to get your warnings, because if one goes down, then you can go to the next one. Just have some redundancy there, because you cannot always count on any of those coming through when you need them to.
Weather radio is not foolproof either.
Right.
I'm the first to say that. But it's a dedicated service to just warning you about the weather. And it comes straight from the National Weather Service. So the person who's actually writing the forecast, he or she hits the send button. Within seconds, it's waking that weather radio up in your home and giving you the message. So it's an instantaneous service, where some of the phone call services can only call 10 to 40,000 every 2 minutes. So it's always going to be a delay on the phone calls coming out. So it's an instantaneous device, and that's what is the beauty of having a $30 weather radio in your home. Oh yeah, it doesn't have a monthly charge either like phones. So, you know, I have a mobile phone, I have a smartphone, but this is $1,000 a year to have this phone. Pay the bill and own the phone. So comparing a $1,000 device, which is really a computer, to a $30 weather radio, it's a different technology, of course, but you know, having that base level and working up from there, we believe will save a lot of money.
Absolutely. All right. Well, thank you, Emery Kent. Let's give Emery a great hand and his comments. Thank you so much. Appreciate all the questions too. All right, we're going to keep it rolling here. Up next, the role of social media in weather, trusted sources, and impact messaging. And here to present that is going to be Buddy Rogers of the Kentucky Emergency Management. He is their public information officer. And following him will be Jennifer Rukavina from WPSD in Paducah. Buddy.
Hey, hi everybody, how are you all doing? I was actually asked to stall for a couple minutes and I think make some changes up in the audio room.
Buddy's messing with his UK hat, his lucky UK hat. He doesn't want anything to happen to that UK hat. Because if something happens to that, then
Something happens to the cats.
something happens to the cats, and that can't be good. Is everybody good so far? Everybody having a good time? Are you learning something? Good, good. That's what we want. Now make sure whether good or bad, you know, make sure you leave your comments on that sheet that I was telling you about, and make sure you turn that in at the end so that we can get some feedback on today. I would appreciate that.
We may have to go home.
Is it really stuck in the seat? What is the deal? Is that an omen of some kind? We got any Cincinnati fans here today?
Do we have any Cincinnati? One. See you
One,
later.
okay.
See you later. But anyway,
You're done. Escort them out.
anyway, I do believe in higher power, but I also believe in luck when it comes to my UK Wildcats. And I'm going to talk about routine messaging, but I also have certain routines I like to cast play. I wear a lucky shirt, it's on underneath here. I sit in my favorite chair, which is good, but I also have a lucky visor. So if you see me walk around today with this visor on, that's the reason. So, what kind of presentation? My role in Kentucky Emergency Management as public information officer, I'm also the outreach officer. And part of the outreach is it's basically constant communications with the public, with the media, with our partners, with elected officials. Every day I have to communicate and share information. And there's a difference between routine days, what we now refer to as blue sky days, and crisis or emergency events. We're having one right now with our presentation. So as we continue with our presentation, let me just ask a couple of questions. How many people are familiar and use social media? How many have more than one social media account? 3? 5? 10? 12? I have 16. 12 of them are active right now. And that it's a constant chore to try to keep up with all of us. If you don't use it on a regular basis, you're going to lose your audience. But in regular communications, in my job, and I'm sure there are several out here that have similar roles, there's various ways that I use social media. And there's various ways that we communicate without social media. And as a public information officer, some of those include press releases, conference calls with elected officials to give them information with our partners. We use press conferences. In fact, we just had one recently with the governor during a snow emergency.
They're working on it.
Do we need to take a break? Do you want to take a
They're trying to make sure that the computers are, that the projector is reading into the computer, so they're having a little issue with that.
So, well, let's
Yeah.
but anyway, during Blue Sky Days, there's several ways that I communicate with the media and the public and just normal activities. What I found, and it's true across the nation, as a public information officer for the state of Kentucky, it's important that I have an audience that relies on us for the information that we're sharing, because we need to be the official source. Yeah. Done. These are just some of the methods of carrying routine information or routine communications. And I mentioned some of them: the press releases, public service announcements, articles that I submit to other agencies for them to use. We did have a electronic newsletter. We just recently made the decision to stop using the newsletter because it's very cumbersome, very long. A lot of people don't want to read 8 pages of articles. So we're going to start a blog, and if you want to make a note of it, well, actually, we'll send out a link to be on our website. We're going to have 2 blogs. One will be for internal blogging and one for public blogging. But we're getting into blogging. Of course, we use our social media messages every day. Just about. There are some days when I'm overwhelmed and I can't do that. And I'll talk about that a little bit on crisis communications. We've got a link here. I don't know if it was working. I can say this is a form of just outreach message that we use during raining and flooding times.
Hi, I'm Buddy Rogers, Tech Emergency Management. With the recent heavy rains we've had across the Commonwealth, you may encounter water on the roadway. You may have traveled these roads many times, or you can travel through water like this, but you never know what the condition of the road is underneath that water. So if you encounter water on the roadway, do the right thing, protect yourself and your family. Stop, turn around, don't drown, get home safe.
That little yellow dog is not a very big yellow dog. It's hard to see some of your IT help here? I don't think it's.
You're trying to get back to the presentation?
Yeah.
Yeah, no. Stop using
Okay. It's really hard to see. Other forms of routine information communication that we send out are just outreach messages. We just completed last Tuesday, the 10th, the statewide tornado drill. We pushed that for about a month out. And part of our awareness campaign this year was 4 months. And if you notice on the right, this was in February. This was around Valentine's Day, and something that I had gotten from radio.gov. They had got it from another source that they allowed us to share it. This will keep Valentine's, since I won't be the only one to see y'all feed. Again, these are just normal routine messaging that we use social media for to push out to the public to try to make the public aware of dangers, weather-related dangers and other dangers that they face on a daily basis. Other outreach are events that we just, last Monday, we coordinated, the State Weather Preparedness Committee, coordinated the KET call-in shows for everyone staying safe. How many of you guys had the opportunity to watch that? Okay, I know you're all along with Lexington, but it'll be cached on their library shortly. They just had the last replay of it Thursday. So if you are interested in watching it, it's an hour-long show where panelists take calls from viewers. It's a lot of fun. It's a really quick hour. There's a lot of good information shared with the public. This is another annual outreach that we do. And again, we post this on social media and post it and as well. Crisis communications, I've got on here that can include public relations, damage control. And part of that is dealing with organizations and agencies and private corporations, your image. And when something bad happens, and I'll give you an example that we had 2 weeks ago during the snowstorm. On social media, we got hammered a couple times over the conditions of I-24 and I-65. We had people asking us why didn't Kentucky Emergency Management close down the interstates. They were complaining that they were stuck on the interstate. And I have to politically correctly tell them that Kentucky Emergency Management, we have no authority over the interstates or the highways. And we appreciate the concern. If they need help, we can give them help, things of that nature. And we use social media actually to try to locate people who needed help, make sure that local emergency management, National Guard knew their situation and was trying to get to them. We were encouraging people to stay with their vehicle, stay in the car. That was the safest way to not only ride out the storm, but wait until someone can come and bring you water and food and give you assistance as they could until things could get cleared up. But you'll notice the crisis communications, all of these different things, I'm sure you're aware of them. And again, we're talking about social media today and apps. There are apps that you can get on your phones, on your devices that will give you information that you can share as well. And then text alerts. I know we talked about it briefly, but one that I'll give out to you is follow KYN, text it 40404. And during certain emergencies, we will actually send out alerts via that way, and it's just another redundant source for you. Again, that's follow KYN, PIO 40404. This is an example of a routine. It's a crisis on an individual level. It's not a statewide crisis, but to show you the power of social media, this was a press release, or I'm sorry, this was a golden alert that was pushing out information from Mason County, a press release they had issued on a person that was missing. And they issued a golden alert. A golden alert is where someone has a cognitive impairment that affects their ability to rationalize, and by doing so, can put them in immediate danger. So I try to, every time I'm aware of a golden alert, I try to push it out on social media just to help out. And this particular post, we had just under 14,000 people reached it. In your communication on a regular basis, and I'm calling crisis communications, you should have a plan, and your plan should be written. You should practice the plan. Once you write it, don't put it up and forget about it. You need to practice it. You need to do it with yourself, with other people, with other agencies like we do at state government. We have drills and exercises, it seems like every week. But when you do that, you're making sure your plan works. It gives you opportunity to review the plan, what worked good, what did not work, what did the other thing. In your daily activities as an organization or an agency, you need to have a designated spokesperson and an alternate. For an example, back at the state, I was actually in Texas when the big snowstorm was in the the EOC, Emergency Operations Center, the week before during the bitter cold. And I had a planned vacation, was fortunate enough to go because I had a trained backup instead of being playing the role of the PIO once I'm away. And not only that, you should also have volunteers that will help you out. When it comes to social media, everybody can help. When they an agency or an organization, you have to coordinate with the person who's in charge of those pages or the sites and make sure that you become a trusted agent for them. But just the general public itself can help monitor situations in their communities and post information that can be shared and gathered back at the state level, which can increase the situational awareness for everybody, particularly those officials would have a play in the response. Then during a crisis, when you're gathering information, you need to make sure that information is accurate. For example, if I saw a post on Facebook that said, let's use I-24 for example. I-24 is shut down. There's snow everywhere. Cars are backed up. Everybody's stuck. I wouldn't automatically push that forward without making sure that it's accurate. Because if it weren't, then I have egg on my face in my agency and try to avoid that. But only that, in certain situations, you can push information and put the public in danger. So make sure that once you gather your facts, you trust that you verify those facts. And you need to identify your stakeholders. For me, again, it's the general public, it's the media, it's elected officials, it's our state partners, it's the community officials. So know who your audience is and try to target your messages accordingly. I talk about trust but verify. I can tell you a funny story when I first got in this business about 2 years ago. It wasn't pretty, but in a press release, I was given a number for Red Cross shelter manager in Louisville, and then another number for one in Cincinnati. And I was good. I was 2 weeks on the job. I went back to a guy who was training me, gave him those telephone numbers. He put it out in a press release. 5 minutes later, the Courier Journal called and said, "Hey, did you check those numbers?" And he found me, "Did you check them all?" "No, I got the Red Cross." One was to a house of prostitution, and one was to a warehouse in Kansas. And fortunately, I did not get fired because I was brand new. So I learned a valuable lesson from it. If you push out information on social media, make sure you verify that it's accurate before you push it out. And again, another method that I use are press conferences. Has something with social media, except the fact that we try to post those advisories to social media for those who are interested. And again, the middle comment bullet, one thing that I really like to use social media for is how quickly I can get information out. When I do a press release, it sometimes takes me 4 hours or a day to get it, to go through the vetting process to get it approved. When you're in a crisis, you need to get that information out now. And social media allows us that avenue to do so. It's quick, it's spontaneous. You should ask people to share it. Your audience will just continue to grow. This is a press release we had going back in the snowstorm back in February. Bitter cold, he came in the business of distributing water all around Kentucky. He distributed just over 400,000 gallons of water. I think 18 counties in eastern Kentucky, about 5 or 6 days. This is an outreach opportunity where the Lieutenant Governor is recognizing the storm rating program. That was a couple years ago down at the Capitol. And this was posted out on social media just for outreach, just make some awareness on the storm rating. It's just a press release over in Bullitt County a few years back. When you're dealing with those of you who have to deal with meetings in public on certain events, these are some good tips. You don't hide, which means you confront the issue. You tell what you know about it. You have to be transparent. You cannot ever, ever, ever lie. If you lie, then you destroy years of trust that you built with the media and the public, with your partners. And so if you can't tell what you know, the best thing you can do is say, I'm sorry, I can't address that right now, but what I can tell you is this. You give people information they can use. And that's called the bridging technique. And we all ask you to be brief. Same thing like a tweet. You've got 140 characters. And you probably know if you had to be real creative to get a message out in 140 characters. So same thing on all social media. Just be brief to the point, very simple language that everybody can understand. Be sincere. Show empathy. Be confident in your messaging. Let them know that you are the official source, and you build your audience that way. During a crisis, the public wants to know basically 5 things: what happened, what's being done, who's in charge, what can they, the public, do to help and protect themselves, and what next. Again, these are all important messages that I try to put out during a crisis and try to direct the public on what they can do to protect themselves and just give them some general information. Most people just want information, and information and communications in our society is growing by leaps and bounds because of new technology. I talked earlier about the communications plan. If you work with an agency or an organization, you need to make sure that you have a plan, you have a written plan. We call it the standard operations plan. I'm also in charge of the Joint Information Centers where other state PIOs come when we do have an activation of the Emergency Operations Center for support of an incident. And this is a physical place where we all sit and we gather and disseminate information. And so I have to maintain an SOP for that. And then within your SOP, you need to have a crisis communications plan, identifying how you differentiate between routine communications and crisis, and the messaging, how it's different. And I think Jennifer's going to talk a little bit about the types of messaging that we do these days. We try to call it impact messaging. It's more direct, more to the point, no fluff. But within your plan, you also need to have a social media plan. Identify how you're going to communicate through social media, what avenues you're going to use, who has the authority to post you're going to have, who gathers the information, who gets it back to you, and how to properly communicate with social media. Social media actually is just changing the world of emergency management throughout the nation. It's just amazing. About 7 or 8 years ago, about 8 years ago, I was in Memphis at a public information officer workshop. It was hosted by FEMA, and all the states were invited. There were about 300 people there. And they were talking, they had a briefing on social media. They asked the question, how many people use social media? Basically like wild ideas. Out of this room of about 300 people, there were maybe 10 or 12 people raised their hand. And other people looked around like, why? The very next year, it's the same type of workshop. They asked the same question again. About 80% of the people in attendance raised their hand. So it's growing by leaps and bounds. We can't keep up with it. There's so many different avenues that you can use social media for, so many different mechanisms that you can use to spread your message. I would encourage you, if you don't use social media as a way to communicate with your audience, you need to do so. I had to also just talk for a minute and give a kudos to Bruce Thomas and Midland Radio, a great partner for emergency management across the nation at different levels, locals and states and so forth. But I'm a big supporter of weather radio. Everywhere I go, I preach them, I push them. Because as it says here, the bottom line is they save lives. If you don't have one, get one. There, you know, you can buy them for $29, $30, all the way up to the very more sophisticated ones, but it's some of the best money you're ever spending. Anybody have any questions, or maybe we should wait till the very end?
We have time for a couple of questions.
Okay.
Do you want to ask Buddy a question? Hey, Buddy.
I'll ask the question. How many UK fans you have here? Thank you all for your attention. I appreciate having questions, see me. I would encourage you to go to kym.ky.gov. I'll say that again, kym.ky.gov. There you can follow us on the Facebook, you like us on Facebook, you can follow us on Twitter, you can go to our YouTube accounts. We have all sorts of PSAs there if you ever need them for any reason on different weather-related events. Just, again, kym.ky.gov, all sorts of information there. Thank you all.
All right, let's give Buddy a hand. And, one thing you need to know about Buddy is that he is really pretty much on call 24 hours a day and is at the beck and call of the governor, because when the governor makes a declaration for a disaster or a state of emergency like we were a couple of weeks ago, it could be something like the Bourbon fire that we had. What was that? But that's one of your roles is any kind of disaster like that where emergency services are called out, maybe sometimes the National Guard are called out. There's a disaster anywhere in Kentucky. Buddy is probably going to end up being there, being kind of the frontline public information officer to the rest of the state to let everybody else know what's going on in those disasters. So that's very important. So thank you, Buddy. All right, up next we have Jennifer Rukavina, who is with WPSD Channel 6 in Paducah. Jennifer.
There we go. Okay, I'm going to follow up with Buddy's presentation here on how we actually respond to crisis. In the research that I did and the presentation you're going to see, it has to do with tornado warnings. Similar research has been done across different parts of the country. I wanted to find out how we do in at least my viewing area, which also applies to the rest of the state of Kentucky, fairly rural, as well as Southern Illinois is what I cover, as well as Northwest Tennessee and Southeast Missouri. And I got responses from all of those areas. But before I do that, I want to play a video that I often play with this presentation. It's a couple years old now, but it was in a joint public awareness evening of severe weather presentations that we did with the Weather Service in Paducah. And it was really just to get the public involved, get some response from them, and give them an opportunity to ask questions to National Weather Service as well as meteorologists from my station. And out of that came my idea to do this research. But the video that we played that night kind of goes into everything. So I'm going to start with that video.
All I could see to my left was chaos. There was nothing there. All the apartments were gone. A night of severe weather with WPSD Local 6 and the Paducah National Weather Service.
He's putting down very heavy rainfall right now.
We're going to lose everything in a matter of 30 minutes, but it's just unbelievable.
Now this is, I don't know what to say, heartbreaking.
parts of Nashville that it nearly is reaching the electric lines. This was part of Interstate 24 Saturday. This portable school building crashed into submerged cars stranded on the highway. In fact, they say this is the most water the Boston Dam has discharged in its 45-year history.
Local folks I talked to say it's rising a foot an hour, and that's why there is such a sense of urgency.
We don't say most of that. Potentially catastrophic flooding. It's just disheartening the way to see the water coming.
With long periods of rain on the way, concerns now over property loss and life loss.
The rescue crews in the area urging people to evacuate their homes.
It's a matter. It's our community, it's our life, and we do it.
Through so many emotions there last night. You lay in bed, you hear that explosion and it rattles the house. I guess they got the last few nerves I had left.
Just about every house on this 4-mile stretch of road is surrounded by water, and that's what the Greens found when they got to their house.
Let's see, the storm brings some destructive winds and some large hail. Repeating, we have a tornado warning. I stay on to watch out for my family. Yes.
Tell people like this, and I've seen them just break down and cry, and that's all I can do to keep on. Watch they did it with that.
If you're watching from Saline County and Harrisburg area right now, please get to a safe place of shelter. Spotted a tornado with this storm.
Hopefully they didn't know anything ever happened.
Rescuers found her body streets away from her house.
All this unfolded right before our eyes.
They rated this storm as an EF4.
And of course, this tornado has garnered national attention because of the way that it swept through here.
It was at a peak wind of approximately 180 miles an hour.
It's such a different scene being here. You know, the devastation, it's one thing to see pictures, it's another thing to see video, but it is another thing completely to see it right in front of your face and to know the terror that so many people went through as they were in their homes yesterday morning around this time. It's just something that's really hard to imagine.
Day 2, and arguably the hardest part of today, will be going through what's left.
The scariest thing to me is we're dealing with the same jet stream that produced last year's tornadoes.
Folks at home, I guess it really hammers home the point that they need to be prepared.
I mean, in this case, what happened is this thing moved at 50 miles an hour. It literally pushed in the sides of the house, popped the roof up, and then it came on down on top of it. And then the storm was gone.
And sure where my kids were, and all I could think about was that I didn't want to live if my kids weren't alive.
I've already cried all morning, so we're all gonna be crying for a long time.
Walked down that stretch, which is a wonderful story given what we're looking at behind us.
Canceling a rental mother rode out the storm in a bathtub.
I felt all the force in the house.
There are some miracles in this circle.
Prepare now. Destructive weather will always be on the horizon. A community prepared is a community strong.
I could. See to my left was chaos. There was nothing.
Are you guys able to minimize that, possibly? There we go. And I love seeing so many students here this morning. There should be a play button at the top.
It's going to turn swamp. You're seeing the presenter view.
I don't know if they can.
I'm not that person.
I was the reason why everything was held up before because I'm now a person, but we'll see if they can figure it out here for a second, but I want to just make mention about this video. For those of you in school, emergency managers, public, all of what was going on in that video and living in the KenTenn area
the Ohio Valley. We're used to this weather, but this is why meteorologists do what they do, because of how it impacts the public, like you saw, those people. Those are the people that depend on us every single day, and why we try to get it right, and why we try to preach preparedness, so that they are better equipped to respond in the face of crisis, much like what Buddy was talking about. I'm gonna focus more on the severe weather side of things, and show you how in our region we tend to respond. Now, I did this research about 1.5 years ago, so some things have changed a little bit towards the social media side of things. We are in the process with the Kentucky Preparedness Committee of furthering this research a little more modern now that we've gotten into social media so much more even over the last year, so that we'll evolve that way too. I think we're good to go. Thanks, guys. Weather Ready Nation, you're gonna hear that theme more and more today, is a big part of my plan at WPSD Local 6. I became an ambassador about 1 year ago, shortly after the program was launched, and very proud of starting to use that, and I think across the country starting to gain ground. And Weather Service in Paducah, at least, that's who I work with closely. They're a big champion of that, and I think it's going to be a big success as more and more offices and the public gets involved even more. Nope. Go ahead. There we go. Now, doing this research, I had different goals in mind. And keep in mind, this is all geared towards severe weather, kind of moving away from the winter side of things. But I really wanted to gain insight into the awareness and reactions to tornado warnings. When those are issued, how does the public react? How do they, what is their perception and how do they react to it? And then I wanted to identify any weaknesses that there were out there. How can I, as a meteorologist on TV, communicate better so that people will respond better as well? And then develop a plan, which a lot of that now goes into Weather Ready Nation and using that more to educate the public. Here's a couple different views. This is from the Brookport tornado. And one of the biggest things that we battle in this region, the KenTenn region, is most of our supercell storms are high precipitation. You're almost never going to see that tornado coming because it's rain wrapped. And that was the case in Brookport. It's very hard to identify. I wish I had the name of the gentleman that was on the barge on the Ohio River that was taking this video, and I took a screenshot of it. But you can see what looks like just a big wall of rain coming down the Ohio River. That was the tornado. If you live in Brookport, you live over here on the right side, and that's what you're looking at as the storm is coming. That view up there in the top left is from the Carson Center, which is on the riverfront in Paducah, looking to the northwest. And down below was my view to the north from the TV station, which was about 2 miles, 3 miles from the storm. All of which were very difficult to see the actual tornado because it was rain wrapped. It looked like a big wall of clouds. In fact, when there was research done by the Weather Service, getting those accounts after the storm when they were doing their damage assessment, there were people that were outside looking for the tornado and didn't take cover, were either injured, and I believe in one case, a fatality, because they were out looking at the storm, trying to see the tornado. Well, you couldn't see it until it was upon you. Now, this is the survey that I did then in response to our night of severe weather talk that we had with the public. And then when the Brookport tornado happened a few months later, I launched it on a bigger scale. It went out to 500 people across the local 6 area. They were allowed to remain anonymous, but they told me if they were male or female, where their zip code was, so I knew exactly what kind of sample I was getting across our area, and how old they were, so I could get a demographic of young versus an older generation, and how people respond differently that way. So this is kind of what it looked like. It was pretty generic. I tried to keep it very plain, so it wasn't too glamorous or anything, but as we go ahead, just want to show you some of the responses that I got to these questions, because they're very telling as to what direction we need to move in as we get into preparedness on severe weather days. When they took the survey that day, do you have a safety plan in the event of a warning for your area? A nice 80% said yes, but still 21% said no. So the 21% of these people in our area are just not planning ahead. That's something we have to work on. We'd like to see 100%. That's not likely, but we'd like to continue to grow that 79%. Do you plan on making changes or improving your safety plan for future warnings? So if you didn't have a warning, if you didn't have a plan, are you going to make a plan? 32% said yes. 34% said no, even though they were sitting at or reading about severe weather that had just happened. Maybe 34%. So close to 60% were going to either improve their plan or make a plan. For response, I asked people what their first reaction to a newly issued warning was for their area. I was kind of surprised to see 33% be such a high number, I guess, for taking shelter, but 27% go and check another source before they take any action at all. 25% wait for the storm to get there. 2% no reaction, and you're going to have that set of people that just, they don't care about a plan, they don't think it's going to happen to them. You're just not going to reach every single person. But and I also asked, what kind of structure do you live in? Or do you shelter in? I was surprised to see the number so high for a storm shelter or basement, because in my area, at least, the river area, we don't have basements there. Not many people have basements, but a lot of them are starting to get storm shelters, but most take shelter in an interior room in a wood-built structure. We do have a population across the state, too, of manufactured homes, mobile homes. That's somewhere we have to improve upon, is getting people educated as to where they can go beforehand, making that plan so that they know well in advance to get out before a tornado warning is issued for their area. All right, now this is where we start to break down where social media comes in, the different ways people are warned. And you can see here, I asked them, they had to pick just one. What is your primary source to receive severe weather warnings? Overwhelming, you can see number one, social media was number one, and I'll bet that number is bigger today. Local media was 32%, so kind of neck and neck there, the local broadcast. I was very happy to see that weather radio was 25%, considering the other two, that's a fairly high number. And then outdoor siren was 5%, which we see that across the state, at least in Kentucky, as kind of a running theme as well. People are still trying to rely on their outdoor sirens to wake them at night. One good example was Harrisburg, Illinois. A lot of people didn't hear them. Either one, the power went out as the storm was coming into town, and the siren wasn't working, or number two, those that did hear it, heard it very briefly, then it went out, or it was 6 a.m. in the morning and they were asleep. And with the heat, the air going on, you're not gonna hear those outdoor sirens. Then I asked to check all sources that you use to keep updated or receive weather information, and I was happy to see, as a local TV meteorologist, that 91% still tune in to get their information from us, mainly because they want to see the radar. That's the quickest way to see what's coming. But then social media, 74% use social media, Facebook or Twitter, to get their information. And we're seeing more and more of that, because when people take shelter, they take their phone with them, and they're trying to get updates that way. Mobile alerts and texts, a lot of people are going that way. Weather radio, a very high number in the local 6 area. We do a lot of promotion and special events around Midland weather radios. Bruce helps us out a lot with that. And the National Weather Service in Paducah has the largest, Rick?
It is the highest frequency of ownership of weather radio for the size of population of anywhere in the country.
It's the largest in the country, and that's because meteorologists at my station, the CBS affiliate, the ABC affiliate, all have these campaigns running through Midland Weather Radio. And immediately after a big event like Evansville, when that happened, Madisonville, Harrisburg, Brookport, we immediately get out in the community and press the weather radios when it's fresh in their mind and they feel like they needed that added protection. So That's a big reason, and the Weather Service comes out and helps program those weather radios as well, so everyone's all set that way. But you can also see weather call is another instrument that we use. We promote several different ways to get warnings because it's evident that people need that. Power goes out, social media goes down, the TV goes out. You have several ways to get information. I think the big thing coming out of that, though, is where social media is taking us for weather preparedness. And we'll get into that in just a second. But as for weather radios and outdoor sirens, I ask people how audible are those outdoor sirens from inside their home or residence. And a good majority say very audible or barely audible, but a lot of them also admit that it's not very audible or they're not sure. And I think that question alone maybe gets them thinking, well, maybe that's not my source for a warning. But across the state, we're still working on that education as well. If you have a weather radio, do you have it programmed? When I asked if they had them, there was a very overwhelming, yes, we have a weather radio. But then, do you have it programmed county specific? Only just over half have it programmed. 30% said no and 8% not sure, so close to 40% probably doesn't have it programmed and probably not using it because if it goes off too often, especially during an event, you just unplug it. So it's getting people to get those programmed. Also, I ask people what aspect of severe weather coverage on TV is most helpful. This is more for the broadcaster side because I wanted to know what I did that helped and what maybe I needed to do more of. And of course, everyone likes to see the projected path of the storm, kind of tracking it out. Next half hour, they like to see those arrival times. And the cities, they also like the looping radar because a lot of times people like to see where it's coming from. But then 5%, which we've started to hear in different markets, is the urgency and tone of the broadcaster's voice. And Buddy touched on this a little bit on kind of the voice in crisis. If you add an added element, your voice becomes more serious. A lot of the meteorologists in the room here know that when you're in the middle of a tornado outbreak, you become very serious and matter of fact about how dangerous the situation is. And people can hear that. But also adding features to the radar. In the Brookport instance, we put on take cover now in huge letters because we could see it from our sky tracker. Several reports from the Weather Service, this thing was spotted. You don't need to check another source, you need to take cover now. And some people did. We got response that people actually saw that and that's what made them go along with the urgency and the voice. And then a lot of people, whether they put that as their first choice or not, they like to see video and pictures of the storm. That's why they go outside to see it coming, is because they want that visual confirmation that the storm is coming. So taking all of that, and there were a couple additional things too, but those were the main points within the research. Social media is so critical right now. How many students out here use social media as one of their main ways to get weather updates or share weather information? A few of you? How many emergency managers use social media to push out information on the day of severe weather? A lot of you out there. We have to staff an additional meteorologist during tornado outbreaks to just dedicate themselves to social media now because it is such a big part of what we do, but you can't be on TV, run a radar, and post social media all real time with one person. So that's another thing that's evolving in TV meteorology. But becoming storm ready and with the Weather Ready Nation program, so much of what we do these days is trying to give people, viewers, the tools to prepare themselves, to help themselves. In the day of social media, everyone wants instant information. But what we're starting to learn is that we need to give people the tools to help themselves because they want to ask questions during the storm, during tornado coverage. Well, I'm on TV. I can't answer questions on social media because I'm so available on social media, but I can't be that available during a storm. So we need to prepare people, give them the tools so that they can prepare themselves ahead of time and really stress that. At our station, we've started this thing called Weather Authority Alert Days. And it's usually within 24 hours of a large scale event. You do it in the wintertime too. We did it for the last 2 big winter storms. But for severe weather, it's all about preparedness. You'll see these on TV during commercial breaks. You'll see them on social media. It's an added element of awareness so that people may not have a plan necessarily, but in the back of their heads, they know something's going to happen tomorrow. And maybe that's where we start, is making sure someone knows it's going to happen. With Weather Ready Nation, if you guys will click that link, this is an example of how I'm starting to integrate it into my newscasts. Hopefully it won't play a commercial first. There we go. There we go. At least it's a nice commercial. But I do this in advance of severe weather, winter weather, extreme cold, extreme heat. But this is how I've started to integrate. Overnight, tonight, throughout the day. Are you able to scroll down now on your preparedness list, of course, was hazardous road conditions that continue and some of that refreezing that will happen overnight tonight with those sub-zero temperatures. With that being said, those record sub-zero temperatures will come in after midnight tonight. And so keep in mind, check on your neighbors. This is kind of a personal plea to everybody. Check on your neighbors, your friends, and pets and livestock. Make sure that those pets and livestock have adequate bedding as well as some unfrozen water so they don't get dehydrated. Check on neighbors. We've lost some people in our local 6 viewing area because of the cold and going out, checking on mailboxes and that sort of thing. So check on your neighbors, and if you know of anybody that needs to make use of those warming centers, give them a ride, help them out, and let them find some adequate warmth. And if you are using an alternate heat source overnight tonight, make sure you're doing it safely and make sure it's vented. Okay, all those things in mind. Look at this gorgeous sunset tonight from Discovery. You get the general idea. America. It's something that I share on social media too, but I give them a checklist. People are tuning in to watch the weather. Not everyone does have social media in the KenTenn area. We have a lot of rural areas that just don't have that kind of access. So I want to give them a checklist. These are the things that are important today to prepare yourself for. And that's how I started to use Weather Ready Nation. It's not real glitzy, but it gets me into that serious mode. This weather that's headed our way is serious, and these are the things you need to prepare for. I'd love your feedback. The research is evolving. We're trying to move it forward in the next severe weather. We've kind of been waiting for winter to be over because it's hard to get people into severe weather mode when you've got a foot of snow on the ground. But you know, I want your feedback. How do we help, and what are some of the struggles that you as the public or you as emergency managers, what are you going through in keeping from preventing or preparing the public?
Any questions for Jennifer? Yes.
How exactly, because I did some meteorological research on the April 3rd and 4th, 1974 event, and I saw that the core of it occurred east of Paducah, and I was wondering if something like that were to happen again, how would you all be able to communicate to the Lexington and Louisville stations of how dangerous the outbreak could be, because that affected Cincinnati, Louisville, much of Tennessee, Indiana. Xenia got hit. A lot of those tornadoes were EF4 or higher, and that's still a record. That outbreak still has records with it. It's the most violent outbreak in the United States still.
Well, I think that starts really at the government level, because now that we have the Storm Prediction Center and the local National Weather Service offices working very closely, especially during outbreak days. We see this with the moderate risk, the high risks that come out days in advance, at least 24 hours in advance, so that the public is aware. They communicate that to the local meteorologists, and the offices work really well together. They're all represented here, the local National Weather Service offices. They work jointly and making sure that they have that threat communicated office to office. I don't know if, Rick, you want to talk about that, or Joe? I don't know where Joe is. There he is.
How we communicate during severe weather. We have an open chat group with the media and emergency managers called NWS Chat, and we can get into each other's rooms, we get back and forth. I think I can speak for Ricky when I say that compared to what we were able to do 10 or 15 years ago, it was changing information internally amongst all the meteorologists and in the various offices and the TV stations. We're all on the same page now than we were before. We were all pretty much, flying, not blind, but we were all working with bits of information, and we weren't able to share it as easily as we can now. And so I think we're doing a much better we're doing much better at speaking with one voice. I think that showed up on both the leap day tornadoes that you talked about and the March 2nd tornadoes that came just a couple of days later. I think that was probably my almost 30 years of experience in television and National Weather Service, probably the best, most coordinated, well forecast and well worn day that I've experienced in my career.
And not to forget too, the spotter network has grown immensely over the last 5 to 10 years, and that has really helped, especially in the rural areas, in the KenTenn area. The spotters really help verify what's going on at the ground. They have been a tremendous help too. I've had, I think it was Chris back there in the back in Union City, am I right?
Yep.
That we were able to get that tornado warning at least verified because you were there on that storm spotting for it and continued to track it all the way down to Mackenzie, I believe. And we were able to stay on the air because we had a verified threat that a tornado was doing damage down there. So the spotter network has also been tremendous in helping both Weather Service and the TV meteorologists. Anyone else?
Any other questions?
Yeah, when it comes to Facebook and Twitter on social media, Facebook is typically one of the most popular, but with the algorithms they have,
right,
sometimes they can't see the tornado warning until maybe the day after. So for PSD, what do you all do in promoting Twitter over Facebook? Because some people still in severe weather strikes, they go to Facebook to get that information, and sometimes they don't see it on the news feed.
And that's why we push having multiple ways to get information because of that Facebook. We actually use a third party, so it's even more bogged down for us, but it's how we distribute our information. Now with Twitter, it's great. I love Twitter, but in our local, at least in the local 6 area, no one uses it. I get on there to follow all the meteorologists across the country and find out what's going on more than I do the local meteorologists or the local area.
Our station actually did some research on that, and we found that only 2% actually use Twitter. And so neither one of those social media platforms are good for warnings. In fact, we have made it a practice not to put those out onto social media, either Facebook or Twitter from now on, because it's just either they're not engaged or, as Andrew was making the statement, the algorithms that Facebook has put out there, it throttles it back to a point to where it could be actually dangerous.
Right.
Because it's after the fact.
I think one thing that we do provide with Facebook, at least, is we have a kind of a banner at the bottom that clearly shows the timestamp when it was sent out, so that, you know, with Twitter, sometimes you can't see what time it is because it's been retweeted, then it's more recent, and we make sure that's on all of our graphics so that it's clear and present what the graphic is showing.
Yeah, that's the thing. The algorithms are going to be a problem with Twitter as well. So I think that's going to be just something that we're going to have to deal with, and just, again, direct people to the right places to get the information and have those 2 or 3 different ways to get your warnings, as we've stated before.
We also, I mean, we promote the Weather Service line, and I know you do too, where they can call in, where the spotters can call in information. And then, like you said, the chat room is vital to us because we're in there real time with the meteorologists at the National Weather Service. We see what they're doing, what reports are coming in from emergency managers, and it allows us to get on the air faster than waiting for a report to get printed out somewhere and then to us. So that's been a big, big help.
All right. Thank you, Jennifer. Appreciate it very much. Give Jennifer a hand. And we're running just a little bit behind, but not too much. We'll make sure we do get your lunch break going on here in just a few minutes. One more presentation before the lunch break. This is about radar interpretation, squall lines, tornadic debris signatures. And here to present that is Angie Lease from National Weather Service Office in Nashville. Angie.
Thank you. We'll go ahead and get that presentation loaded up. I want to thank Chris Allen and Joe Sullivan for putting this together and having me and a cohort from the National Weather Service, Sam Shammer, you'll hear him talk later. I want to thank you all for organizing this and having me here today. So who here knows how to read radar pretty well? Anybody? I'm sure students, emergency managers, anybody not know a thing about radar? Okay, good. So I'm going to go into a little bit of the nerd stuff about it. I'm supposed to be giving this talk with Pat Spoden. He's my counterpart at the Weather Service in Paducah. We're both the Science and Operations Officers. But unfortunately, we had a dear colleague of ours pass away, and he's at that funeral. If you know anything about squall lines and bow echoes, then you've heard of the name Ron Krismalinski. He was a pioneer in our in all of weather, and he's a pioneer for squall lines. So it's unfortunate, but I wouldn't be here today if it weren't for his support. So I want to sort of thank him for that. But I'm going to be talking about tornado debris signatures. We can see them in radar and how we can use them for significant tornado outbreaks, but more especially squall lines. Bow echoes and squall lines are a little bit more difficult to detect. But to start there, we need to know a little bit. Okay. All right, there we go. Need to know a little bit about how the radar works. How Doppler radar works is it sends one horizontal radar beam out, radio wave out. It bounces off hydrometeors, birds, dirt in the air, whatever it is, debris, and it comes back to the radar. And that tells us a little bit about what's out there. Dual polarization radar is exactly that. It's two, instead of one radio wave, it's two now, not just horizontal, but a vertical slice. So now we can tell a little bit more about objects that are in the air. So old conventional radar, the Doppler radar technology, would just tell us where the objects are and basically the size of the objects we're looking at. Now with dual polarization, we can not only tell where the location of these objects are or the size, but we can tell the shape of these and the variety of the objects. So not only can we tell where there's hail, we can kind of have a little bit of idea of how big the hail is. We can tell rain versus hail. We can tell snow versus sleet. It's really revolutionized the way we can read radar, and that is going to help us read radar during tornado outbreaks too. We're able to see tornado debris signatures from this new radar technology. So I'm going to throw a couple of these objects out at you. It's two products from the dual polarization radar where we can detect different kinds of stuff in the atmosphere, and we can really read it well on radar. One is called differential reflectivity. And it sounds fancy, but what this tool does is it just it's a good indicator of basically the drop size or the drop shape of the hydrometeor that we're looking at. When the radar goes out and takes a slice horizontally and vertically, we're able to tell the size and shape of whatever it's bouncing off of, right? So with that, we're able to tell the objects in the air if they're spherical, if they're more vertical, if they're more pancake shaped, horizontally speaking. So we're able to tell what we're looking at. Are we looking at a perfectly circle-shaped or spherically shaped hailstone? Or are we looking at more kind of like a dagger or ice or something like that? We're able to tell that difference now, which is really great. So if we're looking at something that's spherical, that means that it's as tall as it is wide. So it looks more like a circle. So that's going to give us a value of differential reflectivity around 0. It's ZDR for short. Z is reflectivity. So we're able to look at that on radar, which does this have a laser pointer? I don't want to use it just in case. So over here on the right, the image in the middle there is kind of showing this area near zero. And what that is telling us is we're looking at hailstones that are pretty spherically shaped. The larger the hail, the more spherical it is, but when you get up to extreme hail size, like softball size, that kind of extreme hail, you can get values even less than 0. But we can tell a little bit about the shape and then the type of objects we're looking at. So where tornado debris falls on that, it's usually, the shape of the debris is really sporadic. It's not a perfect circle most of the time, anything that's flying in the air. So you're gonna get values less than 0. You're gonna get values that are generally taller than they are wider. So just, basically any kind of shrapnel that's flying in debris of a tornado, it's going to be that shape. So values around 0 or lower are generally gonna tell us that we're looking at tornado debris. Another, especially this one, another product of dual polarization radar is correlation coefficient. What this tells us is it uses ZDR sort of. It looks at the different shapes and different objects that are in a volume, but it compares them. So in one slice, the radar will tell us if we're looking at a bunch of raindrops, if we're looking at a bunch of hail, if we're looking at a combination or a mixture of the two. It'll tell us if we're looking at a bunch of a wide variety of objects, aka debris. This is a really, really good tool that we use and we rely on heavily when we're issuing tornado warnings. The problem is it's an after fact. We should already have a tornado warning out before we see debris on radar, obviously. But what this does is it gives the forecaster confidence of what we're looking at, and it can convey that, okay, this tornado warning isn't the crying wolf tornado warning. This is the one where you need to be serious and take action, as you should to all of them. But this will convey our confidence if we know a tornado is already on the ground doing damage and we can see the debris on radar. So if you take, in this example here, I've got 3 images in the middle. You can see the higher reflectivity on the left. In the middle, you have ZDR values near 0. And then on the right, you have a moderate CC. Correlation coefficient near 1 would mean I'm looking at all snow or all rain. You're looking at the same thing. Lower values is a mixture. So 0.9, 0.8, you're looking at large hail mixing in with raindrops, whatever. And especially even lower on that correlation, you're going to be looking at debris. So the lower correlated, the lesser correlated that the volume scan is, the more you're looking at debris, or more than likely. In this case, if you have like a moderate value of CC, maybe 0.9, 0.85, something like that, and it's in a heavy reflectivity area, you're looking at a hail shaft here in this example. So we're able to see these things on radar now. But very low CC values, we're generally going to be looking at extremely large hail or tornado debris. So I can fly through these slides. Just if you look at the bottom, here's the ZDR chart that our meteorologists can use in real time. So anything less than 2, we can kind of look at on radar. As long as it matches up with a velocity signature and it makes sense with the radar, then we can have more confidence that we're looking at debris. Same thing with correlation coefficient. Anything less than 0.9, 0.8, 0.7, especially when you get into the blue colors, the 0.6, 0.5, then we're really talking about tornado debris there or something completely not correlated with each other. So we can use these in real time and have a little bit more confidence about finding what a tornado debris signature is on radar. So how do we find that? First, we identify a velocity signature. We want to look for raindrops moving towards the radar and then moving away from the radar very close to each other. So we want to find a velocity couplet, which we have here. We want that to make sense with the reflectivity signature. Here we have a supercell on the left and a hook echo. That makes sense, a velocity couplet where the hook echo is. Then if we look at low CC, or if we look at the CC, the correlation coefficient, notice right where that circulation is, there's a large area of very low CC. That's debris in the air. That's debris already occurring with that tornado. And then if we correlate that with ZDR, ZDR is at or just below 0 in that same area. So that gives us high confidence that we're looking at a tornado on the ground with this example. And here's another example. Have a hook echo on the upper left with high DBZ values, high reflectivity values. A velocity couplet here on the upper right. The bottom right, low CC signature in the same spot, low ZDR, right around 0 basically, and sometimes negative. So that would be another example of a tornado debris signature, or TDS. These are going to be harder to see farther from the radar, but if you see it far from the radar, that'll give us extra confidence that we're looking at a pretty strong tornado. Okay, so the first and foremost thing though, we need to make sure the environment's right. We need to know that the environment's right for tornadoes to form. Then we look for that good velocity couplet. Does it match a good reflectivity signature? We want it to make sense conceptually. Is there a low correlation coefficient signature in the same spot as the two previous? Are ZDR values at or around 0 or below 0? If you say yes to all the above, then you're looking at a tornado debris signature. And it does help if you look for height and time continuity for added confidence. Usually the longer a tornado is on the ground, the debris is going to be lofted higher and higher. I'll show you an example of that. A good example of TDS is in a squall line case, which is much more rare. You need to keep in mind, much more rare to see, was the 2013 squall line on Halloween night. And actually, that was in the Paducah area. It was more like southeast Missouri. I'm not sure you can all see that, but southeast Missouri crossing over the river and then into Paducah's area. Here you can see tracks of mostly EF0 and EF1 tornadoes. But there was one EF2 that formed southeast of Dexter, Missouri, and we'll talk about that here in a second. So here's an example of the Dexter tornado. Now the image in the upper left, this is GR Analyst. How many of you have this software program? Okay, if you're real into science and real nerdy, this is a good program to buy so you can have at home. I really, I'm not really supposed to plug anything, but we use it quite often, and it's really, really reliable. It's nice. So what this GR Analyst program shows is radars from across the country. So here's an example in the upper left of the correlation coefficient image of this tornado. The bottom right, you can see the velocity couplet just southwest of Dexter, and the bow echo starting to form. It's kind of in the wraparound bookend of the bow echo here. And that's the one problem with squall line tornadoes, or bow echo tornadoes. Oftentimes the tornadoes are going to be rain wrapped and sometimes at the back of the storm, not at the front. Sometimes they are leading edge tornadoes, but in this particular one, this is at the back. But the challenge with for us forecasters is that it's really hard to issue tornado warnings for squall line tornadoes. But here's an example of one where we could have confidence, because you can see the tornado debris signature, the dark blue spot in the correlation coefficient product. That is correlated perfectly with the reflectivity signature and the velocity signature, so the forecaster can have confidence, yes, this is a tornado on the ground. Keep in mind the height. This was debris up to 8,000 feet, okay? Keep that in the back of your mind. So if we go forward in time, you still have the velocity couplet, and you can see the debris with time. Instead of just being that little spot, it starts spreading outward. That makes sense. The more downstream the wind is blowing and the storm's going, your debris is going to be scattered about more. But both of these times at, I guess it was just after 6 p.m. that tornado formed. 5 minutes later and another 5 minutes later, you can see that debris signature spreading out, but still up to around 8,000 feet. So if we keep going in time from left to right, I wish I had a laser pointer. You can see that there is the velocity signature continues, but a new one forms just southeast of it, within a couple miles of that initial tornado. And if you look at the low CC signatures, it's pretty spread out and weak on the far left image, but in the center, just southeast of that, there's a stronger low correlation coefficient value. It's dark blue near this little town of Baker. And you can see even to the right here, that debris signature took over as the other one weakened. So here you've got basically two tornadoes on the ground, or one had just lifted and the debris is still there, and the next one had already formed and that one's on the ground. So we can see a lot with this new technology as long as you're pretty close to the radar. So that's kind of interesting there. But you can tell, maybe not by the velocity signature, but by the height of that debris. The height of this secondary tornado went up to 12,000 feet instead of just 8,000 feet. So keep that in mind, the difference of those two. And if we keep going, you can see how strong and large that tornado debris signature is with time. And here's another example of another one forming downstream, and just to the, I guess, southeast of that initial tornado warning, or the initial tornado at 0039Z right there in the middle. So you've got two tornadoes on the ground basically within one bow echo and within a short amount of distance from each other. So I guess if you're a warning forecaster in this scenario, you're generally going to have one large tornado warning out. But in the product, we can say one tornado is lofting debris in this part. Just 2 miles away, another tornado further south and east is going to do damage along this path. So we can really get specific with the path of these, which is really great. Again, it's difficult to warn on squall lines and bow echo tornadoes, but at least this can give the forecaster much added confidence, which we really do lack when we have these situations. Okay, so here, once this squall line or bow echo got into Kentucky, we got really close to the Paducah radar, and you could see the low CC signatures along with a couple points within the reflectivity. But when you get close to the radar, it's really difficult to see at the lowest level. Sometimes you get a lot of ground clutter in the way. So if you have a program like this, or us forecasters do, obviously, we can go up to the next level to get above that clutter, and you should still see debris, which we still do. We still have debris, and at this time, in two spots, really close to the Paducah radar. And if you look at reflectivity, notice one of the, I guess this was near Blandville, southwest of Paducah, one tornado was on the leading edge, one was still in that wraparound bookend. So one you might see coming if it was illuminated by lightning, and the other you probably wouldn't see coming because it was completely wrapped in rain. And what's funny about these low CC signatures is they're going to come and go as fast as the tornado is there. And unfortunately, in the second image here, you have the old debris signature southeast of the radar there, but another one along the leading edge, which was unwarned. Although there weren't reports of damage, which is good, what happened was a tornado probably formed there. I'd have to see the velocity signature to validate that, but it looks like a debris ball basically, as a low CC signature here. It's likely that they missed a tornado. So what we can go back and look at an event like this, go to that area, or have the emergency manager go to that area and see if there is damage. The good thing about this is probably nobody got hurt, didn't hit a home. It might have been just wood debris or something like that in the forest, which is good news. But this can also humble us a little bit too, so we can see tornadoes that we can potentially miss. Okay, so I mentioned before that first Dexter tornado was an EF1. The second one that formed just southeast of it was an EF2. The difference in the debris height was from 8,000 to 12,000 feet. If you look at this chart, there's been some research from the Jackson, Mississippi Weather Service office, and they took, I guess, a sample size of almost 200 tornadoes that had debris signatures, and they looked at how high that debris went. And then they broke it up between supercells and then squall line and bow echo tornadoes. With supercell tornadoes, there's almost a clear threshold, 10,000 feet. If you have debris over 10,000 feet, you're looking at a strong or violent tornado. If it's below 10,000 feet, you're most likely looking at a weak tornado. So not only can the forecaster be confident of a tornado on the ground, but now we can be confident of the type of damage you're going to see. So this has really kind of revolutionized everything. But the problem is in squall lines, it doesn't work that way. You can see the 10,000 mark. There's a whole lot of overlap between EF1s and EF2s and 3s. Generally, EF3 is about the strongest you're going to get with a squall line tornado. But look how far that debris spreads, basically 7,500 feet up to at least 13,000 feet. So the reason that is, if you think about it, squall lines and bow echoes move really fast. Their translation speed is fast from west to east. Supercells have a much, much stronger updraft. Squall lines that move faster west to east, generally speaking. It's not always the case, but the updrafts are not nearly as strong as they are in supercells. So it's not going to loft the debris as high in a squall line as they do in supercells. It's going to just basically destroy something and blow it out to the east. So that's why the debris height won't be as high in squall lines. So even though that was a squall line, maybe at least a hybrid squall line in the other case, that it still kind of worked for the supercell. The first storm was an EF1 and it had debris up to 8,000 feet. The second one was an EF2 and it had debris to 12,000 feet. So it kind of worked in this case. An example of an exception to the rule was a case we had just east of Nashville. This was a January 30th, 2013 tornado outbreak. And just east of the radar, within a couple miles of the radar, we had an EF2 form, and you can see the hook echo due east of the radar there. And then this is a 3-panel of the correlation coefficient. The lowest one's in the upper right with that circulation. You can see the circulation there. I went up another height there, still debris. I went up to the highest place I could find debris. Well, that was only 1,400 feet. The highest debris I saw on radar was 1,400 feet. That's nothing, but the damage was pretty incredible for a squall line. It was a good EF2 damage that we saw with that tornado. So there are exceptions to that rule, but it's something to be aware of, that when you see tornado warnings come out of weather service offices now, we've got this technology that can give us confidence, not only that a squall line tornado has formed and is on the ground doing damage, but we can kind of predict a little bit about the strength as well.
Okay, any questions for Angie? Any questions at all? All right. Angie, thank you so much. Let's give Angie a hand. All right, the time has come to have lunch. I know that you're hungry and you want to take a break. So what we're going to do is, during this time of lunch, Chris Conley, who is in the back, in the corner there, raise your hand, Chris. He is with Mean Motion Media. He is also part of our NWA chapter team here, and he is providing live streaming of this event today, as I mentioned at the very beginning. But during the time that you're eating and just having conversation, just feel free to roam around. They're going to play a video of some of his spotting and some of the storm chases that he's been on in recent times, and you're going to see that on the video screen. So when you're seeing that, you can watch that as you're eating, or you can converse. You know, you guys just move around and move about as much as you want to in these next few minutes. Also, what we're going to need you to do is, everything is on the back table as far as their box lunches. So we need to form a line in this direction of these steps, and then go up and then serve yourself, and then come back around and be seated. Do not carry the food out into the museum. Please keep everything in here. And then if you would, please pick up after yourself so we don't get fussed out by nice Corvette museum folks. So if you would, just help yourself. There should be plenty for everybody, 1 box per person. Thank you.
Same time as Brian. Yeah, I do. Yeah, like I know him from like years back, but I never like went to school with him at the same time. I ever worked with him, but I knew.
That's
You know, with the safe houses and safe rooms and all like that. And weather radios for residents.
Did you say confession or concession? We should all get along. Sooner or later, that'll change. We just gotta play that.
Yeah. Yeah. Oh, yeah. So No, it was pretty good. Yeah, that's 13. 13. Yeah.
Oh, did you?
We were 300.
No, it's too dangerous.
You know Dean Hunter? Yeah. I've worked with Dean on occasion.
Okay, yeah.
Prior to him was Jeremy High.
I was just scrambling this year. I understand.
Go ahead.
I got to see all
Hey, while you guys are eating lunch and enjoying the video, just a reminder, even though we didn't put a place for your name on the survey sheet, we don't necessarily need to know the name when you turn in your survey, but I guess what we'll need to do for the door prizes, the weather radios that we're going to give away at the end, if you would just like write your name, say in the bottom corner of that sheet, and then maybe tear that off, and then we'll pass around something, we'll put everybody's name in, and then we'll draw out names for weather radios. So just be thinking about that as we get closer to the end here, and then we'll make sure that everybody gets their name in the head for weather radios. Thank you.
Hey, Bruce Jones or Bruce Thomas? Back in late 80s, mid to late 80s. Yeah. I was working for a tank pilot in West Africa. We had a tornado come down. And the clouds and probably 20,000 feet. It was up on the it was like thing down, and like it was up there 45 minutes. It didn't hurt.
part of your admission price is to sit and watch us eat. We could do Mystery Science Theater. Good. I know that's what I just said. You didn't hear.
Personally, I would have had to have gone right past home there. North Metcalf. North Metcalf.
Hey, now I'm trying to figure out how to turn the lights on. I don't really want to see it.
Hey, Chris, Conley, where is this at?
That's Union City, Tennessee.
Union City.
Yeah, all these videos are shot local in the area.
Here, why don't you take the microphone and just tell us what we're looking at? I think that'd be helpful. Yeah, this is Chris Conley, Mean Motion Media. Hey guys, thanks for having me here. Everybody hear me? Okay. All right. So what we're seeing here, this is Union City, Tennessee, right inside the hook. Probably about 400 yards away. Believe it or not, there's a rain rack tornado in there. EF2's on the ground for about 15 miles. So this is the, if not the most dramatic supercell that I've seen east of Mississippi. And you'll see here later the incredible wall cloud structure that we had. I can't believe that it didn't produce another one. Yeah, kind of. You just can't really see it. It's on the back edge back there. We're probably 600, 700 yards from it. Not really.
The inflow coming into it was incredible. I mean, that's all you heard was wind in the trees. I haven't witnessed very many supercells of this type of structure anywhere east of Mississippi. The incredible part about this day, we were kind of poised to go to Southern Illinois. That's where everybody said the big tornado outbreak was going to be. Before we got to a place we had to make a decision, we kind of looked at the high-res models, and it looked like the best lifted index, those are the best cape and the best shear was going to be down in western Tennessee. So we changed our mind and shot south. And at this point, I'd like to give a shout out to NWS Paducah. I didn't have Memphis's phone number, so I called them instead, and they relayed all this information. That's something I didn't mention when Jennifer asked a question about, someone asked a question about contacting each other and how we stay in touch during severe weather events. But Bob Palmer, the emergency manager in Simpson County, just south of here, reminded me that about the conference calls that we did. We don't do conference calls during the warnings, but we do conference calls the day before when we expect something like this to happen. So that we're getting folks, as many folks as we can. We've had some of the snowstorms here in the last couple of weeks. We've had 270 folks on our conference calls. And generally, it's anyone who's, you're allowed to get on it as long as you have some sort of public safety, emergency management aspect of your job, whether it's an official title of emergency manager, whether you're the building supervisor for a factory, for the Corvette plant. We want someone there. If they've got 600 people on the line, we want someone in that office or that manufacturing building to know what's going on, and we want them to be on the conference call. So any of you that have that sort of responsibility with your job, definitely talk to them about it. Okay, this is the west side of Union City. Storm motion is generally to the southeast, and I think at this point we actually got a direct call from NWS Memphis and told them we could not confirm a tornado. We can't see it, but there's some crazy motion in that right there. Yes, west northwest, and we're at the back of the Ramada Inn there in Union City. And the incredible part is this is coming right at the main bypass, going around Union City, and people are driving like there's nothing fixing to happen. Back behind us, it's sunny. And this is right in the inflow notch. We stayed in on this afternoon. We stayed in a tornado warning box for 3.5 hours. GoPro. That's all. Yeah. No, that's
pull a few more hairs out of there.
So we're fixing to leave out here in a minute because we get a little bit too close. So this is going through the south side of Union City. We're trying to get around so we can shoot south, but we got the big highway. Got to give a shout out to Mike Hall. He's the one that shot the video. I had to do all the drafts. Ricky, who here goes to Western?
It'll take probably 3 or 4.
Well, I've had this invitation out before. If you guys aren't driving to Houston, Kentucky and hopping in the back of my truck, it's crazy. I mean, there's plenty of room. You guys can come anytime. You know what we're doing. Just give me a little tweet on Twitter and I'll wait for you. Don't be late. I'll leave you. I've left my driver before. Like I said, I forgot the name of this highway, but I think we're north of KenTenn. Fixing to get on the main road. And it's kind of funny, I almost had like, there's actually 2 supercells right next to each other. We end up getting this crazy cell merger. And I think you'll be able to see it here shortly. There's actually 3 deeper tails moving into the area of circulation at the same time.
Normally, at least 3. But there's not. Use the code red and notify them.
Yeah. Always good to be a lot better.
Yeah, I'm gonna notify them.
There you can see you got your precip form there on the back side of your inflow tail. And we're just trying to ride right along with it. We were pretty fortunate on this day. We had a road that running almost exactly parallel with the area of circulation. So we were able to stay inside that inflow line for almost 2 hours.
Now,
Got lucky. Oh yeah.
One person.
There's a common factor for chasing around the KenTenn area is trees everywhere. So now that this cell merger is taking place, it starts to morph into this. I don't even know how to describe it. I've never seen anything that you'll see here in a minute east of Mississippi everywhere.
One person. The most time will be me. A couple of us watching.
So right here, we're starting to run out of road. We take this little side road up. We've got to, I think it was called Gainesville, Tennessee. Fix to get off the road. If we get on another one, we'll take it back up with you. There you can see 2 of the 3 inflow tails coming in.
But we see them pop up.
And inside that precip board was a report of golf ball size hail. So yes, you need to stay out of that. So shot easy.
Would you explain to everybody that's watching this, because I know there's a misconception sometimes between spotting and chasing, and how those 2 things are different?
Let's see, that's yeah, we're kind of running from, we chase to get there, but I don't know, spotting and chasing, that's kind of a fine line. One thing is, we don't act like a bunch of knuckleheads when we're out there. Really respectful of the public. We don't block traffic or anything like that. We try and interact the best we can with the public, warn them. I don't know, I liken it to like a responsible way to do it. I think.
Yeah, I know that when we tell people, don't go grab a camera and go chasing, because it's a dangerous thing, as we're witnessing even in your video, your main, one of your main obscurities is the trees and the hills. I mean, this is not like out in the Central Plains where you can see for 30 miles. You've got a lot of obstructions here, and that can be very dangerous when you're chasing. So that's why we tell people, don't go and chase storms unless you know what you're doing. And even when you know what you're doing, like in your case, you're having to make sure that not only you have a line of sight to the storm, but that the storm, as soon as you turn a corner from where you're trying to keep your eye on the storm, that you're not going to get in the way of it.
Yeah, that's correct. The other thing is how can I put this? You got to get the knowledge to do it. If you want to do this kind of thing, I've taken a ton of classes, online classes, had help from going to things like this. But you got to have the knowledge. And the other key thing is you got to have a plan. We had a plan that day. We already knew the road network. We had that worked out before we got down there where we were going to go. But if you notice one thing, we're on these main roads where the speed limit is 65 miles an hour. One thing you got to understand here is these tornadoes are not like out on the plains. They move fast, 55, 60 miles an hour. So you better be on a good road to do it.
That's good, right? Yeah. So here's another thing that I know sometimes you would look at that, the first thing you see is, oh, that must be a tornado. But it is not a tornado. Number one, if it's not in contact with the ground, and number two, we don't see rotation. Usually we get those scud-type clouds and this kind of situation where you see just an appendage that's hanging down, but sometimes it's not rotating.
Okay, so what's going on here is the both supercells actually merged. Now there's just one area of rotation, which is off to the right-hand side of the screen. This is one of the most incredible wall cloud. I don't know what you want to call it, but it's crazy. You just don't see this. So it stayed that way for about 15 minutes. We got a good spot. Mike got some incredible video. This is just southeast of McKenzie, and you know, the tornado had already produced one, and that went across real late. But we got in a good spot here. Everybody stayed inside the vehicle because we got light very, very close, as you saw. Now, postpone, please.
Hey, Joe, hit that postpone button down in the lower right-hand corner, please. Or it's going to do another thing. Thank you.
So that's a funny thing about supercells. We're back inside the inflow notch again. But how come this structure looks incredible? It makes it. I mean, it's kind of blew me away.
And for those of you that have not seen something like this before, this whole thing is rotating. And it's one huge updraft that is just sitting there and spinning in itself and just sucking in all that warm, moist air, and it's just shooting it up into the cloud. But this thing has such velocity to it, storm rotation to it, that, like you say, it's pretty incredible stuff to see that, because you don't see that much around here.
Right. And here's the kicker. We thought this one was going to go. That's why we're trying to still hang around it. The key thing, and the reason why we thought it was going to go, is the wind on our necks was warm. It wasn't cold going into it. Oh, yeah.
That's how you can tell the difference if you're where you are in proximity of the storm. If you feel a warm wind at your back, you're in the inflow. You're in those surface winds that are coming at your back, usually warm. That's where the moisture is going in and up into the storm, where it's then cool, and then those dark downdraft areas where you're seeing that's where the storm is falling apart and coming back down. Usually rain and hail is in that part, and then you have the rear flank downdraft where you're looking at the very back edge of that storm where it is actually beginning to erode, those winds starting to fall apart and everything starts to fall apart from the storm.
Yeah, and that's exactly what happened about a half hour later. This wall cloud, shelf cloud looking appendage, it ended up gusting out is what we call it. So the warm inflow changed from the back of your neck, and now you've got a cold outflow coming out. And that's pretty much what we called it a day. So,
and those times is when you have those kind of storms where you go from 75, 80 degrees, and then it falls 20 degrees, 25 degrees in a matter of minutes. When that storm starts to fall apart, you start to get the downdraft area and the colder air, the cold rain that starts to come down. And now you got a little bit of a roll there that appendage is going out, and that's starting to flow into. That's the inflow, yeah, like almost like a beaver tail.
So I think this is almost the close. It tried to regain, as we call it, it's going through another cycle. They cycle all the time. So new inflow tail forms out to the front of us. And I thought for sure, I was like, well, it ain't done yet. So we keep going, keep on going. But this is its last hurrah. So there's our proximity, Union City. You can see the area of circulation there at 3:30, and that's exactly what we saw. So that precip area is your hook. There's some more cloud formations. It was incredible. We got on this one place where I had double stacked plates. That was during the cell merger. What's that? Big thing was, it was the first time we worked with Jennifer Rackmina. We tried to feed as much information to her as we could. We didn't have the live stream up that day due to the fact we lost internet service. So we pretty much chase spotted this whole day, that whole day out. All we had left was GPS. Now this is a time-lapse video coming from Southern Illinois, I believe on July 1st of this year. And I added this in there to it because I've never seen a shelf cloud move away from you.
On the way back.
So all this is done, we can go for a 3-4 GoPros now. So we're starting to get another cell merger, and when I turn it back around, you'll see two cells coming together. We kind of get over it, taken by rain then. So right there is a prime example of your 850, 500 millibar winds, 700 millibar winds, how you got a real good crossover there. In the field, that's what you need to do.
First thing he knew was upside down.
The computer's great, but there's nothing that really beats a set eyeball.
Yeah.
There's Mike taking a few pictures.
Hey, let me fly. No, I know the conference guy.
Okay, we get it turned around. Now we got this neat looking shelf cloud, but it's not coming towards us. Okay, this is when we're coming into Harrisburg, Illinois. See, it's kind of moving away. It was weird. And there's some more scud, tremendous amount of lift coming into it. And there's even some wing rotation with that right there. So we keep on going because we're fixing to get clobbered by rain.
Yeah.
Oh, if you don't know the car in front of me, that's Jeff Blair. He's another spotter from Southern Illinois. A good friend of mine. He's a great guy. Really knows what he's doing.
I asked if he can.
Oh, yeah.
He called me. When I called him, he's never called me.
Miles an hour. Here we go. All right, so this one here is May 2013, Owensboro Barbecue Festival. So is Spotters, Chasers. We also support the general public during, big outdoor events. Well, it wasn't even supposed to rain that day, I don't think. Maybe a chance of rain, but we ended up getting a severe thunderstorm coming out of Henderson. So I was on my way to Lowe's and I had a GoPro sitting in the truck. I said, wow, well, let's go chase this thing out.
Feel like I was on 1,000.
One thing I like about these time-lapse videos is you can really see the motion in all the clouds that you can't normally see. Yeah, I need to go a little bit further, so made a wrong turn there. Don't see them. So taking a few pictures, put it out on Twitter. Then we shoot back south again. Now we're facing north. This is actually when the storm is coming over the barbecue place. Tim, you remember that, don't you? Yeah. It just kind of blows my mind how that storm is as big as a city. Well, now we got another one coming. That storm actually split and formed another storm in Henderson County. Now it's coming into the Central Davis County. But I've had enough. I need to go.
There's a few gravel. Very few blacktop. But they're on the second line. You got one mile, 1 mile, 1 mile, 4 degrees. So the direction we're going, we go a mile down the road. Once it starts raining, still the basement.
It's really cool to see that.
You got all the shine,
But you're talking about.
I understood that. Even then, I've literally got to run something because wow. It's a piece of your power. Remind me in 3 days.
We may be done.
4 hours.
All right, here's some recent video. I thought I'd throw this in. This is the essentially the whole life cycle that where some people got 2 feet of snow. Lord, my guys got 2 feet. I got 16 and a half. But this was kind of a bad situation in Davis County and stuff. We're already flooded. We're going to get another foot or 2 of snow. Not good. So what I did, I just documented this a little bit, made a short little YouTube video out of it. But on that night, once the snow actually got going, I've never seen snowfall rates like that. Not since, I guess, 2002, maybe? 4?
It's good seeing you.
Okay, that's in Panther Creek. We've got a lot higher than that. So as storm spotters, though, one thing that we do, we give reports of flooding, right? We also report ice, snowfall rates, how much snow have you had in an hour? And the guys at the National Weather Service, they're interested in that. It's just not about storms.
I need to bring the coffee pot back this afternoon.
Chris, thank you so much. Give Chris a hand for that. That was awesome. Again, it's Chris Conley, Mean Motion Media. He's on Twitter at Mean Motion Media. Follow him. He's got some great content like this right here, and he keeps us up to date on those things. And Western students, he says what he means, you know. So hitch a ride with it when you can. It'll be an educational process for sure. So we appreciate Chris, for making that happen at this point during our lunch. Everybody enjoy your lunch? Good? Okay, everybody getting fed? Everybody got taken care of? Good? All right, we're going to continue on. And as we continue, I want to present to you a person who actually years ago worked for us at WBKO when he was just starting out. He did a little bit of everything, which is commonplace at WBKO. You learn a little bit of editing, shooting, writing, going out and doing news stories, and then, of course, he did a little bit of weather. And since then, he's been more focused on the western part of Kentucky and working with television stations like Jennifer's at WPSD and some other things. But he is really entrenched in the school system. He does a lot of school talks, a lot of demonstrations. We have him on WBKO doing this. He has a program called Hooked on Science, and his name is Jason Lindsay. Let's give him a big hand.
Everybody having fun so far? Yeah. Hopefully you're supposed to say yeah. Well, this is the part where we're going to have a lot of fun. We're going to use plungers, diaper genie bags, create giant clouds, make it snow toilet paper, all kinds of fun things that teach you a little bit about weather. And that's very important because we all know that in order to better understand weather, we have to educate ourselves. That's how I got kind of excited about weather. When I was a kid, 5 years old in kindergarten at Richardsville Elementary School, I used to be terrified of storms. And I had a teacher that kind of got me interested in science and weather because they encouraged me to check more books out about weather. I eventually became a meteorologist and do what I do today. I did the TV business for a long time. I worked in Wyoming for a little bit, at WBKO for a little bit, in southeast Missouri, west Kentucky, a little bit of everywhere, and kind of got tired of doing that and started my own business back in '07 called Hooked on Science. And now I visit hundreds of schools from St. Louis to Indianapolis to the Carolinas to Knoxville, Nashville, Little Rock, back over towards Springfield, Missouri. A whole lot of them, like 500 last year, so obviously more than one a day. In some cases, they bring to me a bunch of students in the audience schools doing just this, these demonstrations, whether it be mild weather, whether it be blowing up a pumpkin in the classroom, catching a kid on fire, whatever it might be, you know, having fun. You always got to wear your lab coat, of course, just in case if something does go wrong, you're protecting your clothes and yourself. I don't think there's any kids in the audience, but if there is, please make sure there's always an adult around before you do the science experiment. Make sure that you use the appropriate safety gear and have fun. It's bad if you do catch on fire, but what is worse is if you catch on fire and not have fun, right? That's the worst thing ever. So I have some boiling water. Now, before a Kentucky kid leaves the 4th grade, they should know at what temperature water starts to boil. Anybody here know that? Hopefully, because you're beyond 4th grade. So let's look at Fahrenheit. That's what we use in America more than anything else. 212 degrees Fahrenheit, 100 degrees Celsius. We know 32 degrees Fahrenheit is very important. Why is that important? We start to get some snow. We know it can snow at, maybe 35 depending on where you're at, but 32 is a very, very key temperature. What about Celsius? What's the freezing mark Celsius? 0 degrees Celsius. And here it's at least 212 degrees because I'm starting to see some bubbles. What I have here is something that's very cold, something you should never touch with your naked hand because it'll give you frostbite, if you will. It's negative 109 degrees below zero. Anybody know what this is? Dry ice, frozen carbon dioxide gas. It does not evaporate. It does not condensate. It does not melt. It does not freeze. What's it doing? What do we do? What does this do? If I set it out on the table and come back 2 hours later, what do we call that in science? It goes from a solid to a gas. It sublimates. It sublimates. So if I were to put a piece of ice here from my refrigerator and a piece of dry ice, and I come back several hours later, it will be dry where the dry ice is. It's dry ice because it's sublimated. But we'll have a puddle of water because the ice in the refrigerator will melt. I have some dry ice here, and I have some toilet paper. It's not used. That's a good sign, right? I want to pick it up with that. I want to show you how cold it is. It's so cold it should make my giant spoon scream at me. Negative 109 degrees below zero. So I'm going to put it close to this one to listen to see how cold it is. It's loud, right? You hear that? I don't think I did. Making it shake, just like you get shakes when you get cold, right? That's your body warming up. What about our board? I'm going to put it on my board. What will it do here? Will it be a higher pitch or a lower pitch? Higher, right? Why? Because we have these spaces in between, and those vibrations are kind of being squashed together, and we get the higher pitch all together there. So that's how cold it is, just to give you an idea. Very, very cold. But what I'm going to do is I'm going to take this crushed up dry ice, and I'm going to place it in the boiling hot water. What do you think might happen? Kids love this because it creates something that they typically see up in the sky unless it's a foggy day and we get a cloud on the surface known as fog. We're going to create a giant cloud. It will shoot up into the air and it will quickly sink to the ground. And usually if the kids are crisscross on the floor, it kind of covers them up just a little bit overall. It's a pretty cool experiment. Now we have to make sure that we don't splash anything on anybody, and you shouldn't at the distance you are. But we're going to speed up the sublimation process here. They get to where it goes really fast. What do we call it? Anybody know when you speed up a process in science? What is that called? A catalyst. So the hot water is going to act as a catalyst. It's going to speed up that process and shoot our cloud up in the air and should sink down. Do you think we should give it a few more minutes, or do you want to see the cloud now? Do you want one that hits the ceiling and snows in here? Yes. Not going to happen. But that would be awesome. Now, if you do have some warm water and you have liquid nitrogen, okay, and you do this, it will shoot up to the ceiling. Overall, because that's a quick change, a rapid change that will make it shoot up into the air. So let me make sure I unplug everything so that I don't permanently glow for a week or two. And then when I do that and I pour my dry ice in here, it should shoot my cloud up into the air. And it will be really cold around this as well. Clouds, we know, exist. Rain comes from clouds. There are tiny, tiny little rain droplets in clouds, millions upon millions of them. We have cumulus clouds, cumulonimbus clouds, stratus clouds. We have modest clouds. The list goes on. There's a ton of clouds that have been named by scientists over the years. This one, I guess you could call this more of a stratus cloud, more like fog here in a few minutes as it sinks to the ground. You ready for this? We do it? Let's do it. There's our giant cloud right there. Notice how it quickly sinks to the ground. The kids are going wild. It's crazy. So I'll come toward you just a little bit and put some of the cloud on top of you. Whatever you do, don't let this get in your hair. Your hair might turn green. Right? So there's our cloud that I'm talking about. And notice how it's sinking. Our clouds don't automatically sink like this that Mother Nature creates. So why in the world is this sinking to the ground really fast? They know?
It's just cold.
It's heavier. It's frozen carbon dioxide gas, so it's quickly sinking to the ground there. It's a little bit heavier than the air around it. We see that around Halloween a lot, but it's a pretty cool experiment. The next thing I want to move on, because we got a few more to do here, has to do with learning about how air takes up space, something hard for kids to understand, especially if you're in the early years of school, because you can't see it. You can't see air around us. You can smell it because it can stink sometimes. You know it's there from that. You know it's there when the wind blows. So what we can use is something you put poopy diapers in to prove that air takes up space. Anybody have a diaper genie bag in here? Any new kids around? Usually you put lots of poopy diapers in here, but using this we can kind of understand how air is all around us. I need a helper. You've all been sitting for a while. We need to get up and move around. I need a helper. Who wants to help me? Okay, how about you? Come on down here. We're going to stretch this out It's about 23 rulers, 23 feet. You hold that for me. I'm gonna go this direction. I need one more helper. I'm gonna have to pick someone. Oh, come on down, yes. How many breaths of air will it take her to inflate this 23-foot long? Talk on. What do you think? How many breaths will it take you to inflate this 23-foot long diaper jean bag? We want kids to think like a scientist because it's what meteorologists do. We're scientists. We always have to ask questions. We come up with a hypothesis. We think the front's going to do this. We think the tornado's going to do that. Sometimes we design experiments. We do experiments. We collect data and conclude. So what do you think? What's your hypothesis? 5 breaths? 500? 3 million? What do you think? Raise your hand if you say 100. Who says 500? Who doesn't want to participate? How about 5 breaths? I think she can do it in 5 breaths. You okay with that? Okay, so hold it like this, and then just put 5 breaths of air in there. Okay, there's 1. Okay. 2, by the way, hundreds of schools each year. A lot of little mouths have been on that bag. 3. Number 4, and we'll have that one here in just a few minutes. Number 5, proving that air takes up space. Something's making that expand, isn't it? What's making you expand the air? Here, hold this, don't need to go. Okay, you let go for me. All right. This way. This is 5 per breath right here. Not bad, right? Yeah, pretty cool. So air takes up space. It's some of the basics of our atmosphere. What is the most abundant gas in our atmosphere? Anybody know? Nitrogen. And then we have some oxygen, we have some carbon dioxide gas, and a combination of all these gases combined together, we get our atmosphere, the air around us that we breathe in. Okay, so this is 5 per breaths. How many of these will it take her? Because we can see that. See how many times this goes into the entire bag and then multiplied by 5. And that's about how many it will take. Hold that for me again. We'll count by 5s here. 5, 10, 15, 20, 25, 30, 35, 40, 45. I go to 50 because you're going to faint in between. And your last breath will not be as strong as your first. Okay, you can set that down. I want to do the same thing she did. 5 breaths, but I'm going to come back. I need your help. Don't rush to get there. 5 breaths, same people, same bag, except I'm going to use air to my advantage. We know matter is anything that takes up space. Air takes up space, and we prove that. We know that matter is anything that takes up space and has mass. Matter can exist in 4 states: Kentucky, Tennessee, Illinois, Missouri, right? 4 states of matter: solid, liquid, gas, and what's the other ones? P plasma. So I'm going to use air to my advantage. Okay. See how I do it. Observe. There we go. Not that bad, right? You may let go for me. Put this up into the air. This is my 5 breath. What did I do different than her? What did I do different? Anybody see anything? What did I do different? Oops, sorry. I used air to my advantage. I didn't put my mouth on the bag. Not only is that where the germs are, but more importantly, there's air all around the bag. And as I blow into the bag, that pulls more air in with it, creating a Superman breath. And I'm able to put more air into the bag, therefore, kind of inflated a lot faster. Okay, so if I let this go, will it sink or float? Who says it's going to sink, that it's more dense in the air around it? Who says it's going to float? It is less dense. Okay, you think it's going to float? What do you think? Well, if it was going to float, that would mean I blow helium out of my mouth, and I would be rich, because we're not supposed to have helium in like 15 to 20 years. It's going extinct, which means it's a non-renewable resource. When you go to another planet to get it, so by all means, by the time we send a spacecraft there, it'll be a waste of money. Hopefully, yes, yes. But I think some of the kids out there that you all have, especially their kids, won't be able to experience unless we come up with something different, helium in their lives. Thank you, you may sit back down. A lot of people put helium in their mouth and they talk about it. Please do not replace the air around you with something else, because what you're doing when you put helium in your chest and you breathe it out and you change your voice, is you're replacing the oxygen, which that helium gets into your bloodstream, which harms you. So I know it's cool, it's something you might do in college, but I encourage kids not to do experiments that hurt them. And that's one that would do just that. Plungers. How in the world could I use plungers to help me better understand science, specifically weather? Came from my toilet this morning. They're brand new. They have not been in any toilet. But we sometimes see the local meteorologist or even the one at the National Weather Service or wherever, when they have a weather map up, talk about high pressure and low pressure. High pressure is typically blue on the weather map, and it means sunshine. You have sinking air. What about a low pressure? It's just the opposite of a high pressure. Low pressure. So that means it's going to bring rain, snow, tornadoes, hurricanes, the kind of weather that many kids don't like because they can't go outside. And with a low pressure system, you have rising air. You eventually get your air rising in the summertime on a hot summer day. You get your cumulonimbus cloud that forms. You reach your dew point, you get your cloud and all that stuff. So rising air, low pressure system. With these two plungers, I need a helper. How about this guy right here? Helper, what's your name, sir? Kyle. So do you work in this area, or are you just at college? What are you doing here? Senior at U of L. Okay. So what can I do to prove that low pressure is can form somewhere here and a high pressure somewhere? High pressure, the wind blows from a high to a low, right? So how can I do that with this? Can we put it on his ears, you think? Push really hard? That's not going to work. It might lose a brain. We've got to get that back up and stuff back in. So what can we do? Oh, this one. If I take and push this together, something forms on the inside in order to create suction. What has to form on the inside? A low pressure forms on the inside. Remember, we're talking about kids who don't understand the kind of basic level at college level. So at a younger level, push it together, low pressure forms on the inside, high pressure forms on the outside. So how do you know I'm just not telling you that? Because if that's the case, it should be hard to pull these apart. You agree? And it will. So if you pull on this side, I know you got some big muscles there, dude, but don't use them all, okay? You see, it's kind of hard. And if you have a 5-year-old, you're pulling them across the gym, they're like, wow, this is awesome. And then we're proving that there's a high pressure on the outside, it's pushing for the low pressure on the inside, and it's hard to pull these apart. Eventually it comes apart. But I like to use everyday items from around the house to teach simple science concepts, because not everybody has the stuff that you might have in your classroom, your college classroom, and this is perfect just for that. That's it right now. Thank you, sir. And that includes even in the classroom using those everyday items to take science beyond the classroom window. Otherwise, kids just think school must take place at school. When parents, you're one of the best teachers that you can have. So you can teach them this kind of stuff at home. Toilet paper, okay? Toilet paper. It's weak. I can rip it. I can tear it. I'll blow my nose on it, by the way. But what I can do with toilet paper is talk about Bernoulli's principle, which says as the pressure falls, the speed increases. My 4 kids and I do this in the living room every once in a while. We make a cloud, and when we made our cloud in the living room and hit the ceiling, we had to repaint the ceiling. But try to do these experiments in an area where you test them first before you do them with a group of kids, so that you kind of know what to expect and it doesn't always go wrong. A lot of the teachers that I work with in many of the schools across our great states here, Tennessee and Kentucky, their first period is the guinea pig. Typically, they use that as their test period. Hopefully you have your advanced students in that class, you can catch the concepts really fast. And then by the end of the day, they have it perfect. So a lot of times they're doing this at home, they're trying them out in their first period. So how can I rapidly enroll this entire roll of toilet paper? How can I? Just by using my breath. How about you? Come on. She talk a lot? Some. Could you rapidly enroll this entire roll of toilet paper by blowing on it? No, it's not going to happen, is it? I won't make you try it. But what I can do is I can use my wife's hair dryer. Right? Because air here is going to blow out at more than at least 100, maybe 150. This is an old one. Miles per hour overall. You can set that down. Thank you. So it's going to blow out pretty fast, and it's going to shoot the toilet paper right through the air. We can teach kids about highs and lows. By the way, I have something up here that I'm going to give away before we get to that experiment. If you want a rain gauge that's wireless, and you want a thermometer that's wireless, I was going to give these away. All you got to do is go live, Hooked on Science on Facebook, leave a comment, and what I'll do at the very end is I'll let you know who won, and I'll check my phone really fast. So, but don't do that just yet. Don't do it until I say go, 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 and then the first person who does it will do it then. Also, all of those here are like, I didn't bring my phone with me. I'm losing out on this opportunity. I'm going to give away 5 science kits. So whoever posts anything, I'll snail mail them to you once I figure out who wins it. Back to our experiment. Toilet paper, using my plunger as a dowel rod, and my lead fluid. I'm going to focus the air on top. As I do, a high pressure will form somewhere and a low pressure will form somewhere. Anybody want to guess where the high pressure will form? Will it form underneath or on top? For those of you that know Bernoulli's principle, we know as the pressure falls, the speed increases. As the speed increases, the pressure falls. So with that fact in mind, where's the low and the high going to fall? I'm blowing the fast flow of air on top. So where's the low going to fall? You know, on top. So the pressure is going to fall there because that's where we're increasing the speed at, right? And the high pressure will form underneath. The wind blows from a high to a low. It pushes up, and we should get lift, and this toilet paper should fly right through the air. I need two helpers. I'm going to pick somebody out there. How about this blonde-haired lady with a pencil sticking out of your finger there? You come on down. You want to bring that guy next to you? Is that your boyfriend? Whatever one you like the best. Whichever one. Bring one of them with you. Yeah. She likes them both. Oh, she left them both. Okay. So just bring one of them with you. You're going to be my holders for the wonder here. You'll stand on one side. So are you a WK? The best college in our great state? My alma mater, right? Pretty good college there, especially when it comes to meteorology and broadcasting. How about you hold this side right here? Okay, and you hold it over. Anybody from South Central Kentucky, from the Bowling Green area? Raise your hand. Anybody in here at all? Nobody? I went to the best high school here, Warren Central. We were fire breathing dragons. Overall, since I left in 2000, I think there's been like 2 or 3 new schools open here. So you're a growing area. It's a great work here. Now, is Owensboro going to be Bowling Green for the population? What do you think? That's big talk as we, move to the new census. Right now, Bowling Green is the 3rd largest city, and then behind it would be Owensboro. Do you think they're close enough to eventually Owensboro will take rule there? No, not at all. You're both you're saying no for sure. Fast floor there on top. I have my lead floor on top here. Focus it there. High pressure forms underneath, low on top, and we get lift and it should shoot through the air. Now, that bubble, anything here back here that should fly or explode, you don't have any boxing factors. So you should be okay. Plug this in, and I'm going to focus it right on top. We should get our toilet paper shoot through the air. Go ahead and move your sunglasses in case of this thing. A little bit more. It's high up into the air and it gets the kids excited. So here's what we find in the educational environment. If it's something that's out of the ordinary, if it's something that gets them excited, we sneak in the concept, we sneak in the vocabulary, and they tend to remember it a lot better. I mean, you all remember what happened during these big events, JFK, when man was on the moon. Remember what you were doing at that time, at that place. You can go sit back down for me. So what we try to do in the education building is to create amazing, astounding science demonstrations to where the kids are at that point that they can't forget what they learned. And if it's TP in the classroom, playing with diaper genie bags, creating giant clouds, hands-on is the big thing right now in our education system. Kentucky just adopted a whole new set of science standards. We're talking more about climate change and long-term effects of the things that we do here on Earth to our climate. That's been adopted, and they're developing a whole new test, and it's going to be more of a hands-on approach like this in the future, especially in the next few years. Anybody have any questions about what we did today? Any questions at all? Go, 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 by the way. Go ahead and post your comments and your pictures, and I'll let you know here in a few minutes when you were the winner. Just look for Hooked on Science on Facebook to do that. Any questions? HookedOnScience.org has a free experiment of the week. Some of them are weather-related, some of them are not. They just get kids excited. But there's a whole little weather section there. A lot of others, from basically turning your toaster into a hot air balloon along with a trash bag, telling kids how hot air rises and cold air sinks. So lots of fun things there. Any questions? No? The experiments are free there at HookedOnScience.org. I'll give you some quick moments to go post that, and I'll look and see who posted a comment really fast and see who the winner might be. Lots of stuff still coming up here. I'll let Chris come back down and tell you guys what's coming up next while I'm looking for this. Overall, thank you for having me. Did you have fun a little bit there? This is the guy I watched on TV in the morning. At that time, it was Jeff Noble in the evenings. And I forget who did weekends back in the 80s and 2009 when I grew up. So he's one of the guys that kind of got me excited and continued that excitement for weather. Watching your local meteorologist does make a difference in specifically kids' lives that are watching. So thanks for getting me excited, Chris, and continuing that excitement.
Well, thank you. Okay, so I appreciate that. Jason, big hand, thank you. And let's see. So you're going to look up. You're going to find out who the winner is. You're going to name. Okay, you're fine. You're fine. Remember to keep Jason in mind if you have, like he was talking about, any event that has where kids are involved and you want them to learn about science. This is perfect. So you can get hooked on science and go to his website and get signed up for that.
Looks like we have 3 teams, so it's taking my time a little bit longer.
It's probably everybody that's on their phone.
Yeah, that's true. And there's another break I'm assuming before we end today. Is that correct?
There is at 1:45.
So how about I announce it at 1:45? Do that when it might be.
That'll be fine.
Overall. Yep, that works. Thank you, guys. Have a good day.
Thank you, Jason. Appreciate it. And Jason is also now a correspondent for Weather Nation. And so, in fact, we taped an interview a little bit before his demonstration that's going to be airing on Weather Nation. I know it's not commonly here, at least it's not on Time Warner Cable here in Warren County, but it is on Dish Network, and in some other cities, you'll find Weather Nation. It's a lot like the Weather Channel, but he's now a correspondent with them and doing some more things with them, which is exciting. All right. Right now, it's time to talk about ground truth observations and hear from the Kentucky Mesonet Network is Kyle Thompson.
I'm gonna bore everybody for like 20 minutes now since y'all just got that great talk on science and stuff. I'm Kyle Thompson. I have my master's from Western Kentucky University, and I'm a meteorology electronics technician with the Kentucky Mesonet. I've worked there for 4 years, so I'm going to talk a little bit today about ground truth observations that we use and what ground truthing is really. So what is ground truthing? Ground truthing is whenever we see what's happening on Doppler radar and we look at what is happening on the ground. And when we look at things on the ground, we look at CoCoRa's, personal weather stations, AWOS, ASOS, and the Kentucky Mesonet here in Kentucky. So we want to know, we see what's happening up in the sky, but is it actually reaching the ground? So what are the different types of ground truth data that we're going to talk about? So I want to everybody imagine your cell phones, and we're going to use the different type of cell phone bars to explain how these networks and observations go up as we start talking about it. So if you have one bar, you don't have really good service, or it can be very spotty service, and then you have 5 bars, which goes all the way up and discusses the more scientific and the more maintained type of weather stations that are out there. So we'll start out with what CoCoRa's is. CoCoRa's is a network of volunteers that have gauges all around the U.S. that take measurements of precipitation and also of snowfall and snowfall rates. Amounts are reported between 6 a.m. and 9 a.m. every day, so these are a daily occurrence. Information is used by a number of entities, such as water management people. The National Weather Service also uses them to make their maps that they have showing precip across the state at 7 a.m. usually when Louisville puts their maps out. Jackson and Paducah also do these maps also for their areas. Both Kentucky and Tennessee have CoCoRa's. So, and we'll look at the these are all the CoCoRa's stations. You see these gray points, those are the actual points where CoCoRa's measurements are taken across the state of Kentucky. Just today, yeah, right, from that day. So you have people that do report even when we do not have precip occurring. And that was taken sometime earlier this week. I think it was on Yes, it was on the 17th when we actually had a dry day. And then you have Tennessee that also has the Cocoa Ross, and that's showing all the people that have reported for those. Cocoa Ross is great, and if you want more information, you can visit cocoaross.org, and they have all the information for the person in the state that actually maintains your network. Here in Kentucky, Tom Pretty, which is with the UK Ag Extension Office, he actually is the one that does a lot of the Cocoa Ross stuff here. And Joe and all of them also have a lot to do with that also. So we're going to talk about personal weather stations, and this is where I'm going to go on a tangent for a little bit. Working with the Mesonet, we have standards of where we actually put our stations at. We go by what they call WMO standards, which are the World Meteorological Organization standards for meteorological observation systems. Personal weather stations are great, but we always have questions about where these actual stations are at. If you see WeatherBug networks on TV or anything, or use Weather Underground, a lot of these are personal weather stations that are actually putting this information out. So stations can provide many types of meteorological data. So pretty much wind speed, wind direction, precipitation, a lot of them do, temperature, and things like that they do. But the most important thing to know about personal weather stations is where that location is. So as you can see by the picture, siting of a station is very important. The picture here has a weather station that's located on a black roof. And as many of us know, that black absorbs heat, so it's going to cause for temperature readings to be very off. A lot of times people do put weather stations in the middle of buildings. So if you're taking wind measurements, it's going to throw those wind measurements off, and actually probably be much higher than what it would be if it was in an open field. Or if you put them under a tree, you're going to have shading, which is also going to mess with temperatures and also going to mess with the wind speed, direction, and the speed that's actually occurring. Other problems that occur with personal weather stations that do not occur with the Mesonet as much and with ASOS is the calibration of equipment. With ASOS and with the Mesonet, once we see issues with those, the techs at the National Weather Service will go out and deal with the ASOS, and us as techs at the Mesonet, we will go out and replace equipment that it looks like it's not reading correctly. Maintenance of the station and vegetation, that's another big key. A couple of years ago with the Mesonet, we have a station in Hopkins County that is on reclaimed strip mine that was reading much higher than every other station around it. And come to find out, it was actually the vegetation height and the type of vegetation that was absorbing heat and causing that station to read much higher than what it was at other stations around it. So knowing and making sure that the maintenance and that your equipment is clean is a very important part of having a personal weather station. We need to know what is actually happening at those. And then missing data values. Though we have missing data values with the Mesonet and ASOS and much of the higher networks, personal weather stations, if the maintenance isn't kept up, that can also mean that you're going to have issues where temperatures and precipitation and things might not be reported, which are very important for the Weather Service to get a better idea whenever they do their forecasting and other entities. So we have AWOS. There's AWOS and ASOS. AWOS is Automated Weather Observation Systems, which are located at many airports across Kentucky and Tennessee. The closest AWOS to us that is in a big city is going to be in Owensboro. Barron County at the Glasgow Regional Airport also has an AWOS system. These are usually maintained by FAA, so they have met techs that go out and look at these stations and upkeep these stations. And they take temperature, precipitation, and some other variables as far as weather variables. These are good stations, but it usually takes the FAA much longer to get out to a station like this to do maintenance on them if they have a trouble ticket issued by the local weather service office that uses that data. So it can cause for data to be off, and not always as reliable as what the next two networks are that I'm going to talk about. So ASOS, or automated observation systems, are located at either regional airports or international airports and military bases all across the U.S. These are upkept by National Weather Service and by FAA and military agencies. And this is what an ASOS looks like. ASOS, I think the cost is $25,000, $30,000. No, it's more than that. It's 60 plus, isn't it? Yeah. So you're looking at $75,000 for this piece of equipment. John Gordon, who's the MIC at the National Weather Service in Louisville, always says this about ASOS stations. ASOS stations are meant for aviation and not necessarily meant for climate change or any type of climate research. These stations record every minute, so whenever you call the number that you can call to get ASOS data, they update pilots so they know what they're taking off and landing into at these airports. So it's very important, especially at international airports and regional airports, for these stations to be working in case planes need to de-ice, or also to see what wind observations are doing so you don't have a plane go down due to high wind speeds or something that might knock it off the runway. So at these stations, they take air temperature, wind speed, wind direction, air pressure, dew point temperature, visibility. So they have a system on the ground that shoots a beam up into the sky that shows how high the cloud types are, sky conditions, and weather conditions. So every minute they are taking observations, but every hour you will see these observations coming out. A lot of the times when media refer to either Louisville or Lexington or Evansville or even here in Bowling Green, they are referring to those ASOS stations that are located at the regional airports and also at the international airports. In Kentucky, there are 8 ASOS locations that range anywhere from Bowling Green, from Paducah to Bowling Green to London, and then as far north as Covington, which is at Northern Kentucky, Cincinnati's International Airport. And then Tennessee has 7 ASOS stations across their area that range from Bristol, Chattanooga, Knoxville, Memphis, and Nashville, and Jackson, Tennessee. So what is the Kentucky Mesonet, and why is Kentucky unique into having a Mesonet? Back in 2007, we had a earmark grant from Senator Mitch McConnell's office that allowed us to install weather monitoring stations across the state of Kentucky. At the current time, we have 65 observation systems that range from 345 feet over in Fulton County to 4,301 feet above sea level in Harlan County. So they are very sporadic throughout the state. 64 counties actually have these stations. And we report the same variables that all these other stations have been reporting. Our data is collected every 5 minutes at the stations. We package that, and every 15 minutes, we put this out onto a public website where this data is for free. So you have near real-time weather information that occurs every 15 minutes under normal conditions. During severe weather, we can turn on what we call our 5-minute data, where we're providing 5-minute data during severe weather events or during snow events. So while 5-minute data is on, I will sit in the chat room with the National Weather Service and media and give reports of any severe wind gusts that we have, or if we have rainfall totals that are being very high that they need to know about to issue different flood products and also to issue severe thunderstorm warnings and tornado warnings. Our locations vary depending on the type of land use that we have in the area. We look at about a 100-meter radius around our stations for them to be open. So about 330 feet, we're actually looking that we have a clear space around us that will not be influenced by different types of temperatures that could cause abnormalities or anything like that. This is what our setup looks like. Most of our stations run off solar power that charge two 12-volt batteries, and that's what runs the whole station. And these stations are very reliable. We have a 99.7% upkeep with most of our stations as they actually report that 15-minute data to everything. Here's a picture of one of our stations, and this is the station in Bullitt County. You can actually see Jim Beam in the background there, area where they do the smoking gun barrels and stuff there. This is actually one of my favorite sites to visit. It's located at Bernheim Forest in Bullitt County. We do a lot of outreach with Bernheim Forest to get people interested that are coming to the forest to look at that type of thing. Here is our new website that we're about to put out, hopefully within the next week or two. So you get all this information put onto a public website that you're able to click on for free. At last check, we were at 51 or 55 degrees across the street. We have a Mesonet station over here at the Corvette plant that is not accessible to the public because security will throw us off their grounds if they know we're not over there without them calling them. So you can look at this website to be able to get all this data provided to you for free. This is our QA/QC system, our quality control and quality assurance system. All these colors that you're seeing are flags for our data that are starting to show up. If we have a red flag, that means that data is no good, so it will mark it, and we do not report that data out onto the public website in a case like that. The yellows, especially where it says TAO1, TAO2, and TAO3, is starting to show drifting between our temperature sensors. This is very common and it's very minute that we usually don't have too many problems with our temperature sensors. So every variable that we report across our network, we have on this webpage for us to internally look at to see if our data is good data that we're providing to the public. So we're going to use an example from May 1st and May 2nd, 2010. The flooding event that happened in Nashville also affected the flooding event here in Kentucky, also affected Kentucky. So before the Mesonet came along, the Weather Service in Kentucky only had really two good, reliable points between Bowling Green and Louisville. And that was the Bowling Green Airport and Louisville International Airport. So what the Mesonet has done for Kentucky is help fill in these spots and provide data for the Weather Service to know exactly what's going on. Between the two-day event that happened, we measured 10.16 inches of rain, I think, at our farm site here in Bowling Green. So you see radar at the top that shows what radar picked up as the actual totals. And then below is actually what the Mesonet and other reporting stations reported as those temperatures, or as those precip totals. And these are some pictures from that event that happened. You have Lexington down here on the bottom right. That is Hardin County in E-Town somewhere on the bottom left where it washed out a train track in that area. The top left or right is the Bowling Green on US 231. If you go out of town a little bit towards Allen County, you'll know exactly where this is at. It's near Drakes Creek. In this picture, I believe it's near Westport, where they had major flooding during that event. So, any questions? No, I'm done. That's what I was looking at.
Any questions for Kyle for the Mesonet? Okay.
Are there any plans to move that into Tennessee? Because I miss having that Mesonet working in Louisville.
Oh, I know you do. We are in process of talking with people trying to get it moved into Tennessee. That's our next step, is to move down into the state of Tennessee. And we're looking at the Sumner County areas, Robertson County, in that area. We would like to move further south into your all CWA there in Nashville.
So, which counties are still pursuing
having a mesonet site, you're currently zero sites, zero counties looking to get a mesonet.
Is anybody in here from Butler County by any chance? No? And I thought I was gonna make somebody say. Butler County is actually finally gonna go through. We're in the process of getting ready to start concrete. I know that makes BKO and NKY happy. So, yeah, that is something that's gonna happen. Webster County in northwestern Kentucky is looking at possibly adding one into their station. The area that we really want to get is in Pulaski County, over in Jackson's region, to help fill a major hole in our network. So, and Shelby County is adding another station to their county. So they're paying $15,000 in another station.
And I would say, just from talking with Kyle and anyone else that's been involved in the mesonet here in Kentucky, is that if there's anybody that you know of on a, like from a corporate level, that would be interested in helping fund a Kentucky mesonet site in those communities that don't have one, then talk to Kyle, because he would like to know who that is, because they could use that help. You got a question?
I know that the Weather Service has been pushing ping lately, and I know it's a good tool. I mean, I enjoy using it and looking at it, but how much faith does the Weather Service put into that, and what does it help?
I'll let Joe answer that since he deals more with the ping stuff than I do.
Well, first of all, for those of you that aren't familiar with what ping is, it's the precip identification of the ground app. What it is a sort of a crowdsourcing app that you can download on your Android or iPhone, and you can select what sort of precipitation you're getting right at your area. We use it all the time, and especially in the wintertime, because when anyone that's from around here, you know that we never get snowstorms that are just snowstorms. There's always something else mixed in. Rain, freezing rain, sleet, etc. And that's the sort of thing that despite what Angie was talking about with us being able to see tornado debris signatures up to 8 or 12,000 feet, we can't see what's happening on the ground because it's below the radar beam. It's what we have to estimate. And just the second snowstorm that we had in February, the one that didn't produce as much as we had anticipated, produced more sleet. There was actually, and Keith Alexander, who's up next, can attest to the fact that we had, last year, we had expected a big snow to develop that turned into a sleet storm instead of a snowstorm. And some of the ping apps that were coming in, or ping reports that were coming in, were what, they were essentially the way that we knew what was going on out there, because there's no way to know just looking at radar and looking at the limited surface observations that we had. And by the way, limited surface observations, when I moved to Louisville in 2007, I was very frustrated. I came from Wyoming, where I actually had more observations per square mile than they had in Kentucky at the time. And so this has been, the mesonet has been a godsend for forecasting and especially for warning in the state of Kentucky. And if you know anyone who wants to support in those counties in Pulaski County or any of the others that don't currently have a mesonet, it is money very well spent. It'll help, it helps the National Weather Service here, and that's why Angie down in Tennessee wants it down in Tennessee, because she knows how valuable it is up here. So we do use ping, it is very good, but it's not providing us continuous data. We have so far not run into the problem with the bogus data coming in, and for severe weather, you can actually report hail. We'll never take a hail report from ping, in our office at least, and go with that as ground truth. That'll give us, because it's anonymous, we will verify before we send out any sort of local storm report, anything that comes in from ping. So the most long-winded answer to yes, we like it.
Anybody have any other questions for Kyle?
Talking about the mesonet site, is there any plans for Scott County? Because the weather in Scott County is very, very different from the northern part to the southern part of the county. In fact, it probably varies quite a bit from that county to any other county, really in the state, especially in the winter time.
most definitely. I'm actually very familiar with the Scott County area. My best friend used to live there. So I know exactly how the weather differs, especially between Lexington and I think our nearest site between you all is going to be Owen County, which is to your north. As of right now, I do not know of any talks. I'm not the one that goes out and actually secures the actual places for them. I do more in the maintenance on the stations and stuff, but it is definitely an area where talks fell through. And it would be nice to get back up and going and get something in the area, in the Georgetown, Scott County area for sure.
Okay.
West Virginia. Yeah. West Virginia. Yeah. West Virginia doesn't have a mesonet at all. They have ASOS and AWOS stations and co-op stations, but they do not have a mesonet to our degree. Between Oklahoma was the first big mesonet. They have 100 stations in the state of Oklahoma that's been going since 97, I believe, is when it went into effect. And then Kentucky came along in 2007, and New York's actually getting ready to start a mesonet. So there is a big push for mesonets across. As of right now, I don't think anything's going to happen in the West Virginia area, but it could over the next couple of years for sure. It would be a good thing to get, for sure.
Any other questions for Kyle? All right, let's give Kyle a hand. Appreciate it. Thank you, Kyle. All right, we're at 1:45. Let's take a 15-minute break, and then we'll reconvene back in here. Thank you.
Yeah, so it just takes a lot of once you do, we will do it.
That was the thing that was motivating me to do something that I'm from the other end. I'm coming from So I'm from Lakewood.
Hey, Tori.
Okay. Right, yeah. I know that's something it's terrible. And I'm like, Tori, why are you doing this? It's almost easier to do that. You can file it every time. And I've like to text I know when we were in that meeting, I was like, I was like, one, I don't I had a huge fire because I really did lots of stuff. Because I don't have the I can't have sound.
The winner for the thermometer and the rain gauge was Brandon Jarrett. Is he here now? Brandon Jarrett? No, I'll wait till I get back.
Yes, the president.
It might be on top, right?
We basically decided they cost them a lot.
Are these on we tried, I like said, no, I understand.
Everything about this conference, but it's very interesting.
Well, you don't want to have seats?
I love it.
It's open and I need to play sit with my mom. What can I say? Take pride in my work.
I've got one.
She paid answer me like
Groggy.
Yeah. I can see her.
Oh, man.
Yeah, but I mean.
Sorry about the rest. I was dead. Somebody had no choice. I'll tell you.
When do y'all have that? Yeah. Well, I got Wow on Tuesday, and then.
So this week.
So introduce myself, James So, like, when you were saying, yeah, James _ Brian Ford. But yeah, whenever, like, I would love to chase. I've never really been with the slaughter, so, like, especially if that was Brian. Yeah, just shoot on Twitter. Yes, whatever. Okay. Yeah. What's your last name? Tom. Okay. I have family in Knoxville. That's where my mom's from. So we always go up there. My brothers are out school. But yeah, we normally spend a good week up there. So if there's any event up there, yeah, that'd be fun. But yeah, the sword. They they normally try to reserve those for the juniors and just upper class as well. But with me only being a freshman right now, I think I'll get more out of it once I get to the guys out the way. So I actually know all the but yeah, it's time. But as for that, yeah, I would appreciate that opportunity if it came. That'd be awesome. But we'll enjoy it. Nice to get one.
Okay. We're going to keep things on track here. What's the score? 4-4. Just 4-4. Okay, tied up. UK sensitive. Okay, sure. Yeah, I know. That's fine. That's good. That's all right. I understand. Hey, I told you, you can just do what you need to do. By the way, here is where, if you would, and I'm going to, Joe, you may want to get that box that you created. It's out there by the table where you found it. Okay, I'll go get it. Okay, Joe's going to bring in the box so that you can all put your names in. So if you would take, it doesn't have to be that survey piece of paper, just, you know, if you have a piece of paper where you can find it, just write your name, your first and last name at the bottom, like a bottom corner of a piece of paper, and then just tear that part off, fold it up, and then Joe's going to pass around that box, and you guys can put
This
your
is
name
called
in there.
necessity is the mother of invention.
That's right.
Box, right.
We spared no expense for the box that we're going to draw the names out of. And we have several weather radios that we're going to give away after the panel discussion is over. And Bruce Thomas from Midland Radio also brought some weather radios. So I think we may have 5 or 6 radios to give away total. So somebody will come away today with a new weather radio. All right, so make sure you put your name in the box. In the meantime, we're going to move on. And let me just say before we get this presentation started that, as I was saying at the very beginning when I was thanking our sponsors and everybody that has helped make this day possible, Keith Alexander is here from LG&E. It's going to be part of this next presentation. They took care of your lunch today from the Corvette Cafe, so let's give Keith and LG&E a big applause. Everybody, was it good?
Yeah.
So the next time you come back here to the Corvette Museum, if you go all the way down to the end of where the Corvettes are parked out, that's where the Corvette Cafe is. And they, by the way, they do great burgers. They do a lot of different things. So all that food today came from them, and we appreciate LG&E taking care of that for us today. We appreciate it very much. So we're going to talk about safety after the storm. We've talked about before the storm, during the storm, and now we're going to go to after the storm. So here to talk about that is Keith Alexander from LG&E, and then following him, Ronnie Pearson of the Warren County Emergency Management. So Keith.
Great deal. Welcome to everybody. And I hate to follow all these professionals that they get paid for being on TV and do public speaking. I only get to talk to when your lights are out and you want to know why it's coming on. By the way, right now with the tournament going on, if I lose power, I'll get more negative consumer complaints than if somebody was out of school for a week. So anyway, the main focus, and you'll hear more from my counterpart here in emergency management, for us it's safety. I'll start it off with this. Most of the TV stations, radio stations, after a big event, we always make the calls to tell people stay away from down wires. And we call this one. It's very short, sweet, and to the point. If you were beyond that yellow tape, you wouldn't be here at this conference right now. So when we say and tell you and ask you to stay away from down power lines, it's exactly the reason why right there. You know, this right here, I think there's some pictures after this. This was a little tornado and came up, and this is behind Cardinal Stadium and goes into the backside of Churchill Downs. The streets are already dry, not much rain, not much hoopla over that, but look at the mess that it caused. And if you count down through there, I've got 35 crews and people that work most of that day through the night and into the next day to clean that up. Just one little event. All right, people say, well, if you use stronger poles, things wouldn't happen. If you see that 4-prong steel tower down there, it just bent in half like it was made out of hot plastic. That was taken from the 2009 ice storm down in western Kentucky. And so it seems like a whole lot of things that utilities do. The stronger we build it, the more Mother Nature can throw at it. So, you know, I got to learn how to work this. Joe, when I call you and ask you how much ice are we getting, this is what I'm afraid of right here. That's nowhere on your prediction chart. That's from 2009 down in western Kentucky. So would you say that's a 1/4 inch, 3/4 inch, an inch of ice, or 4 or 5 inches of ice? That's a lot of ice. We build those towers, by the way, they can withstand a 300-mile-an-hour wind, and they can withstand a lot of ice loading, but they can't handle it. Things give. Mother Nature trumps everything. And here we have our line crew that's the water line crew. Actually, that's a joke. We don't have line crews that work in the water, but when the rivers get up, the streams get up, LGKU can proudly say that now we have 8 line boat trucks. I guess that's the only thing I'm allowed to classify. We got a call on this one. Somebody called from the last high water event and said, a bunch of your employees are out fishing. I'm serious, that's what they said. Did they catch it?
They ain't got no fishing rod, but, and then if it's not the weather, we get help from the public. I mean, now, here's a guy that, when they took this picture, this guy was getting ready to get out of his car and walk away. Never do that. If you're caught like that, any number of ways to kill you is laying all around, touching the ground, touching the car. You're all right as long as you're in the car. The minute you step out there, if something's energized around there, you will be a casualty. Okay, that's one small substation transformer that took a lightning strike. That's what they look like when they go bad. Some say, well, they can just plug another one in. That one right there is about $1.2 million to replace and has an 8-month lead time to get it in here. So I showed this. All of the utilities response and everything is meant to protect the public, and everything is focused around our customers and you folks. And the center dot in there is to monitor. We are always watching the weather. I know I probably bugged Joe and Ricky and all these folks with the National Weather Service. You'll hear me, I might not always say anything, except during the last winter event, we had some calls and somebody said something about ice, and I chimed in and wanted to know how much wind was coming with the ice. It makes a big difference. But we monitor everything all the time, and not just when it's here. We monitor way out in advance, and I believe last year the Weather Service was tracking a potential storm that was going to hit Kentucky, and it was going to be similar, or could have been similar, to 2009 ice storm. Anybody want to hazard a guess what I spent in the 3 days before that? Just getting ready in case. Anybody, just a guess. How much? 1.5 million. Anybody else? We spent $3.5 million getting ready for something. But I'm of an opinion that the best way to keep you folks safe and keep your lights on is to stay prepared. And, you know, it's better to have spent that money and had people there to restore power than go an extra 4 or 5 days trying to get people's lights back on when people are suffering. So monitoring is the king. I've got very little time, and I want to get my counterpart over here in emergency management time to talk. But we do engineering, construction standards, and maintenance. Monitoring, like I said, is the key thing that we do, and we're always preparing, and we're always training our folks. And then I've got right in there for close relationships with the Joes of the world, the folks that do this weather monitoring, because it does mean a lot to us. We want to know what's coming, when it's coming, and how bad it is. I'll skip through some of this in the interest of time. We take our data after we have an event. We track everything that we do. This is our restoration patterns. I don't let them get by without looking at everything. So, just to give you an idea of our service territory, this is it mapped out. And here's a fun one. I still talk about this. 2009, we have 3,000 employees between oil, gas, electric, and Kentucky Utilities and Old Dominion Power. We brought in, for the 2009 ice storm, 6,731 people. That doesn't sound like a lot, but that's 6,000 people you got to feed, you got to manage, you got to assess damage, you got to tell them where to work, you got to get them to and from. 6,000 people. Just some fun facts.
Anybody want to hazard a guess on what we spent restored in 2009? Well, let's think about it while I go through some other stuff here. All right. I'm gonna defer the question till the very end because I want him to have some time to speak, but I'll tell you the answer to the question. In 2009, we spent $238 million restoring from the effects of the ice storm. And I heard a lady come up to me and she said, well, you're insured. We're self-insured. So you know what that means, don't you? That means we get the checkbook out and write a check for it. So I'll defer to questions till after my camera here. Go ahead.
Good afternoon, everybody. My name is Ronnie Pierce. I'm the Director of Emergency Management for Dearborn County. Those just the first visit to the Clement Museum. Welcome. Thank you.
I talked a little bit about after the storm and what we do. If you notice in the Baptist row back here, we got all of our EM friends. If you would, raise your hand. Do hoorah. All right.
Busted.
Thank you, Bob. Hey, after the show. From an emergency management perspective, those of you that don't know what we do, after the storm is where we come to play. We coordinate law enforcement, fire service, EMS services, rescue, all the things that's going to need to happen after the fact. But it's a partnership with everything, just like Keith alluded to. If it wasn't for our utility partners, the weather service, local media, it would make our jobs a lot more difficult. But there's some things that you can
Okay. Mark, you got control up there?
There we go. Safety first. If you've been affected by a severe weather event, your home has been damaged, or your work's been damaged, first thing we're going to do is make sure you're okay. If you're going to take care of someone else, you've got to make sure you're capable of doing that. There's a lot of dangers and things that happen after a storm that may be present. I want you to think a little bit about those. You got to mentally prepare yourself. I've been doing emergency service work for over 30 years. I've seen a lot. It's everybody gets in relaxed and calm day-to-day things, and all of a sudden it happens to you. You step outside, and it looks like there's a bomb going. You've never seen this devastation like this before. So it's important that you kind of mentally prepare yourself for what you may see. First thing first, yourself, your family, your coworkers, whoever you're with. If there's immediate needs, first aid, you need to take care of those. Evacuations. This is from Oklahoma. They're actually moving some of the school kids from the school that got hit there. But everybody's supposed to be prepared. Everybody got a disaster kit? Raise your hand if y'all want it. All right, good. What's in your disaster kit? First aid kit. Everybody have first aid training? Good. You need to know how to use it. It's one of the things you're going to need right off the bat up front. Power lines, as Keith has alluded to, it's one of the hazards that's out there when you first come out. There's a lot of them. Watch for them, look for them. Use your senses. You'll hear hissing. You'll see the sparks. You'll see the smoke. Keep children away. Think about this picture here. A middle schooler dies after being electrocuted by that rock. It happens. But these are hazards you have to be aware of to protect yourself and your family. Let Keith and them know that where those power lines are down, they'll get to you as quickly as they can. They have, as he just mentioned, they always have on standby large amounts of contingents to go deal with these problems. They just have to be notified to get out there and get these shut down so repairs can be made. Gas. This is another one of the hazards that you may see. During the wind events, we find cases that gas meters get torn from homes. LP gas tanks in yards get flipped over. Know how to shut those off in your home, your business, your facility. This is a typical home gas meter. The thing in the circle there is the valve to shut off. Basically, you close it to those two holes line up. That shuts off that gas. If you smell it, you ever open your windows, get everybody out of the structure as safely as you can. watching for hazards, broken glass, down power lines, and things of that nature. Mark, this little video that happened, I don't know if this is a police dash cam of a house and it had a gas leak, which happens quite often, Mark. I think the gas been leaking in the house for several minutes. They called in, they smelled it. They didn't evacuate. Called the responders. That's a fire truck over there. They're all, there were some responders and civilians in that particular incident. So if you smell it, shut your utility off, close the windows, evacuate the facility. Y'all see the firefighter there in the middle? These are all possibilities. Safety first. All right. Know where your electrical fuse panels are in your home. Turn off the master. Gas meters, water meters, learn how to turn these off. These are the things that you can do to protect yourself and the responders that are on their way to respond to your emergency. Falling limbs and trees during the ice storm of '09 that he's mentioned. We've seen multiple places, responders all over, walking around, all of a sudden here come a tree, here come branches. Be very cautious, be aware of your situation. This gentleman here on the right, just after this picture was taken, the tree that's leaning actually came down. So that's how close these things can be. It's something to be aware of. You want to make sure that you're thinking safety first. Avoid driving. This is a contingent point. A lot of the things that you've heard today is spotting and chasing. We need to know it helps us do our job of what the weather is doing prior to. But after the event, the things that first responders have to deal with, in particular, are traffic backup. Now, trying to get fire trucks and ambulances into a place that's been damaged and ravaged by a severe event makes it terribly, terribly difficult to happen. So if you don't need to drive, don't. Stay there, take everything, and we'll get the services into you. Critical situations, when these things happen, as such on the right, we have a contingent of services to get there. Traveling through that traffic to get there makes it more difficult, and minutes matter in the job that you do. So please, if you don't have to drive after the event, how many of you have smartphones? How many want pictures of after the storm? Come on, keep them up. We all do. We all do. Just please understand, we need room to get in and out. You can get your pictures, but please leave this room. These is what happened. This is it. These are local pictures. This was up in northern Warren County in '98. How many of you are Western students? Don't know where that's at? Egypt, absolutely. He sat there for about an hour before we kept telling him to come. He swim to us and he wouldn't do it. So we actually had some responders out there to get to it. How many were here in the hailstorm in '98? Okay. If you'll look to the left side of the screen, the vinyl siding on that apartment complex, believe me, all out Scottsville Road, around Ashley Circle, every apartment home will look like that. We had 4,000 roofs destroyed. And when they took off the shingles, we actually had a mound of shingles out at one of the places we delivered that was 20 feet tall and almost 200 feet long. That means it was quite a unique storm. Okay. So my part, please remember, don't get caught up in chaos. Be calm. Your motto, what's the Boy Scout say? Be prepared. have a plan. You with your family, your coworkers, know where you're gonna go, know what you're gonna do to avoid the panic button. So again, that's all I've got. Thank you for your time.
Thank you, Ronnie. Thank you, Keith. Any questions for either one of them? Anybody? All right. Gentlemen, we appreciate it. Very good presentations. Appreciate that. All right. We've got one more before we'll start our panel discussion. And this one, we bring back Joe Sullivan from National Weather Service Louisville and Sam Schamberger from NWS Nashville. They're going to talk about damage surveys after going out after the storm, going out and surveying all the damage. Like Ronnie was showing you some of the pictures. They're going to discuss that. So, Joe.
Thank you, Chris. I don't know where Sam went. He ran as soon as it was his turn to get up here. What I'm going to show you is not a prepared presentation, but it's just a little bit of what we do when we go out. Actually, I'm going to show you a couple different things because what I've got here are a couple of things that we used to do. Now, this is it's interesting that Ronnie just showed the April '98 tornado for Warren County in the hailstorm, because believe it or not, we have no photographs of that storm. My boss my boss John Gordon has said he'll give $20 to anybody to give a picture of this storm, this tornado, because look at that. I mean, it went across 1, 2, 3, 4 counties at F3 tornado. That's a pretty good sized tornado. And then it looks like it recycled as an F2 in Metcalfe County, and then came back as an F3 in Adair County. This is a huge storm. 1998, not that long ago. I mean, my gosh, well, I didn't have a digital camera then, but it's something that would not happen nowadays. But believe it or not, and the path on this, those straight lines, this is actually pretty unusual for a storm or tornado path in 1998 to show that there's a bend in the middle. Because prior to, really just the last couple of years, tornadoes look just like this. In fact, this is a tornado in our official storm database from October of last year. This was in Scott County, up near Stamping Ground, October 7th or 8th. I can't remember the exact date, but did a damage survey. How many of you think the tornadoes are straight lines that are the same width all the way along the line? Anyone? Anyone? Oh, you're right. You want to know what we do now? We actually go out, and thanks to all these wonderful GIS and GPS and G-whatever-us things, now when we're doing our damage surveys, this is what we come up with. We're actually able to go out with a smartphone or a tablet and take pictures of individual buildings, and then we can plot it all in one place here. And I've walked a lot of ground getting this one. And when you put it all together, you think, oh my gosh, this looks like he was drunk walking across here. Well, have you ever seen a tornado, a small tornado, from a video go across? They don't go in straight lines. They're kind of whipping around and stuff like that. And so we're actually able to, when we have good damage indicators, the mouse's battery seems to be dying out now, but we can go in and take a look at these things. And when I plot them and take the photograph and say what it is at the office, or I mean out in the field, instantaneously at the office they're seeing it. And this is so much easier. I can't begin to tell you how much easier it is than going out and driving all day, taking a couple of pictures, tracing on a gazetteer map, and then driving all the way back to the office and sitting down and typing and trying to put out a thing just to get that little straight line with 2 dots and a line in between. So we've come a long way just in the last 10 years in how we do our tornado damage surveys. But what it really boils down to, and what it gets down to, is that this is what we do. We go out after the fact. We don't do it for fun. I mean, if you've ever come across one of the first tornadoes that I had to do a damage survey for in Kentucky was the Super Tuesday outbreak. I was down in Allen County, not too far, a little community called Holland. 4 people died. It's no fun to go someplace the morning after 4 people have lost their lives. So we don't do it for entertainment. But we go out there because we want to figure out what's going on and what's happening. Now, in this particular storm, there were a couple of fatalities. This is from Madison County, up near Richmond in 2009. I want to point out a couple of things, and this is not a talk about the Fujita scale versus the enhanced Fujita scale, but it's the damage survey that particular day highlighted a bunch of things and why we went to the enhanced Fujita scale. These are expensive homes near the Kirkwood subdivision, west-southwest of Richmond. And when I first rolled up that morning, I thought, oh my God, look at this. I mean, we've got huge walls out. And I thought, there's no way that this was anything less than an F2. It's probably an F3 tornado. And then I got out and I was with the county emergency manager and the county building inspector and code enforcement officer. And we started walking around, and what I saw disturbed me. These are the brick fascia walls, the brick veneer rather, around it. You think a brick home is going to be really safe, right? It's better than vinyl and all those other things. Well, here's all the brick and here's all the mortar, and here's what's holding it up against the wall. Nothing. There was nothing holding it up. It was gravity. It was just waiting to fall over. The brick clips, the ties, the brick ties that were supposed to be nailed in and then pulled in between in these lines of bricks were never put in. They were never even nailed in. Sorry, I'm trying to get the mouse down. There we go. There's a whole wall full of bricks with not a single brick tie in there at all. And that's why this wall collapsed. And it didn't take long to figure out that what I was looking at here, the highest I could rate this tornado on a damage survey was an EF1 because the construction was so poor. And I happened to be talking to someone who had some extensive damage, something like this, and I said, who built all these homes? He said, oh, well, there's the builder right down there. He's coming up this way. And I immediately left. I did not want to talk to this guy. Long story short, I did talk with the code enforcement officer, the guy that was in charge of all that. And he said, you know, we can send inspectors out here every day, and they'll throw the clips down on the ground. And then as soon as we walk away, they don't ever put them up. They'll nail a couple in while we're there. But this is just a word to the wise. If you're building at your house or you're having a house built, you know, people like to cut corners. And that's all it took. It wasn't the expense of doing it. It wasn't the expense of the clips. Those things cost like 12 cents a piece. The expense is, you know, you get the time that it takes to do that. And it's a lot easier to just put the bricks up and not do the job. So I did want to point that out. There was a lot of construction there that wall never should have come out. And that's the sort of stuff that we look at when we do our damage surveys. We look to see, was the house properly built? If it wasn't, we have to downgrade the tornado because it doesn't take as much wind to do damage to a poorly built home. And it really wasn't until I got into an older home that was built in the 70s, I think, that I had the evidence that I could write it up as high as I did as an EF3. So anyway, I just wanted to point out some of the stuff that we do when we go out. I did not put together a prepared presentation because I was trying to get everybody else's prepared presentations ready for today. But Sam Schamberger did put together a prepared presentation, and his is going to expand upon this and go on how not only can we take those straight lines that we've drawn, but even after the fact, we can add a little bit of value and thanks to some really cool stuff that modern technology is providing. So Sam Schamberger, a lead forecaster at the national office. Thank you, Joe. All right, so while he gets my presentation loaded up there, like Joe mentioned, one of the things we do at the Weather Service is after every tornado, oh, you can load it. Oh, there we go. All right, so one of the things after every tornado, Ricky, Joe, myself, whoever, someone from one of the National Weather Service offices goes out and surveys the damage from a tornado to determine what? To determine how strong it was, where it began, where it ended, and how wide it was. So we get all that information, put it into the damage assessment toolkit like Joe was talking about. But there are limitations with what we can determine from ground surveys. And I'm going to talk a little bit about what we have done at the NWS office in Nashville using Google Earth. How many of you have ever used Google Earth on your computer? Oh, wow, a bunch of you. It's my favorite nerd tool to use personally. And there's so much cool stuff you can do with Google Earth. But like I mentioned, after every tornado, we go out and survey the damage. The main thing we determine is the EF scale ranking of that tornado, how long the tornado was on the ground, and how wide it was. But like I mentioned, there's limitations with what we can determine from a ground survey. Poor road networks. There's not always a road that goes everywhere a tornado decides to go. Inaccessible areas. There's some places we just can't go. And private property. You know, you may not be allowed to survey in that area. And that can result in inaccurate findings from that tornado. We may not be able to determine where it actually began or ended, or we may miss where it actually reached its peak strength. So we've used Google Earth imagery because you can actually use Google Earth and go back in time and look at aerial imagery from the past and determine where tornadoes have occurred. And we've been able to take that and supplement our ground surveys with that information. And we've found a lot of amazing things from using Google Earth. Google Earth has imagery back as far as the 1990s in some areas. And you can view damage. Like I said, that can be inaccessible to us on the ground with areas with no roads or private land, and really enhances what we can find. And this all goes into the official database for tornadoes, which is called storm data. Have y'all heard of storm data before? Yeah. That's the official record of tornado database. So taking all that, going back and using that Google Earth imagery, it's a great, great tool. Unfortunately, historical imagery in Google Earth is only available in kind of a piecemeal fashion. If any of you have ever gone and looked at the historical imagery in Google Earth, it kind of looks like a patchwork quilt, because it's just taking what imagery is available at that time and put it all together. So some areas might be updated in 2013, some might be updated in 2001. It just varies depending on where you're looking. And unfortunately, sometimes the aerial imagery may not be updated for several months or even years after a particular tornado has occurred. So what happens in that time? Well, people rebuild, the forest regrows, and you may not be able to determine where that tornado actually occurred before. Conversely, some areas receive frequent updates. So typically the urban areas, Louisville, Bowling Green, Nashville, will see more frequent updates in the aerial imagery than rural areas. And with Google Earth, weak tornadoes are much more difficult to find and see, which you can kind of expect that. If you've got a weak tornado, it's not going to cause a lot of damage to be able to be seen from space using a satellite. But if you have a violent tornado, strong or violent tornado, an EF2 to EF5 tornado, you're going to be able to see that pretty clearly from space. It's going to be able to blow down a lot of trees, damage a lot of buildings, and that's going to be able to be seen more easily. And like I mentioned, tornado damage is often quickly repaired. So all these are reasons that there are limitations with the Google Earth imagery. Nevertheless, we've used it as a great tool to supplement a lot of the tornadoes that we've surveyed in Middle Tennessee. So I'm going to go over some examples of some of those tornadoes. First of all, here's a map of some of the historical Google Earth imagery across Middle Tennessee. So what do you notice from that map? See all the squares? There's some areas like, this is, let me see. Yeah, it is dying, Joe, you weren't kidding. Right there is Cookeville, Tennessee. And this is Putnam County right here. This part of Putnam County has 1 year of aerial imagery. This part has another, and this part has another. So if you have a tornado that went from here to here, you may only be able to see bits and pieces of it depending on when that aerial imagery was updated. So that's a problem with this approach. But let's look at some examples. Now, Jennifer this morning, I believe she mentioned the Leap Day tornado outbreak, which was back on February 29th, 2012, and that was a big outbreak in Middle Tennessee as well. It began back in the Plains on February 28th. If any of you remember, there was a tornado that went through downtown Branson, Missouri that day, and then the tornadoes continued into the night across Mississippi River, the Ohio River, and then there were tornadoes all day in Kentucky and Tennessee. She mentioned the Harrisburg, Illinois tornado, but I'm going to focus on some of the tornadoes we had in Middle Tennessee that day. We actually had several tornadoes with 3 fatalities and 7 injuries. So here's the SPC storm reports from this outbreak. You can see it began in Kansas, Nebraska with tornadoes there, and then spread into Missouri, northern Arkansas, western Kentucky, Paducah's area. And then the next day, February 29th, you can see all the tornadoes in Kentucky and middle and eastern Tennessee. Okay, so let's focus on this part of Middle Tennessee. This is eastern Middle Tennessee. If any of you are familiar with the Cumberland Plateau area, this is over east of Cookeville, so we're looking around the Crossville, Tennessee area. This is Cumberland County, Tennessee. And one of the worst tornadoes we had that day was an EF2 tornado in northern Cumberland County. So we're gonna focus on this little community called Rennie up in northern Cumberland County. Okay, so here's some of the Google Earth imagery from that event. So the imagery on the left has not been updated yet, but the imagery on the right was updated after this tornado as of April 2013. So this is a problem with using this approach to supplement tornado surveys. But we were able to see with this imagery, do you see this right here? This is where trees, it's a little hard to see, trees have all been blown down and then logged, forested out after the tornado went through. And if we zoom in on that area, let's see here. This is where we found the original tornado path to be. So my old WCM, Tom Johnstone, he went out and surveyed this tornado. And the farthest they could get is about where that yellow point ends there on the left. So there were no roads that they could access to the east of there. These are all forest roads you can see there on the map. But based on this Google Earth imagery, we actually found the tornado strengthened, widened to nearly a mile in width, and plowed through the forest of northern Cumberland County past where Tom could go. So we're going to take a look at that path here. Yeah, we actually extended the path from 5 miles to 12 miles, doubled the length of the tornado path, widened it from 300 yards to half a mile, but really it was almost a mile wide in some places. And we kept it rated EF2, but based on the tree damage alone, it was almost rated EF3, just from the Google Earth imagery. So let's zoom in on the path here. We're gonna look up this forested area. Can y'all see that? It's a little hard to see, but I think we can zoom in a little more. Let's zoom in on this one particular part. Every single tree was blown down. Tens of thousands of trees in this area were blown down. And typically when you see damage like this, you're talking probably EF3. Unfortunately, there was no structures in this area at all where the tornado hit. So the highest we could rate it confidently was EF2. But this is one of the amazing things we can use from Google Earth to supplement what Joe does and what we do and Ricky does when we survey tornado damage. So we're gonna look at another event. This is a big event in Middle Tennessee as well, also up here in South Central Kentucky, was the January 30th tornado outbreak. And one of the worst tornadoes we had from that event was in Coble, Tennessee. This is a little tiny town in Hickman County, southwest of Nashville. You can see Coble is just a really small little blip here on this highway here. This is the center of town. And here's the Google Earth imagery from after the tornado. So can you see, kind of in this red shaded, there's lighter areas within the forested region there and kind of curves off to the right there. That's where the trees have been blown down from the tornado. You can see that's a pretty substantial path there. But when we actually surveyed it originally, that's what we found. Again, because we couldn't access any of this area to the east of the highway there, or over here between these highways. You know, there's just no way to get there without some sort of helicopter, spaceship, drone, you know, whatever it is that we have available to us. So again, here's a zoomed in area right east of downtown Coble. Almost all the trees, once again, are blown down, and you can even see, can y'all see it in the pattern of the trees there? You can almost see the, whoops, can't go back. There we go. The swirl in the pattern of the trees there, the cyclonic swirl there. And this was a QLCS tornado. You all heard Angie talk about that earlier. These aren't your classic supercell-like tornadoes. You're not going to see a beautiful spiral. You're going to see convergence in the damage on at the northern end of where the damage is, and then kind of a downburst, almost like signature on the south side of that tornado path. But again, this is major, major forest damage, strong EF2 rating, and we determined the tornado is much wider than we initially thought based on the Google Earth imagery. Now, Joe mentioned the Super Tuesday tornado outbreak. You'll remember this, February 5th, 2008. It's hard to believe it's been 7 years since that happened. But this was a major event in Middle Tennessee. We had this long-tracked supercell come out of northern Mississippi, tracked all the way across Middle Tennessee, went right over Nashville, caused massive devastation in Lafayette, Tennessee, with over 20 lives lost, then went and caused a lot of damage in Allen and Cumberland counties in Kentucky as well. But I'm going to focus on some of the damage here to the southwest of Nashville, where we had several long-track tornadoes. So here's Nashville, a big urbanized area here up at the top. I want you to focus here on this forested area to the southwest of Nashville. This is Williamson County, western Williamson County. Here's the city of Franklin, Tennessee. So this was before the Super Tuesday outbreak. Here's after. Do you see that right there? There's almost a straight line cut there in the forest right in the center of that red swath there. Let's see if we can go back again. There's before and after. Can y'all see that? It literally mowed down the forest in this narrow corridor there, and it was heading right for Nashville. And luckily, it lifted right before it got to the homes that are right there. So, but based on the Google Earth imagery, we were able to determine, hey, it even went a little further than we initially thought. So, very, very useful information can be gathered from satellite imagery after tornadoes. And like I mentioned, this can be very beneficial for us, especially in those inaccessible areas we can't get to, rural areas, and can give us even more accurate measurements for path length and width, and possibly even change the EF scale ranking in some cases. Unfortunately, with Google Earth, the aerial imagery is not updated very consistently, so that causes some problems. You saw that patchwork quilt of data, and you still need ground surveys to go out there. We can't tell from space what's happened to all the structures at the ground, so we still need to go out there in person to see what happened to all the buildings. All right, so any questions?
How
Yes, sir. It varies. I would say typically once a year in most cases, but some of the urban areas might be updated more than a few times a year. It just varies.
Do you get any other resource besides Google Earth, National Weather Service satellites or anything like that that would give more immediate, accurate information to you?
There is available through NASA. We can request after major outbreaks, we can request satellite imagery from the day after or the day of, I believe it is, of just our specific region, and they can give us very accurate, almost very high resolution data if we request it. That wasn't available in previous years, but that's available now. Not necessarily, because we'll still, like I mentioned, still need to see what happened to all the buildings really to get an accurate EF scale ranking or F scale ranking depending on the year, and we just can't go back far enough in time to see some of those historical events. It's really just the past few years that we can use using tools like this for that reason. Any other questions? Joe, did you want to add anything? I was going to mention it. We can, and I think you said it, but I was distracted from it. With the Civil Air Patrol, we can do flyovers, but those are expensive, and we generally don't do those for every EF1 tornado that's out there. One of the things that we're really trying to do now, and we've done it a couple of times, I know several offices have. As far as I know, no Weather Service office yet owns a drone, but we have several friends that do, and they've all volunteered to come out. Josh Durkee, who spoke this morning from Western, has a drone, and I used one. Well, actually, the tornado that I showed you up in Scott County near Stamping Ground, I used a drone that was owned by a local firefighter that volunteered his services that day. And it really does help a lot, because what we're doing on the ground cannot, not only is it our roads inaccessible, but sometimes when you go walking off, you might not see anything for a while, because when you run across plowed fields, there's no evidence of anything. Unless it's been a real ground scouring tornado, you think, okay, it's lifted. That's what it looked like happened with the one that was extended because it ended in the middle of an open pasture or field. And you can't see beyond the next quarter of a mile away to the next damage, and just assume that it's gone. We've had cases, we also get volunteer pilots to go up the day after, and we'll send them where we think there might be a flight or might have been some damage. We can't pay them, unfortunately. So it's just if they want to go up and get some hours in their plane, here, while you're up there, check this area out and take a camera, take a couple of shots for us. And we've actually been able to extend links of tornadoes that way as well.
Okay. Any more questions? All right. Let's give Sam a hand. Thank you, Sam. And now we come to the end of our session here, and this is going to be the panel discussion. And you know, we've allotted a lot of time for this, but we probably won't take all of it. It all depends on your questions. So what I need Ricky Shanklin from the National Weather Service office in Paducah, Mike Dossett, the director of Kentucky Emergency Management. I saw him a few minutes ago. There it is. All right, come on down. Bruce Thomas, Midland Radio. Mark Garland, Kentucky Emergency Management Region 1. And Jennifer Rukavina from WPSD. Jennifer went back. She went, oh, she's already gone. Okay. All right. You guys just have a seat wherever you want. And
Kyle Thompson is still here from the Mezzanine if you'd like to ask any Mezzanine questions. We won't make him sit up there if he doesn't want to, but Yeah, if anybody else wants to sit up there, Kevin Deitch is from our offices here, so Kevin, go sit up there.
And then at the very end, those of you that put your name in the very highfalutin box here, we'll draw out for some weather radios.
And Chris, you're supposed to go up there too. So, yeah, that's right. You're on the agenda for being up there. So now I get to run around with the.
You just won't be in the hot seat.
That's right. I get to pass the microphone out to anybody who wants to ask a question. So. Oh, and I did put CBS live streaming on there, so we could actually put the game in the background if you want. So, when I first turned it on, they were both up. But they're on 31-24 at the half, so it is halftime. You know, I have tripped over these little studs in the ground here about 5 times here, but I thought this was great. They have a nice little aisle to walk across here. No, it's just because there's a row of missing seats. So, anybody have a question? Come on, don't be shy. You guys have been really quiet today. And because Chris has been doing most of the emceeing, I haven't been actually going around poking people, but I will poke somebody if they don't ask a question. So, oh, look, I've got 2 people already.
I've got a question, perhaps just a general question. You can bounce back and forth. Where do you see the weather reporting going in the future? We've talked, listened about a lot of app stuff that you can do on personal radio, but do you see more public involvement? That's one of the things I say, watching the weather on TV. People can send pictures and those kinds of things in that are rebroadcast. Where do you see the future of weather going from your different perspectives?
Yeah, I'll answer that from the position of media and television. So much has changed in the 27 years that I've been doing the weather at WVKO, in that it is more, the public is more engaged in helping us tell the story. Because for so long it was, the Weather Service had their thing, and they told their story, they passed the information to us, then we kind of repeat the story or kind of deliver it more on a local scale. But now what I see changing of late is that many of you are helping us tell the story. And that's the difference. Because you are able now with your devices, you're sending us real-time information that we weren't able to get before. It used to be we'd have to wait an hour for an observation to come in, or we would have to wait 15 minutes for a complete radar scan to come in. Now we have real-time radar, we have real-time reports, we have you telling us what's going on, you have you out there sending us pictures and video of what's happening where you are. And so that's totally changing the landscape. Now that's not to say that we're going away. It's just saying that we're having to change how we deliver the weather from the way we did it years ago.
I think a little bit of this is generational. Jennifer Ruccovina was talking a great deal about social media and how important that is and how the numbers in her surveys were increasing. But I see almost a generational divide in the 50, 60 up, the baby boomers, versus, I have kids that are in their teens and how they function. They don't watch television at all. They watch Netflix, or they watch, what they watch. But it's a lot of generational split going on with the new digital age. And it'll be interesting to see where it all ends up. And I'm sure broadcast television is going more towards streaming every day. And we'll eventually see probably as the bandwidth gets better, as Google Fiber gets in more cities, that we'll have more streaming of newscasts on demand, and you won't be watching as much a 6 o'clock newscast as you will be just getting what's being streamed, what you want on demand. So it's a quick changing area in the next 5 years. you know, the smartphone really hasn't been around, but maybe since 2007, 8 timeframe. So things have changed with the tablet, and then we've got Google Glass coming, and we've got other things. The new Apple Watch will be out soon. And so these technologies are going to be game changers. And the fact that you'll be able to, you know, have a GPS on your watch that shows you where you're going, and you'll be able to do a lot of other functions just through your watch will be happening. That comes out to next month. So every year I go to the Consumer Electronics Show in Las Vegas, I get to see a lot of things that are futuristic. And then a few years later, you actually start seeing them places. So it's a new paradigm out there when it comes to communicating. But right now, you still have a lot of people, 50 plus, that are watching the evening newscasts. So, you know, still come home and, you know, turn the TV on. I know my wife does. My wife and I are in our 50s. We watch news, and we still enjoy watching television. But to get our kids to do that's not easy to do.
You know, it is an exciting time. First, I'd like to thank you, because that's where Kentucky Emergency Management gets a lot of our data, our instant data. We get it obviously from our partners with the Weather Service, and I want to thank all five offices. We monitor their conference calls each and every time. We begin hosting our own conference calls for EM managers during the event. But interestingly enough, some of the new developments involve mining social data. And what we have with a partnership with a company called Ezra, and many of you may know Ezra, it's the backbone for global GIS. So there are a number of tools that are available to us now, and they mine the back end of social media. We have access to Facebook, Twitter, Instagram, YouTube, and Flickr. So every time you post, if you're in an area that is impacted, we can pull that data in, and essentially from a state purview, we can set the demarc line of the damaged area. And obviously, Twitter and Facebook, they're unconfirmed sources. But when you have multiple postings of damage, including videos and photos, then we can essentially very quickly plot the demarc line. We can see where most quickly to send resources and where our first responders are going. So it's a very exciting time, and that's one of the ways that we get real-time instant data.
Years where the weather patterns are similar, like, you know, like when you hear Joe Bastardi, he's the long-range weather forecaster, and he's always on the CNN and all that stuff, and he's giving these analog years because he does a lot of research. Are those pretty accurate? Because, you know, for the spring, he kind of gave like 1995, 2003, 2004. Are those pretty accurate to use, the analog years?
I would say in many cases they are not, but we have seen some correlation. Actually, if you look on our website or earlier this week, at least if you did, we compared some past years when we had a winter similar to this. For example, 2002 and 2003, the springs were actually fairly active, but sometimes that doesn't pan out. I mean, we've been looking at, you know, comparable years in the past, and 2 or 3 years it'll pan out pretty good. The next, you know, time that same pattern comes around, it doesn't at all. So I would say use those with much caution. I don't think, you know, we should throw them out the window. I think they're worth looking at, but I think we have to be real careful when we get that type of information out. Take it with a grain of salt for sure.
Yeah, I would concur with what Ricky's saying, in that it's used more on a comparative basis. It's used more to go, well, how does what we're seeing as far as the patterns meet up with years where something similar has happened like this. But I know that Shane and Shane Holiday that works with me at WBKO, we do a lot of that looking back. In fact, there's a website, I can't remember the name of it, but there's a website where you can go and look and try to throw in some of the same parameters of a storm that we're looking at coming in, and look back chronologically as to where it kind of evens out with those similar events from the 70s or 80s. And you can see a similar pattern, but it's like Ricky says, they don't always turn out the same way. So that's where you have to always count for the what ifs and the wherefores when you're trying to forecast these things, that it may not come out exactly the way it happened 20, 30 years ago, but some similarities are going to be there.
I noticed that through some of the presentations, some GIS maps were used, and I was wondering how many of y'all use GIS on a day-to-day basis, and if you do you find it helpful in any way?
I know in Louisville, we're very into GIS. Joe actually showed a little bit of the storm data software that we use when we survey tornadoes, and those points are all GIS based. We also use it, once we have those maps done, we post-process them, and so on our website, we actually have the GIS tracks with all the pictures, with the ratings and everything, and that's through ArcMap that we do that. We also do daily rainfall maps that run through ArcMap as well. So I know Louisville, and it's across the Weather Service everywhere, we use it quite a bit.
Along those same lines, I was at an AMS conference in 2014 in Atlanta, and the Norman, Oklahoma Weather Forecasting Office was trying to implement this plan that they would try to live GIS map or track a tornado track for EMS personnel to get to the areas where they saw the most intense rotation that like fastest. I didn't know if there's a way that you guys could implement that in local offices too.
Yeah, I've not heard anything about that. Certainly would be willing to take a look at it and see exactly what they're doing.
It's more directed toward the Weather Service. You all look at the models and I guess not model variability, but model accuracy as far as what the models put out versus what is actually reported. You know, that day, what was forecasted, 5 to 7 days out, and how accurate those models are, and if so, are there models that seem to perform better during the summer season, winter seasons? Anything that you found out through that research, if it has gone on?
I'll just make a couple of general comments about the model data. You know, it is getting a lot better. I don't think anyone you ask would say anything different than that. But you compare it over a long period of time, a decade ago, or so, especially, we can see great improvements in the model data. And just this year, I think in January, we doubled the capacity of our supercomputers that run the models in Silver Spring, Maryland, and it's going up to. This doesn't mean much to me. Maybe that's some of you computer gurus, but to 5 petaflops this October. So computing capacity for the models increases greatly more. But yes, some of the models do perform better in certain scenarios than other scenarios, whether it be rainfall or certain winter pattern, summer pattern, and we kind of get used to those over time. But then sometimes, right when you expect a certain model to do better, it doesn't. It's another one, maybe the GFS or European or whatever does better. So we're still learning from that, but the good news is the overall is considerably better.
How many meteorology students from Western are here? Okay, you got this guy that I pulled up the last second. Kevin Dutch is a young forecaster in our office. We joke that he still has his mom drop him off because he's too young to drive. But if you're interested in the job in the Weather Service, they're hard to get into now. It's not like when Ricky and I got in. Well, it's sort of like it was. It was tight back then too. But it's there's a lot of competition to get in. So Let me just toss it out to you guys. Who wants to get into the weather service? Here's your time to pick the brain of a guy who did get in. He's a very sharp forecaster too.
How did you get in?
I'm still wondering that myself, but honestly. My trick when I was in high school was area forecast discussions. Are you guys familiar with those? I would read those daily, and there's going to be stuff in there that you don't understand, but then you Google it and you figure it out. And I think that kind of put me a step ahead. AFBs and then the Storm Prediction Center also went in there. I was really interested in severe weather. So they have convective outlooks, and I read those almost daily too. So that kind of got me with the meteorology lingo. That helped me understand models a little bit more, because a lot of forecast discussions talk about models. So that kind of put me, I think, a little step ahead, even before I got into college, of some of my peers. And then once you're in college, just work hard, get involved in anything. I know us at the Weather Service in Louisville, we're still looking for student volunteers this summer. So if you'd like to be interested in that, come talk to me after this. Paducah may have some volunteer slots as well. So just get involved and do well in school. It's probably the two main things I can say.
I don't work for the Weather Service, but I work with the Weather Service. And they have something called the Pathways program now. And that is how you get into the Weather Service as a student through the Pathways program as a junior, maybe a senior, but you can't wait too long. You've got to apply and get accepted into an office in this Pathways program. And it's a fast track to get into the Weather Service. So you familiar with this new title?
Yeah. Yeah, I would encourage likewise. It is a new program. I think it just is getting underway this year, so that would be definitely a good way to get in. One thing I wanted to say too, when you graduate from college, keep an open mind and be flexible. And I'll just give you a little snippet of my story getting into the Weather Service. And that was always my lifelong dream from mid-teens or so on. And I graduated from the University of Wisconsin. And I didn't have a job when I graduated, so I thought, what am I going to do? And I grew up near Hopkinsville, and I thought, somebody said, well, consider broadcasting and go to Western Kentucky University, take a couple of broadcasting classes. And so I did that. I came down here one semester and took some classes after graduating from there. And I never even thought about this, but an entity called the Defense Mapping Agency in Louisville, Kentucky, had an opening for a cartographer position, which I didn't even know I qualified for, but you got a lot of the same coursework, and you all, by virtue of your degree in meteorology, probably, I haven't cross-checked it lately, but probably qualify for that position and several other physical science positions in the federal government. So I say that, keep, again, stay flexible, keep open, get your foot in the door, the pathways, the summer volunteer program, even coming to the weather offices and shadowing for a day or two every now and then, and we do that all the time. We certainly would be happy at our office in Paducah if anybody wants to come and do a shadow shift, a couple days, that kind of thing. So those are a few things I would recommend.
Internships are the very best way to get into anything in life, because you're willing to do it for free because you're passionate about it. Having mentored scores of kids that have gone on to be, leaders in television and also in the Weather Service through my career, I can tell you that these internships where people have passion, like we're talking about going the extra mile, doing things to set you apart, that is what sets you apart. And having that passion where you're willing to do something even if it's for free on the weekends, well, guess what? That's what opens the doors. In television, same thing. In the Weather Service. And again, if you can get it, this Pathways program was the SCEP program. It's just been renamed, and it's funded. And there's like 500 openings coming up in the National Weather Service. They're trying to fill right now. They're starting to fill these, but it's like 500 openings. So there are openings, and there's a lot of people retiring. I hear about people retiring in the upper levels of the Weather Service every day, opening more areas for people to migrate up to WCM and MIC and the SUP positions. And I think the WCM position is amazing. That's where I would be if I was in the Weather Service, hopefully. I mean, that position that gives you a lot of outreach. But if you're into science and technology, the SOOP position's amazing as a science operations officer at the Weather Service office. And MIC is like a manager who manages the office, but the meteorologist in charge doesn't get to forecast that much. They deal more with personnel issues than actually the day-to-day forecast, I think. But I've been told by all my friends that are in these positions. I was lucky enough to be president of the National Weather Association in 2012 and 13, which is actually the organization of the employees of the National Weather Service originally, and then it started allowing broadcasters in, and now it's half, broadcasters. Well, it's a third broadcasters, a third students, and a third NOAA.gov employees that make up the 2,500 to 3,000 members of the NWA. So it's a great organization to be part of. Any of you that are not members of the NWA, I'm going to give them a little plug right now. Please join your local chapter. And then students, for $20, you can join the national chapter. So, and then the meeting will be the 40th anniversary of this National Weather Association that came out of the National Weather Service in 1975. Meeting will be in Oklahoma City, October 18th through the 22nd. It's open to anyone that has a weather interest. You don't have to be a meteorologist to come and participate. And then you'll get a chance to tour the Storm Prediction Center, see the National Weather Center, and interact with people that you'll enjoy. You'll learn more there than you'll learn in the semester at college probably.
Yeah, how many of you Western students are actually interested in going into broadcasting? Good, that's good to see. The thing is that we've always had a relationship with Western, and having a lot of internships and in some cases even having people that end up working for us as their first job in television, in broadcasting, and become broadcast meteorologists. Shane Holliday, who's here. Shane, raise your hand. Shane is an instructor at Western, and so he teaches that combination of meteorology and broadcast. And so that's very critical to you kind of getting your first foot in the door. And since we are considered a small television market here at Bowling Green, we're in between Nashville and Louisville, which are bigger markets, then we're able to take you in and put you right out there as your first job. And so don't ever forget that. Or we can actually, because we know so many people and network with so many people across the country, we know a lot of people, and we can help get you in the door and maybe another town that you would like to be in. So I would encourage you to do all you can and tap into Shane and all of his knowledge and all the people that he knows and learn from him as well.
Yeah, quick question for you. I've seen a growing trend with the news media. It seems like the media is either swinging in one or two different ways, that either they're hyping storms way out of proportion, days or weeks in advance, or they're downplaying storms. And to give you an example to get downplayed, one of the recent winter storms that we had, I was on a conference call with Joe in our local area. They were calling for 12 plus inches of snow. And our local radio station, within hours of that conference call, was advertising 2 inches or less of snowfall for our area. And also, you've got news media that seems to be giving some really, really bad advice to people. For instance, in Oklahoma during one of the more Oklahoma tornadoes, where they were telling people to get out of the area if you can, which created a situation where hundreds of people could have lost their life if the tornado had continued. Is there any movement within the weather community itself to try to curtail some of this, to try to get a handle on it?
Yeah, I don't know if you really want to know my feelings because I'm liable to say some colorful words here, but I went to the National Weather Association, the 39th meeting, which was in Salt Lake City, and Bruce and I were there, and we heard a lot of this. Hype casting is what I call it. There's a lot of clickbait that goes on in social media. There are people who I call posers. They get on social media simply to create hype. They post a lot of colorful maps. They'll take one model out of all the dozens of models that are out there, They'll post the one that shows the most snowfall or the worst weather and put it out there. This is going to happen. And it gets everybody worked up and they share it, and then it goes viral, and then there's nothing you can do to stop it. But here's the thing that we're seeing. I'll even take issue with our own network, ABC. There are times, and Shane and Christy know this, when I'm sitting there just about to just put my fist through a wall, because there are millions are being affected, and it came without warning, and all this other kind of, what in the world are they doing? And all it is just they're doing it to raise your fear level so you'll watch. That's simply all it's about. And I take issue with it. I hate it. I wish there was something I could do about it to change it. But unfortunately, news has gone from being news to infotainment. And that's the real problem. But the people, unfortunately, they eat it up because it raises your emotions, it raises your fear level, and therefore you're going to stay tuned in. And we hear it all the time. Well, so-and-so said it was going to do this. Why aren't you saying it? Well, we're not saying it because what they're saying is poppycock. I was trying to find a nice word, you know. Yeah, and it is a lot of times they're taking what could be a worst case scenario and then just throwing it out there in hopes that you will stay with their network and stay with their coverage. Oh, we'll see you all the way through this. We'll put our reporters out there in 5 feet of water and the wind blowing their hair and all over the place. And oh, look, we're out there in the dangerous weather for you. And I'm like, just shut up and get back in the studio. Because it's ridiculous. And I am sorry that that's happening, but unfortunately, we're all kind of taking it on the chin because there are people out there that just want to glorify all this, and they're really muddying the message. I know Bruce wants to say something.
Well, I was really going to talk more about what you were talking about in Oklahoma City, like the El Reno tornadoes, what you're talking about, and the meteorologist at the NBC station went on and told people, because of the size of the tornado, they needed to get in their cars and get away if they did not have a safe room. And that caused a firestorm for his career. And I can tell you, I was a meteorologist on television for 20 years in Texas and Kansas. And I've dealt with some horrible tornadoes that killed a lot of people. And one specifically in 1997 was an F5. And it happened May of 1997, just after the movie Twister came out. And it was the first F5 in America in 10 years. And we told people to take cover in their homes and shelter in their bathrooms. And, there's a real slow moving tornado in the middle of the afternoon. People went home to cover. An F5 took everything down to the slab, took the linoleum and the plumbing, and it just took the roads away, literally. So what he was saying in his mind was the right thing he felt at that time. And his name's Mike Morgan, and I don't need to defend Mike. Mike can defend himself very well, but it was a judgment thing, and he didn't cause a traffic jam. It was already 6 o'clock on a Friday afternoon in Oklahoma City. You know what I mean? It was already bad. But, sometimes in the heat of battle, you make judgment calls and say things that maybe people can be critical of, and maybe it wasn't the right call at that time. But if that tornado had just stayed on track, it was going to downtown Oklahoma City, and right in the middle of rush hour on a Friday afternoon, Friday 6 o'clock. It was a horrendous storm. I mean, it caught storm chasers off guard. We lost three of the most passionate storm researchers and chasers in America were lost during that storm, and a couple of the other ones just barely got away. I was talking to one of the guys about it who was there when it happened, and said that if he had not had a V8 in his vehicle, he would have been dead, because he said it was sucking him back into the tornado. And the three that were killed were in a Cobalt with a 4-cylinder engine because they were trying to save gas. So those of you out spotting storms or chasing storms, have a V8, have a powerful engine. it makes a difference when you're really in a bad situation to get away. And he told me he had his Chevy Avalanche floored to the floor. It was going 40 miles an hour, trying to get out of in the updraft into the Arctic. So, you know, it's these little things that happen in a situation in Oklahoma City like that. It's easy to point fingers, but I will tell you, I never tell people to stay in structures anymore that could be unsafe. I tell people to drive away from the storms. So unless you have a safe room, and because we don't know it's an F5 until after the storm. You know, there is some new technology we're seeing today with dual pole. Angie was sharing that with us about dual polarization radar, where we're now being able to maybe detect this might be an F3 or F4, F5 based on how high it's throwing the debris up into the atmosphere. But basically, you don't know how strong that tornado is a lot of times until afterwards, until the surveys are done, a lot of times by people like Ricky. Well, I tell you, 95% of the people at the Weather Channel never go out in the field. Okay, is that right, Paul? We got Paul here. He spent once in your career, Paul. There's your answer to the Weather Channel there. That's you have to volunteer most likely for that. Is that true? So just don't volunteer to go out. It is thrilling, but it's a lot of, it's like a MIC up in Louisville. John Gordon told me, he goes, it's like, he was a fairly accomplished hurricane hunter, flew into Hurricane Katrina. It was one of his last hurricanes. And he told me it's 12 hours of boredom and 30 minutes of sheer exhilaration, flying in and out of an eye of a hurricane. But, he volunteered to be a hurricane hunter in the Air Force. But after the 2005 hurricane season, he retired from being a hurricane hunter. And well, stay in the studio because the temperatures in the studios are pretty constant. They're usually really cold because they have to keep them extremely cold in the studio, usually in the 60s because of the lighting. And, start out going to school and then become a weather producer and work your way in. We got another question.
I was just going to make a comment back to the question we had over there, and like Chris was saying, as far as the one person putting something out there and blowing things let out of proportion. I'm trying to get the citizens of my county to think about doing the multi-level information again with the weather radios and our broadcasters, WBKO and the area National Weather Service. That's the best way to combat, I think, the issue of blowing things out of proportion. And it kind of brings us back around to what we're talking about here, is doing the multi-level ways of getting our information. And that's what I'm trying to do with my county, to get the citizens to understand, don't just rely on one thing.
And that's a great comment. And if I would, I'd like to follow up just one moment on that. We recently had a significant event across Kentucky in terms of the state agency. Kentucky Emergency Management watched it from beginning to end, where the point at where the resources are coordinated. And there was some very, what I consider inappropriate reporting on the I-25, I-65 issue. And a lot of the responders, or many of the responders, some are actually here today. And I think what got left out, in addition to all the hype, was they left out the true story of the folks at the local level. They didn't show the citizens on four-wheelers. They didn't show our county EMs out there with all of your personnel. They didn't show your personnel handing out snacks and water and trying to do everything you could. The unfortunate hype was people are stranded, and they've been stranded for many hours. You know, that's an unfortunate occurrence. It's happened in many, many states. In this particular state, and our meteorologist can tell you, it was the culmination of a perfect storm in the middle of the night that made that occur. But I think that's one of the things that need to be highlighted. The exceptional outpouring that came from the local support and the local EMs and the local citizens that helped solve that problem.
In the presentation today, I've seen a lot about the April 16th, 98 storm, and I don't know if Shane was there yet. Were you there yet, Shane?
I didn't come along until fall.
Jason Lindsay did a great science presentation earlier, was there. We were on the air live in that storm. But one of the things I remember, like it was yesterday, was that there were hundreds of students out on the football field. I think they were doing Greek activities that day. And you know, the sky was getting pitch black. We were on the air live trying to get the word out. And everybody knew that a bad storm was coming, but nobody really seemed to care. And it wasn't until the outdoor warning signs were activated, then everybody starts to run. You know, so I guess I've always been a big proponent of the outdoor sirens. You know, there's no question they get attention, maybe even more so than other forms of warning. And but yeah, we hear them downplayed. You know, the EM directors, the media, they're kind of wanting to push people away from that form of warning.
Well, I can speak to the initial installation of those sirens here in Warren County. They were up and tested and running only 2 weeks before the April 16th, 98 event. And Ronnie Pearson from Warren County, we worked closely together. We had a whole team of people, including the judge executive, that worked on that project to get it up and running. I mean, we didn't know when we had them up and running that there was going to be an April 16th, 98. But that event happened 2 weeks later, and we got stacks of letters from people thanking the county and everybody involved for putting those sirens out there. Now, I can also speak to what you're saying about, there's been a lot of talk about just don't depend on sirens. And that's some good advice. And even from the get-go, and when we started putting these up and we started the education process of, listen, you know, we call ours COWS. We would put the stickers on them, make them look like, you know, COWS, Community Outdoor Warning Sirens, the acronym COWS. And that was for an education process to also get kids involved in it and teach them to not be afraid of the sirens, and then even help educate some of the parents. And there was a lot of going to the schools and just making sure everybody understood that these were sirens, not like you remember the old sirens, you know, waiting for World War III or Russia to come in and start bombing. You know, that's sirens were thought of at that time like that. These were sirens, though, to be put up in conjunction with all the other ways that you can receive warnings, which now number over 24. So what we're saying, we're not saying anything negative about the sirens. What we're saying is you need to use them in the right way. Because when we put them up, and we're still fighting this, people say, I can't hear those sirens. I'm sitting in my living room watching TV and I can't hear that siren and it's 2 miles down the road. Well, no, you're not supposed to. People think, there are people that have that misconception that the sirens have been placed in their community or down the street for their benefit if they're sitting in their house with the air going, the TV going, kids playing in the house. That's not what they're for. They are only designed for people that are already outdoors. And that is the farmers working in the field, kids are at the ballpark, anybody that's outdoors and mowing the lawn or just doing anything outdoors. That's to tell them the danger is coming so they will get indoors and find out what the danger is. So that's where the misconception is coming in. And then we had the event that happened in Alabama in 2011. in Tuscaloosa, Birmingham. They had a double whammy. That first event came through severe thunderstorms, tornado warnings. Unfortunately, that first round that day, and I hear James Spann talk about this, and I just get chills up my back. As he talked about how that first round of storms came by that day, knocked out a ton of power, unfortunately took out the power to a lot of those outdoor warning sirens. Unfortunately, there was a lot of people who thought, well, if anything else happens, the sirens will go off. When that second and more powerful wave of storms came by that afternoon and evening and did the most destruction, the sirens didn't go off and 350 people lost their lives. Not all of them from the sirens, but from what they gathered from the information when they did the surveys afterwards, they found that a lot of people were waiting for the sirens to go off again, and they never did. So that's why we're telling people, yes, use the sirens for what they're used for, but don't just wait on the siren sound itself to tell you that you're in danger, because that could cost you your life.
Oh, I want to address that siren issue real quickly. It sounds like the sirens did exactly what they were meant to do. What you were saying was an activity on the ball field on campus, and people took cover. So they work. I love sirens. I'm a big advocate of sirens, and I'm in the weather radio business. I think you need both. I think you really do need both. Now, from the emergency management standpoint, the sirens are very expensive to maintain, and that's a problem. As Emory Kidd said earlier, that to do this whole countywide, it costs $4 billion to put sirens up. So you just hit them into the highly populated areas and parks and places where people were likely to be outside, and supplement with weather radio throughout the community. But you know, sirens are a great thing to have, especially in areas that have a lot of people outdoors. It's another level and another layer in what we're trying to do and get that warning process out. Got 5 minutes? Oh, this gentleman here? Oh, okay.
Okay, thank you. I know the purpose of Weather Ready Nation. There was a story that came out that I saw just recently, earlier this month out of Missouri, where they're, I guess this came from a WCM there from the Weather Service, that they're really giving consideration to not doing a statewide tornado test anymore. And, you know, I kind of quote from an article from Fox News that says, I don't think that'll be the last this year, but we need to start discussion to continue doing these in terms of what are we really testing? Are we really adequately testing all the various methods that these warnings go out on? I don't think we are, because we don't really have any method of tracking these to see who is doing what. I'm sure with the Weather Service and media, have you guys seen an increase in people just saying, you know, why are we doing this still nowadays? I'm just curious how that makes you guys feel.
I'll jump on this one.
Yeah.
And several years ago, I worked with in Central Region headquarters, I worked with a guy that invented the same code very credibly. And I agree with him 100% that the only way that you can test the system is to use the actual codes, et cetera, to make sure that it does what it does. But because of things that have changed through the years, now we have to notify the broadcasters as much as possible so that they're getting a code. We actually delayed ours in Kentucky this year because we had so much that was going on when we originally planned it. And we didn't want anyone thinking it was something other than the real thing. And I've started to think that maybe it is time to stop using the real code to go out and do that, because there are so many things that key off of this, and the problem is that they aren't getting the entire message. It'll trigger phones, it will trigger, and actually it didn't trigger phones because the new commercial mobile alerting system, wireless emergency alerts, knows that it's a code or a test, so nobody received that. So it's not even a viable test for that system that was just introduced 2 years ago. When it comes to really the only thing that was tested was weather radios, which we already test once a week. So if you haven't received your weekly test, you know that your weather radio wasn't working. The other thing that it tests is the emergency alert system. But the TV stations don't want to break into their broadcasting because that's money with a test. And those that do, that let the crawls go across, and the whether they're cable or whatever, if they don't have the audio of the weather radio saying this is a test, this is a test, this is a test, there is nothing in the crawl that says it's a test. Now, if you're hard of hearing, if you're otherwise disabled, you can't hear, and you only see tornado warning for these counties, then and it's raining outside, even though it was just a light rain like we had this past week when we tested ours, then, I mean, you can cause undue panic. And you don't even have to be hard of hearing. When we did our test one year, one of our forecasters was in a restaurant, and it was noisy. It was one of those sports bars things, and it was noisy, and all of a sudden she sees crawling across the TV screen, tornado warning. And it was another day. We test our system in March, and guess what happens in March in Kentucky? It's gray, it's cloudy, and if you're not paying attention to the weather, all of a sudden you see tornado warning, you think it's for real. So I've actually changed my mind in the last couple of years to think that maybe we should use the real code going out, because we're testing the systems. The EAS is tested on a monthly basis, and the weather radio is on a weekly basis. So that's my soapbox. Oh, schools are required to do it twice a year now. It doesn't necessarily have to be with ours. Yeah, you have a question.
Hey, Joe, I'd like to follow up on that just a little bit, but kind of turn it around and ask you all the question. First, how many of you think the tornado drill is necessary, period? Do we need to have it, that it helps in some way? Okay, it looks like that's the majority. Then the other issue is, Joe mentioned, the TOR code that we use for weather radio, for EAS. It doesn't, for example, it does not activate your cell phones, the WEA, the WEA chip. It does no good with that because we send it out to our computer system as a test product. And so it doesn't activate that and other things. It does activate the weather radio, whereas the weekly test, it's generally more passive where you just get a light lit up on it. So, but it does actually audibly activate the weather radio. How many of you think the tornado drill is necessary for that? Okay, I just see a few hands. So most of you think the tornado drill is not necessary to activate your weather radio. Okay, case closed.
Okay, I have two things. Going off the statewide tornado drill, I'm a student at U of L, and I was at the gym there, and I didn't even realize it was a statewide tornado drill until I saw Twitter afterwards. And I asked one of the students who worked there, just out of curiosity, what do you guys do for tornado preparedness? And she didn't know. So I had to talk to somebody else, and he was, I guess, the director, whoever was in charge at that time. And he just assured me that they had a plan in place and that it would work. And I said, well, the point of this is to practice it, is to go through with it. And he said, oh, well, it's not worth taking the time out to do all that. So that was frustrating. And then going back to the siren thing, the county that I grew up in Minnesota, they would set off the sirens for anything. Didn't matter what it was. So people just started ignoring the sirens, and it just didn't matter.
Yeah, we still, even here in Kentucky, I know that there are some communities that will set off their siren, they call it the dinner bell. At 12 noon, they'll set it off every day, and that's, oh, it's time for lunch. And I'm thinking, well, what if something's happening really, for real? Like a storm happens to come in at 12 noon. Is it lunch or is it the storm? So I'm like, unfortunately, and Joe and I have talked about this many, many, many times, that there is not a standard that's set for sirens. And they leave it up to the individual communities and the individual municipalities to set those rules and regs as far as when they set them off and when they don't set them off. And so unfortunately, it's like a great thing to have, but again, if it's not used in the right way, and then more importantly, the residents and the community doesn't understand what they're there for, then they're really of no use.
I have two questions. My first question is
A lot of people don't pay attention to the second season severe weather, October, November, sometimes even in August, like the Plainfield tornado of August 28, 1990, Veterans Day outbreak of 2002, and stuff like that. And a lot of people don't actually know about a lot of that stuff. December 16th, 2000, Tuscaloosa. And then my second other question is Torcon, Dr. Greg Forbes from the Weather Channel, is Torcon useful for helping predict conditions for tornadoes? Like, you know, if we were to get a Torcon for central Kentucky for a 10, that would be 100% chance of tornadoes across areas around Lexington, Louisville, and pretty much all of central Kentucky.
Well, I'll answer the last question, then I'll pass it on to these guys for the first part. Torcon is, I guess, for the Weather Channel, that's a great thing. But we actually tried something similar to that at our station, and we found it caused more confusion than anything, because some people say, is today a 3 or is it a 7? And I'm like, all right, we tried it, we thought it would work, but it's not working. What we're keeping an emphasis on is awareness and preparedness, and we're trying to show what the possible threats could be. Instead of throwing out a number, we're just going to keep it to be prepared for anything, and then that way you're covered. So if it doesn't happen like is predicted, then you're prepared for the next time when the storms come in. We'd rather focus more on preparedness than for, hey, today is a 3, or today is a 7, or a 9, or whatever. I mean, that may be fine for the Weather Channel, and if they've done the research and it works for them, that's fine, but it just doesn't work for us on the local level.
As far as, I guess, the first part of your question, secondary season, that's part of the Weather Ready Nation initiative, is to be weather ready all times of the year. And, you know, and that's where you guys come in, emergency management, a lot of the partners with the Weather Service is to keep awareness high, you know, even if it is supposed to be snowing because it's December, but really it's 65 degrees and there's tornadoes nearby. So, you know, that's what Weather Ready Nation aims to do, is to be weather aware in any season.
Yeah, and you bring up a good point about the fall season. The next to the last EF4 we had in our region from the Paducah office was in September. The last F5 was in December. Our most deadly tornado in the last quarter century was in November 6, 2005. That was the Evansville tornado. So we need to all do all we can. We talk about the Weather Ready Nation ambassadors. You know, really all of you here in a sense are a Weather Ready Nation ambassador. We need to take that message, that preparedness message of the fall tornadoes as well as the rest of the year, and be sure people are aware of that. And we try to stress that. We do a campaign in late September each year across the West to bring awareness to the fall peak that we have in tornadoes. And we just need to get the word out there. We're passionate about it, but we do definitely, we need to do more education than we've done already, because there's a lot of people that they just aren't in the mindset. And I think that's one reason that we see more casualties per tornado, if you will, in the fall than we do in the spring. It's because of that awareness level not being quite what it is, you know, what we have in the spring.
I want to go back and talk about the Torcon index a little bit, because, you know, that index, well, first Dr. Forbes came here and spoke. It's been about 4 or 5 years ago, but he came right here to Bowling Green and spoke at the weather, the Kentucky Weather Workshop that was here. And I had the privilege of driving him back to the airport in Nashville. I got to pick his brain a little bit. He actually worked on the team that developed the Fujita scale. He was a graduate student under Dr. Fujita at the University of Chicago. He was a professor at Penn State University for 20 plus years. The man really knows what he's doing. So if Dr. Forbes says there's a high risk of tornadoes, it's a good thing. to pay attention to that, because he truly is good. But even the Storm Prediction Center this year upped their categories. They used to only have 3 categories: SPC, Storm Prediction Center, where most spotters and storm chasers and people like myself go every day during storm season and start the morning reading their discussion. That's spc.noaa.gov if some of you don't know where that is. But they've changed their criteria. It used to be slight, moderate, high, and now they've added marginal and enhanced, then slight,
Marginal, slight, enhanced, moderate.
and then high. So they changed it to 5 categories, and so the Weather Channel's got 10. So I think they're all trying to do the same thing, is get the information out to people and try to be more, just have another tool to enhance that, get the message out. And that's not to storm chasers, and that's to the general public. People tune into the Weather Channel because they need weather information. So I always like to hear what the Torcon is on a really high day. I like to know what he's thinking, because when they get together and put that information out, it's helpful to know, the situational awareness is very important, especially when there's a lot going on out there. It's just another tool. So I'm not a big fan of naming winter storms on the Weather Channel. That was one of the things that they're trying to make winter storms like hurricanes by naming them, kind of deal, trying to make them have a life of their own. Like you say Hurricane Katrina, everybody knows what that was. But you say Winter Storm Nemo, and it sounds like a Disney movie to me. But I just have to say that public once. Okay? I'm gonna hand the mic off real quick.
I don't see any hands up for questions, so I'm going to ask a question. How many of you, the students, again, I mentioned once before, pointing out Kevin up there, the job market is tough when you come out of college right now for all fields, but especially for meteorology, because it's really saturated compared to what it was back when Ricky and I got our degrees way back when in the Stone Ages. But one area that I think it's really going to start going toward, and might not be what those of you who are interested in television are hearing. Correct me if I'm wrong, Paul or Chris or Christy. Have you seen some of the information about virtual TV weathercasters that's been out there? I know that one of the Louisville TV meteorologists, Jeremy Campbell, posted something out about a year and a half ago in Broadcast Magazine, where why pay 5 meteorologists at this station when you can just, with a click of a button, change from a male to a female to anyone that you want, providing the weather. So I think that's going to be limiting some of the career fields here. But one area that I haven't seen that's been tapped yet is going into emergency management. We've had a few forecasters or meteorologists that have volunteered at our office that are interested in the emergency management route. And to the point of even one student up at Ball State is getting a master's degree in applied geosciences and their applications, emergency management. So I would just want to toss that out to you as well, and throw Mike Dawson on, throw him under the bus, or let him answer some questions. I know that they don't have dedicated positions there, but as Ricky was talking about, when he started out with the Defense Mapping Agency, start out in another field, and you never know where it could take. So I'll let Mike speak to anything that he might think when it comes to the future of meteorologists in emergency management.
I think the opportunity for collaboration is always there. I just returned from a meeting at NEMA, which is the National Association of Emergency Managers in DC, and that topic does come up. Quite frankly, it's always a matter of funding, and agencies typically need more people out in the field. I would love to have an in-house meteorologist sitting right in my AOC, but failing that, I have Joe Sullivan, and he's much better.
What I suggested this, it was not to get rid of me. But it was more along the lines of not being a dedicated forecaster for emergency management, but I work very closely with emergency managers. And the more more that there's meteorologists in the field that are doing emergency management, not just doing meteorology for emergency. So what I was sort of leaning toward. for those of you that may be struggling in a year or two to find a job somewhere, there are classes and some of them are even free, and you can take those things. If you really want to help your communities by keeping them safe in dangerous weather, that's exactly what the emergency managers that are in this room are doing 24/7. Just have to learn a little bit about hazmat. You have to learn a little bit about Al-Qaeda or ISIS or whatever the other things, the dangers are, because those are the many dangers that emergency managers do deal with.
I was just going to comment, Joe, in the future, there may be more of a need for, in the private sector. Private sector utilities are all across the country. And it is this weather and the effects of weather are very important to our business, period. And we're seeing more and more utilities come on board with sophisticated meteorologists that can understand the types of things that you all have been talking about today. And right there in Louisville, you've got UPS, it's got a very sophisticated forecasting arm there because of that airport. So I would suggest that you look in the private sector too, because there may be some real opportunities in the future.
Yeah, I think the opportunities for pure meteorology, pure forecasters are there's limited. So I think the message is expand your horizons and look for some branches. Did I see a question back here? I saw someone raise their hand. No? Okay.
Joe, I had one more thing to say to that. Arkansas Tech University over in Russellville, Arkansas, has a professional master's degree in emergency management. I'm one of the speakers there. It's April 8th and 9th. They're doing a conference. And a meteorologist from Mississippi State, she graduated from there with her BS, and then she's now getting a master's degree in emergency management. So there is opportunity for meteorologists to cross into emergency management. My friend here, Emory Kidd, is a chemist, studied chemistry and biology in college. So there's these degrees that you can morph into other things. When I went into meteorology, I didn't know I would be in consumer electronics, but that's where I ended up, 30 years in. So if you have great degrees, they're very hard to get, a lot of science in there, a lot of hard work, but you can always morph those into different things. And I've had several interns that now work for Epic Software in Madison, Wisconsin. They do medical software because they were really good at writing software and computer science. Once they finished their meteorology degrees, they took jobs there because the opportunity to make a lot of money and live in a cool city was there. So it doesn't have to be
when bad weather hits Madison, the people at their offices know what's going on because these guys have meteorology degrees.
That's right. They can give a good forecast.
All right.
I was just going to add one more thing, just for the students out there. Of course, I'm one of the managers in the National Weather Service office, and just to kind of give you an idea, to emphasize everything that they've been talking about, I think over 300 students applied for, there were about a handful of intern jobs in the Weather Service, like 20 or 22. Well over 300 applied for them, only 140, 150 made the panel. And of course, 22 were selected, and most of them had at least master's degrees. So that's just when there's a hiring freeze in the Weather Service, it really affects the chances of students getting in, which is super unfortunate. But as Ricky was saying earlier, and everybody keep an open mind, try and network, volunteer, do everything you can possible to set yourself apart from everybody else. And then you'll eventually get your foot in the door, but you have to work really hard.
I was going to add something to that. We actually did have a Western student several years ago that just because he wanted in so bad, he actually applied that offices people probably would not be applying to. So in the Weather Service, you cannot be afraid to move. Most of us, in order to move up, will have to move out somewhere else. We had somebody apply to Alaska, Caribbean, Maine. And he got to spend his summers when he was in school as an intern, or at that time as a SCEP, in Maine or in Alaska. I mean, you can't really beat that. So if you're applying, don't always go for those big city jobs. There's plenty of offices around the country. They're great offices. They may not be in a big town. Jackson's one of those places. We probably don't get a lot of applicants compared to Nashville, but it's a great office, so don't be afraid to move. Explore the country, you're young, do it. So if you are trying to get in, go for Alaska, go for Caribou, Maine, go for the places that people wouldn't think to apply to.
All right, good advice. Thank you. We're going to wrap it up here, and the last thing we'll do is we'll draw for weather radios. So